Good morning. Welcome from the National Library of Medicine, the National Institutes of Health. My name is Jeff Resnick. I'm chief of the NLM's History of Medicine Division. On behalf of the Office of the NLM Director, I have the great privilege of offering these welcome words and moderating today's proceedings. I also have the great privilege of thanking our co-sponsor, the Friends of the National Library of Medicine, the FNLM. The Friends are indeed wonderful friends of our institution, and we are very grateful to each and every one of them, and especially to their board of directors. I also wish to thank the outstanding media and communications team here at the NLM and at the NIH for their time and their talent dedicated to this very special program. And of course, my NLM colleagues and I thank you for joining us today, all of you from near and far, for the annual NLM Lindbergh King Lecture, which is part of our scientific symposium, Science, Society, and the Legacy of Donald A.B. Lindbergh, MD. One housekeeping note, you will see a live feedback button under your video stream. If you have a question during the course of our proceedings or a comment, please use this button and send it to us. Now let's begin. I'm going to turn things over to my colleague, Jerry Sheehan, who will get us started with welcome remarks on this very exciting day. Jerry, over to you.
Thank you very much, Jeff, and hello and welcome to everyone. It's great to see so many people joining us for today's event. My name is Jerry Sheehan. I'm the Deputy Director of the National Library of Medicine for Policy and External Affairs, and I am honored and privileged to welcome you to the 4th Annual Lindbergh King Lecture and Scientific Symposium. This lecture series was established in 2015 as a forum to bring together insights on the current state and the future of bioinformatics and pathobiology, and convey them to a broad scientific and public audience. Today's Lindbergh King Lecture honors the legacy and contributions of the namesakes of the lecture series, former NLM Director Donald A.B. Lindbergh, and former NLM Deputy Director for Research and Education, Dr. Donald West King. I am sure that they, like many of us, would have wished that we could gather for today's event in person. But knowing Dr. Lindbergh is the leader who first brought computers into the library and arguably brought libraries into the world of computing, it seems altogether fitting and proper to honor the legacy of Drs. Lindbergh and King, even in this virtual forum today. And thank you for doing so. I am pleased that we have a diverse lineup of speakers, and as well so many of you in the audience who are here with us today to help us honor the legacies of the great Drs. Lindbergh and King. And I thank you all for joining what is sure to be an enjoyable, exciting, and interesting day. It's now my pleasure to introduce the first among today's distinguished list of speakers, Dr. Heidi Rehm. Dr. Rehm is the Chief Genomics Officer at the Center for Genomic Medicine and the Department of Medicine at Massachusetts General Hospital. She also has the distinction of serving as the chair of the NLM Board of Regents. Welcome, Dr. Rehm. I'll turn over to you.
Thank you, Jerry. It's my distinct pleasure to welcome everybody to today's scientific symposium on science, society, and the legacy of Donald Lindbergh. We just have an outstanding lineup of sessions and speakers, and I'm sure you're all going to enjoy the whole day. But before we kick things off, a few of us will make some introductory remarks, and I just wanted to share some personal perspectives as we think about the legacy of Donald Lindbergh. He directed the NLM for over 30 years and made a major and lasting impact on biomedical science in that period. He extensively engaged his Board of Regents, and I'm very delighted to be on that board and chairing it this year. And he also engaged many outside constituent groups to ensure that NLM would provide important and useful services to the community. Today, we take for granted that we have PubMed and other basic tools at our disposal, but it was actually Dr. Lindbergh who established many of these tools and made sure, importantly, that they were freely available to the community. And also near and dear to my heart is his work in establishing NCBI, the National Center for Biotechnology Information, which has provided data, storage, access, annotation resources to the genomics community for many years. And I did want to share, one example of the important role of Dr. Lindberg's work and his establishment of NCBI, and that is the launch of the ClinVar database. And any of you who know me know just how near and dear that database is to my heart. So a little history: about 10 years ago, a group of clinical laboratory geneticists, including myself, were working to develop a database to share classified variants that we were generating in our labs, and we really recognized we needed to all come together. Unfortunately, our first endeavor to create such a database and get buy-in to contribute to it was actually unsuccessful. But then we discovered that NCBI was thinking about creating a variant database of this sort. And so we abandoned our first approach and partnered with NCBI to provide input to the development of ClinVar with the NCBI team, so it would fit our needs, and we worked to support it as the location for all of the clinical labs to share their data. This time, the effort took off, and now, as many of you know, ClinVar has become the go-to place for not only US labs, but actually the world to share classified variants. And I actually credit the reputation of NCBI as a trusted resource for long-term sustainability of key genomic resources, as well as the ability to remain free from commercial bias, as the key to the success of ClinVar when we were not able to do that through another endeavor before that. And in fact, the voluntary willingness of commercial labs and other submitters to willingly share their data in ClinVar for no strings attached access by the broader community really is a testament to the reputation of NCBI and what has been built. And indeed, ClinVar has become a core resource for both clinical and research applications of human genetics, and has contributed to the accurate diagnosis of millions of patients receiving genetic testing every year. It's just a wonderful success story. I'm sure that my colleagues and other speakers today will include their own stories of the many lasting impacts that Dr. Lindberg has had on our field. But with that, I will turn it over to our next speaker. Thank you very much for joining us today.
Great. Thank you for those remarks, Dr. Riemann, for getting us started today. Jeff Resnick, I'm going to turn back to you for the rest of the program.
Thank you, Jerry, and thanks indeed, Dr. Ream. Now it's my pleasure to introduce Glenn P. Campbell, who for more than a decade has served masterfully as chair of the Friends of the National Library of Medicine, the FNLM. Most recently, Glenn was managing director for the British Medical Journal, the BMJ, in the Americas. And prior to his time with the BMJ, he was executive vice president for global medical research at Elsevier, where he had publishing responsibility for more than 420 journals in the health sciences, more than half of which were published in partnership with society. Welcome to you, Glenn, and thanks for joining us today.
Thanks, Jeff.
Sure.
And thank you, Dr. Ream and Jerry, for the kind words of introduction. And on behalf of Dr. Redman, Barbara Redman, our president, and the board of directors of the Friends of the National Library of Medicine, and all friends of the National Library of Medicine, it's my pleasure and an honor to welcome you as well to the 2022 Lindbergh King Lecture and the Scientific Symposium, The Legacy of Dr. Donald A.B. Lindbergh. The Friends are pleased to co-sponsor the annual Lindbergh King Lecture once again with our friends and distinguished colleagues of the American Medical Informatics Association, and we're particularly enthusiastic to hear from Dr. Kohan, whose passion for using data and new tools to accelerate the clinical application of biomedical research was shared by Dr. Lindbergh and Dr. King. We are pleased as well to join with our colleagues at the National Library of Medicine to sponsor today's scientific symposium on Dr. King's legacy. Dr. Lindbergh's legacy. Dr. Lindbergh was a great communicator, a candid and caring person in his exchanges with every individual, an active listener and a lifelong learner with a wry sense of humor. His impact on the public health is for one who was highly valued measurable outcomes immeasurable. And incorporating this year's King Lindbergh Lecture into the Scientific Symposium on the Legacy of Dr. Lindbergh provides the opportunity to hear from those whose leadership today in biomedical informatics, leadership training, and library research builds on his groundbreaking work. Over the 30+ years that Dr. Lindberg was director of the NLM, he transformed the library from a passive to active player in delivering improved healthcare outcomes. Today, his successor, the cheerfully dynamic Dr. Brennan, and her leadership team recognize Dr. Lindberg's legacy as the library evolves as a center of biomedical discovery and data-powered health. The Friends are very grateful and appreciative of Jeff Resnick and everyone at the library and AMIA, as well as today's speakers and presenters, for their tremendous efforts to ensure that today's event will be an engaging and thrilling one. Thank you.
Thank you, Glenn. And thanks again to you and everyone on the board of the Friends of the National Library of Medicine. Now it's my distinct pleasure to introduce Dr. Gretchen Purcell Jackson, President and Chair of the Board of Directors for the American Medical Informatics Association, AMIA. Also Vice President and Scientific Medical Officer at Intuitive Surgical, and Associate Professor of Surgery, Pediatrics, and Biomedical Informatics at the Vanderbilt University Medical Center. Dr. Jackson is an internationally recognized biomedical informatician and accomplished clinical surgeon with over 30 years of contributions to informatics research and surgical science. In her current position at Intuitive Surgical, Dr. Jackson is a healthcare technology executive focused on scientific strategy, and she practices pediatric surgery at Vanderbilt Children's Hospital. Welcome to you, Dr. Jackson. Thanks for joining us today. Over to you.
Good morning. Thank you so much. I am so grateful for this opportunity to speak at this National Library of Medicine Symposium, honoring the legacy of Dr. Donald A.B. Lindberg. I am not only the board chair for the American Medical Informatics Association, but also a grateful former recipient of a National Library of Medicine pre-doctoral fellowship, which supported my biomedical informatics training and PhD research at Stanford University. I am honored today to speak on behalf of the American Medical Informatics Association, or AMIA, which I am sure, as most of you know, is the leading scientific health informatics professional organization in the United States. And it's really an important part of Dr. Lindberg's legacy. AMIA now represents over 5,000 biomedical and health informatics professionals who work across academics, industry, health systems, nonprofits, and government. And AMIA now hosts 3 well-attended scientific meetings each year, including the Informatics Summit, focused on bio and clinical research informatics, the Clinical Informatics Meeting, and of course, the annual symposium in November. Some of the most important of Dr. Lindberg's contributions to informatics were his organization in the development of scientific activities and professional societies, which supported the growth and evolution of our field. And I will speak briefly about these contributions to conferences and professional organizations to review this piece of history. So as many of you know, in 1977, Dr. Lindberg presented at the first Symposium on Computer Applications in Medical Care, or SCAMSI, which then was a local meeting in the Washington, D.C. area of engineers, scientists, and clinicians who met to discuss scientific, but clinically relevant papers at the intersection of computers and medicine. The first proceedings of SCAMSI was published by IEEE, and it featured 67 papers, and the meeting hosted 250 attendees with no concurrent sessions. Dr. Lindberg attended this meeting regularly as interest increased, and he was recruited to the first board of directors as the first member from outside of Washington when SCAMSI was legally incorporated and began to attract a national and international audience. This meeting rapidly evolved with the introduction of posters, parallel tracks, panels, tutorials, system demonstrations, and the student paper competition within 5 years. In 1987, the chairman, Daniel Harris, noted that just reading the scientific work was not enough. You had to be there for the informal conversations in the hallways that often led to significant collaborations and innovations. And this was certainly my experience when I attended my first SCAMSI meeting as a student in 1991. And at that time, Dr. Lindbergh was the president of AMIA. AMIA, as we know it today, came from the convergence of professional societies and conferences, and Dr. Lindbergh played a key role in each component. At the 1982 SCAMC meeting, Morris Collin hosted a small meeting of informatics leaders, including Dr. Lindbergh, to propose the creation of the American College of Medical Informatics, or ACME. ACME elected its first class of fellows in 1985 and subsequently incorporated. ACME Fellowship remains one of the highest honors one can receive for substantive and sustained contributions to the field of informatics. Now, in the early 1980s, the American Association for Medical Systems and Informatics, AMSI, emerged as the leading professional organization for computer systems and medical care as a result of the merger of the Society for Computer Medicine and the Society for Advanced Medical Systems. AMSI held its own scientific meeting in the spring, usually on the West Coast, so as not to conflict with SCAMC, and Dr. Lindbergh served on the board of AMSI in the mid-1980s. By the late 1980s, the overlap of the interest and the leaderships across AMSI, SCAMC, and ACME was substantial, and their three boards agreed that a merger to create a single organization would be in the best interest of all. Dr. Lindbergh was selected as the founding president of this new organization, the American Medical Informatics Association, which was legally incorporated in 1990. ACME became a self-governing entity as part of AMIA, and AMSI was dissolved. The annual meeting of AMIA was called SCAMC for the first 5 years after this merger, and in 1987 became the AMIA Annual Symposium. Now, Dr. Lindbergh's contributions to AMIA during his tenure as president included the creation of the ACME retreats, AMIA's committees, the professional specialty groups, which are now known as working groups, and the executive director role, as well as direction to the publications committee to create a new journal, which eventually became the Journal of the American Medical Informatics Association, our flagship journal. This wonderful history of AMIA and Dr. Lindbergh's central roles are described in this publication shown on this slide, authored by Jan van Bemmel, Marion Baum, and Ted Shortliff. Dr. Lindbergh led the evolution of medical informatics societies in meetings not only in the United States, but also globally. The International Medical Informatics Association, IMIA, was created in 1967, and Dr. Lindbergh served as the US representative to IMIA for the American Federation of Information Processing Societies, AFIPS, in the 1980s. Dr. Lindbergh also served as the chair of the organizing committee for IMIA's 1986 international meeting, MedInfo, which took place in Washington, D.C. When MedInfo returned to the United States in 2004 in San Francisco, Dr. Lindbergh personally arranged for the NLM's Fogarty International Center to provide support for attendees from third world countries. As the current board chair for AMIA, which has been my professional home for 3 decades, and the scientific program chair for the 2022 AMIA Annual Symposium in Washington, D.C., I am so grateful for the contributions of Dr. Lindbergh to informatics societies and scientific forums, which are only a teeny tiny piece of Dr. Lindbergh's legacy. I thank you all again for the opportunity to provide opening remarks for this symposium, and I hope you will enjoy the day as much as I will.
Thank you, Dr. Jackson. Fantastic history lesson and much to learn there and to explore. Thank you very, very much. It's now my pleasure to introduce Shannon Jones, who is Director of Libraries for the Medical University of South Carolina Libraries in Charleston. She is also Director for Region 2 of the Network of the National Library of Medicine. A longtime volunteer for the Medical Library Association, or MLA, Shannon currently serves as President of the association. In 2018, Shannon co-founded the MLA Reads Virtual Book Discussion Club to provide a forum where participants can learn, discuss, and process the implications of a variety of DEI topics on their work as information professionals and in their personal lives. She is also co-editor of Diversity and Inclusion in Libraries, a call to action and strategies for success, as well as the forthcoming volume entitled Cultural Humility in Libraries. Shannon Jones, welcome, and thank you for joining us today to represent the Medical Library Association.
Thank you, and good morning, everyone. I bring you greetings from Charleston, South Carolina. I am both humbled and honored to welcome each of you to the Lindbergh King Lecture and Scientific Symposium on behalf of the nearly 3,000 health information professionals that comprise the Medical Library Association, or as we affectionately call it, MLA. As an association, the MLA community believes that quality information is essential for improved health. We aspire to be the association of the most visible, valued, and trusted health information experts. And most importantly, we strive to enhance the quality of healthcare, education, and research in our environments. Since 2003, to honor Dr. Lindbergh's legacy, MLA awards the Lindbergh Research Fellowship annually, aimed at expanding the research knowledge base, linking the information services provided by librarians to improve healthcare and advances in biomedical research. For 30 years, Dr. Lindbergh supported the mission and goals of the Medical Library Association and was a strong champion and advocate for health sciences librarians throughout the nation and the world. I'm one of those librarians who benefited from Dr. Lindbergh's leadership, service, and advocacy. So 20 years ago today, I arrived in Bethesda at NLM for my first day as a member of the 2002 cohort of NLM Associate Fellows. At NLM, I launched my career as a health sciences librarian. I met some wonderful professionals. I had the opportunity to participate in meaningful projects, and I was exposed to tools and good information that have made the journey to standing before you today an amazing ride. In Dr. Lindbergh's 2004 oral history posted to the MLA website, and you all should go and check it out, Dr. Lindbergh mentions that he learned two things at Amherst College. One was a love for biology, and the other was the thrill of discovery. I share in this love. I too love discovering new things, new information, and new concepts, which is what I'm most excited about today. I hope today's program and the speakers who will come before you evoke the same sentiment for you. I also hope that you discover new information that will enhance your professional journey. A sincere thanks to the program organizers for the invitation to join today, and to each of you, I say welcome to the program.
Thank you very much, Shannon. It's a privilege to have you here and appreciate your welcome remarks tremendously. It is a day of discovery, and you could not have framed that more beautifully. Thank you. It's now my pleasure to introduce Kent Smith, who will introduce our keynote speaker for today. Kent Smith was Deputy Director of the National Library of Medicine from 1980 till 2004, and previous to that was also Director of Administration at the NLM for 8 years. As deputy, he was responsible for program development and evaluation, policy formulation, and coordination of library activities. Notably, he served as president of the National Federation of Advanced Information Services and also of the International Committee on Scientific and Technical Information. Ken Smith, welcome, and thank you for joining us today. Over to you.
Thanks. Thank you for the introduction, Jeff. You know, it's a real pleasure to be part of this year's lecture and symposium that has been established, as you know, in the honor of Don Lindbergh and Don King. You know, Dr. King was also a key member of the NLM family. He was a noted scholar, a great pathologist, a lover of medical history, and really a wonderful, kind, and most generous colleague. And of course, it is a particular pleasure to be here to celebrate the legacy of Donald A.B. Lindbergh, a man I had the honor and privilege of working beside during his first 20 years as the NLM director. He was a brilliant man, a born leader, and one who brought with him a clear vision as to how to provide better and wider access to biomedical information, not only for the benefit of the nation's health professionals, but also the general public. His leadership and motivating skills created a team that brought success and realized his vision that he stated early on when he arrived. And so it seems totally appropriate, as we remember Dawn, that our keynote speaker today is also a very successful visionary in medical science. Dr. Isaac Cohen is the Marion V. Nelson Professor of Biomedical Informatics at the Harvard Medical School, chair of its Department of Biomedical Informatics, and is the Associate Professor of Medicine at the Brigham and Women's Hospital. And some of you may also be interested in knowing that he previously had been the director of the Countway Medical Library at Harvard. Now, I'm going to tell you right up front that I will not try to cover all of his honors and accomplishments contained in his 66-page CV, but just highlight a few of them. He began his formal education at the International School of Geneva, Switzerland. He received with honors his Bachelor of Science in Biology from Brown University and his MD and PhD from Boston University, including some doctoral work, I might add, with the Clinical Decision-Making Group at the MIT Lab for Computer Science. Now, he has published well over 500 papers in the medical literature and is the author of the widely used book entitled Microarrays for an Integrative Genomics. He is a distinguished member of the Institute for Medicine, the American Society for Clinical Investigation, and of course, the American College of Medical Informatics. And Dr. Cohen's effort have been driven by his vision of what biomedical researchers could do to find new cures and deliver the best patient care. As Dr. William Tierney put it, and I quote from him, Dr. Cohen has revolutionized many areas of biomedical informatics and has changed the way we practice patient care delivery. That statement actually was made when Dr. Cohen was awarded the prestigious Morris F. Cullen Award of Excellence from the American College of Medical Informatics. With this recognition, one could say, perhaps, that he completed the AMIA trifecta, having also received the William Stead Award for Thought Leadership in Informatics and the Donald A.B. Lindbergh Award for Innovation in Informatics. Highlight amongst many of his accomplishments is his initiative in translating genomic research into the clinical environment. Its name sort of brings back sort of that essence of the George Lucas Star Wars, as it's called I2B2, or Informatics for Integrating Biology and the Bedside. I2B2 provides sort of a technical solution to informatics exchange across institutions and is now a standard component of hundreds of analytic projects throughout the world. In Dr. Patty Brennan's Musings from the Mezzanine, I learned that Dr. Cohen has a little motto called, "Make our data work for us." Data, our speaker said, and I quote from him, "It means that let's not just use it for the real reason most of it is accumulated at present, which is in order to satisfy administrative or reimbursement process, but instead, let's use it to improve healthcare." So folks, I'm pleased to present to you from way up there in God's country, our distinguished keynote speaker, Dr. Isaac Cohen.
Thank you, Dr. Smith. What a remarkable introduction. It's in the can. I will now use that recording for all future introductions. Thank you. That was wonderful. I am so honored to be the keynote speaker today, and truly gratified because Dr. Lindbergh, Don, was an oversized figure in my entire career. And I'm going to say it now just because I'm going to otherwise forget it. I do want to thank everybody who's participated in this program, from Jeff Resnick, all the public participants, the Friends of National Library of Medicine, the National Library of Medicine, all our colleagues for making this moment possible. It is indeed frustrating and sad that we have not been able to come together for 2 years. And this is, I think, a first step towards remediating some of that disturbing trend. So I would like to say first off that Dr. Lindberg really embodied what those of us who trained in pediatrics like to say is the most important part of teaching, which is modeling. He modeled for us what leaders looked like in biomedicine, period. As Dr. Smith said, he was a born leader. I don't know if he was a born leader, but by the time I met him, he was without a doubt a leader and a statesman. And he showed how to be a leader, not just in the modern sense of visionary and brashness, but also in dealing with a complex ecosystem, which at times can be frustrating. As I'll touch upon, he really drove innovations that have transformed so many parts of medicine, but it was not all smooth sailing. And less of a statesman, less of a leader may have gone frustrated and said things that might have actually impeded further progress. But at least in his public face, he was always calm, steadfast, and optimistic. He would say wry jokes about some of the obstacles, but he would not actually let civility falter at any point. And in that respect, I think we are all reminded what leadership looks like. And although I fail often, I use this moment to remind myself of what that looks like. So without further ado, let's just start the keynote. So in thinking about what I wanted to say about Don Lindberg, there was a recurrent theme in all my discussions with him. And frankly, in much of the programs that he funded, including some of my own grants. And that was in making information and knowledge get distributed out, not only to doctors, but to patients. And although I will not make up this point later on, Dr. Ream pointed out about ClinVar, an important resource for both clinical labs and doctors throughout the world. But Dr. Lindberg also sponsored the Genetic Home Reference, which was a genetics reference specifically targeted towards consumers, understanding two things. A, unfortunately, that most doctors don't know enough genetics to be able to explain it well to patients. And second of all, that patients deserve and can profit personally in their health by understanding genetics better. And so I decided that the theme I would address, although there could have been many other themes and many other dimensions of Dr. Lindberg's accomplishments, the theme I would explore was who will be the primary purveyor of authoritative medical knowledge to the US patient. And I will outline Dr. Lindberg's contributions, which are very impressive. I don't think I am taking anything away to say that Dr. Lindberg's work has been very successful, but it's not completed, and he'd want us to continue pushing forward in the direction he started us. And I will articulate some of the gap. And then I will close by putting down my bets, my chips as to where the future lies. And I have the conceit, which I think is based somewhat on facts, that Dr. Lindberg would agree with the way I have laid down my chips, if only because he inspired many of my prejudices in that regard. So let me just tell you what the themes I'm going to address are. First of all, what are the necessary ingredients to having this information and data go towards patients? First of all, there has to be mechanisms of sharing, mechanisms of data and knowledge sharing, and a culture of data sharing, a culture that begets trust and more data sharing. There has to be transparency and accountability. And we tend to forget about the accountability part of it, but having people not only share data, but follow up, have the theories been proven, have the hypotheses been tested, and going to that full cycle in the scientific discovery cycle. The other theme is optimism and innovation, that there is a continued opportunity for all of us to advance medicine and biomedical science because of the ingenuity of the human spirit, especially as embodied in America by the National Library of Medicine at the NIH. The other is scientific skepticism, which is not to accept all theories from the beginning as being God's word. And in fact, assuming very much in the spirit of science that most theories will, in the best of worlds, be proven to be approximate and will have to be refined. Very importantly, that data, actual data, the raw data, are so crucial to actually distinguishing truth from fiction, hypotheses from well-founded science. Finally, again, I do not think I am taking anything from Dr. Lindberg. In fact, I know he was proud about the fact that his success lay in finding superb colleagues to take his vision and translate it into what ultimately became success. And that includes colleagues such as Dr. Smith, colleagues such as Dr. King, colleagues such as Dr. Humphreys, colleagues such as Dr. McRae, who I mentioned their names now, and I have missed others, and apologies for all of you, but these were colleagues and are colleagues of Dr. King, who made several of the projects, I should say, and David Lippman, several of his projects that I will appropriately credit to his leadership actually come to fruition. And so part of his inspiration and genius was finding the right colleagues to actually do the trusted job of actually moving forward. So I put the slide here to remind me to make the following statement. I think there is a risk that we forget how crucial academic and scientific leaders in biomedicine. And I am reminded by the fact that the current director of the National Library of Medicine is a doctor and a nursing professional, that perhaps I should have used the word health professional rather than doctors, but nonetheless, in this slide, it's doctors, that doctors can and should lead in this vision of innovation and scientific discovery, and that we should not only defer to individuals who have perhaps training in business and commerce, but do not understand some of the underlying goals and science of the biomedical enterprise. And so you see here Dr. Lindberg, and although we're not going to talk about it today. Dr. Lindbergh was also a pioneer, for example, in artificial intelligence. He created the AI room expert system that did expert diagnosis of rheumatological disorders. And that tells me that there's plenty of precedent for doctors leading efforts in knowledge discovery and artificial intelligence. And we should encourage more doctors to be in that role. Shown also there on the left of the screen is Dr. Octo Barnett, a colleague of Don's at Massachusetts General Hospital, who along with 4 MIT undergraduates built the MUMPS system that now underlies most of the electronic health record systems in the world, including Epic, for example. And that huge innovation back in the 1960s, mind you, was led by doctors leading undergraduates from MIT. And I do think this model can and should be emulated, because these individuals have many of the concerns that the healthcare system and patients need to have. And just parenthetically, we see Randy Miller back there in the background, who's also has been a leader in many aspects of biomedical informatics, but also a pioneer in artificial intelligence. I think that for the younger folks on this call, it's important that we remind ourselves the world that we lived in when Dr. Lindbergh took the helm of the National Library of Medicine. Unfortunately, I am old enough so that I can remember what that world looked like. So in 1984, I was a third-year medical student, and when I wanted to search medical literature, I had 2 options. One is to look at these books that had indexes of all the published literature, Index Medicus, or I could see something very priestly and remote looking, librarians typing into a terminal that linked to Medline that would, in some arcane query language, return the articles that were up to date on the queries that we, rounding on patients, needed to have. That's where it was. You had to be part of a medical school or have access to this paid Medline's, this paid service that accessed Medline. Trials were shrouded in mystery. A trial would be started by an academic center or a company, and sometimes the primary endpoint would be met, would not be met. And either the secondary endpoint would be substituted as the headline of the publication. You really couldn't track it. And so all bets were off when something was published. Was that original hypothesis that was tested, or was this just a hypothesis that survived multiple hypothesis testing after the primary hypotheses failed? That's where we were in clinical trials. And did patients have access to their medical records? No. In theory, in some abstract legalistic sense, maybe they did. But probably the most glaring example of, and amusing example of the fact that they had no access to the record is a Seinfeld skit where Elaine essentially gets blacklisted by her doctors for daring to ask her doctor what exactly was written in the record. There was no such access. And that meant, among other things, that incorrect assessments of the patient, just mistakes, would go on for decades uncorrected. data was not shared. You'd have a scientific discovery, a genomic sequence discovered in one place, not shared with any other center unless you had a special relationship or a friendship or a material transfer agreement. Incredible delays, therefore, in the progress of science. But paradoxically, and we'll get back to this, trust and expertise was at a maximum. I would actually like to hypothesize that the reason this trust was so high was because everything was so opaque. People did not know what was going on underneath the hood, and therefore pronouncements could go essentially unchallenged because the underlying data, the underlying knowledge was not broadly available. But nonetheless, this is the fact that the trust and expertise is now at historical lows, as I will describe, is a challenge that we must face. And I think if you had predicted this back in 1984, people would be confused by this apparently paradoxical effect. So let's enter the multiple dimensions of Dr. Lindbergh's success. So instead of a few individuals fortunate to have accounts with commercial services accessing Medline, Medline became a free service open to the public, and then the web got wrapped around it in PubMed. And what you see here is the exponential rise of the data available through PubMed and the NCBI. And if you look on the y-axis to the right, you see the millions of users per day. So it's phenomenal, millions of users per day. But I think among the most cheering aspects of these millions of users a day is different surveys have shown that between 25 to 50% of those users are not institutional researchers. They're educators, they're the public. And so there's been this huge efflorescence of data sharing, of information sharing that previously did not exist back in 1984. And this was because of Dr. Lindbergh's direct investments in these programs and picking the leaders to bring forward these efforts. This also pertains to the growth of sharing of genomic data, so that again, GenBank, then within NCBI, demonstrated that there was enormous synergies, not multiplicative, but exponential synergies by having sharing, so that you could now discover through simple search all the variants discovered so far and find out, did your patient have that variant? What is the consequence on protein function of a change in a DNA sequence? And this spread to all the other kinds of high throughput measurements that the genomic and post-genomic revolution have led to. And these did not happen by accident. These were specific programs that had to be fought for in budgetary allocations through Congress that Dr. Lindbergh and his colleagues advocated for and succeeded to do. But it was by no means assured of success. Next, there was really no communities of information sharing, even within academic campuses. That would be the medical library, the medical school, the hospitals. And because this program is no longer present, but you probably don't know the acronym, IAIMS, Integrated Advanced Information Management Systems. These were generous grants that were led out of the National Library of Medicine that allowed the integration of data across these academic health centers and sometimes community health centers in a way that created a culture of sharing, a culture of democratization of data that had not existed. So again, we take this for granted now, but it took specific programs to generate. In 1984, there was a babble of a variety of terminologies that described pathological samples, that described billing codes, that described terms to index journals. And each of those had their own vocabularies, and yet they were describing different parts of the elephant, different parts of the biomedical research knowledge base. But they were not immediately comparable. If someone had described everything in SNOMED, the pathology language, you could not say if it was anything like the thing that had been described in MESH, the terminology for journals. And some of the vocabularies were not only not linked to these other vocabularies, but they were proprietary. You'd have to pay money to access them. And so in a far-reaching effort, Dr. Lindberg got both funding and the political alignment to allow these different vocabularies to be put together into the Unified Medical Language System, led by many, including leaders such as Dr. Humphreys on this Zoom, to provide a tool that is now used all the time to actually compare and align data generated from all these different systems. I mentioned before the obscure state of trials in 1984. It was a significant act of political leadership to convince Congress that despite their constituencies from pharmaceutical companies and other research organizations in various states, it was in the public interest for trials to be registered ahead of time so that the primary endpoints that the trial was intended to test were made explicit before the trial was run. And then to have journals adopt those standards so that our leading journals, medical journals, would require registration in clinicaltrials.gov before a trial was published. All that we take for granted. And with leadership of Dr. Lindberg and Dr. McCrae, this act of political and technical leadership actually happened. I should also point out that patients use clinicaltrials.org all the time to find out when they have, unfortunately, an advanced cancer or a rare disease. Is there a study out there anywhere that actually studies this disease that they can, and what is its enrollment status? Can they enroll in it? It's been used extremely broadly in ways that were never previously thought of. I put this last, but it could end up being the most impactful work of Dr. Lindberg. He was absolutely convinced, not least of all because of his early work in artificial intelligence, that clinical data had to be available in electronic format and had to be widely shareable and ultimately had to be in the control of patients. And with his patients, statesman-like patients, which I described at the beginning, he funded a multiple set of initiatives from a early 1990s electronic health record initiative that actually ended up being the first grant I ever got from the NIH, all the way through to efforts I'll describe later. Not only was it personally important to me because I was involved in some of these efforts and was funded by the National Library of Medicine, but it really led, as I hope I will convince you, to a transformation of the way electronic health record data is shared and disseminated. So let's talk about that first grant that I got. The first grant that I got was a U1 through the National Library of Medicine. And it was part of this vision that Dr. Lindbergh had of data sharing through electronic health records. So electronic health records already existed by that time. Again, I mentioned that they already were around in the 1960s due to visionaries like Dr. Barnett. But the RFA asked for ways to share across institutions, and I proposed back in 1995, I believe, a mechanism to share data using something that at the time was completely novel, the World Wide Web. And what we proposed was to share data across healthcare institutions. And working with Octo Barnett and Charlie Safran and others with funding for the National Library of Medicine, which by the way, was key to my career development. Harvard sometimes runs a very Darwinian system, which is if you don't get funded, you are, as they say, history. So through this grant, we actually had running in 1996, as published in this SCAMSI article, SCAMSI being that conference that Gretchen just referenced. We had running in 1996 a program that in real time accessed data at the Beth Israel, at Children's Hospital, and at MGH, so that in real time you can see if the patient had been seen at any one of those institutions, and if they had been seen at multiple institutions, data would be collated on the fly to create a history of that patient. Many subsequent developments turned that into programs that others used. Beth Israel integrated multiple healthcare systems around that technology, but also the various regional data aggregation efforts that were implemented under President Obama's HITECH Act used that on-the-fly integration approach. At the same time, something rather bizarre and at the time impudent was also funded by the National Library of Medicine, something called the Personal Inter-Network Notary and Guardian. This is work that I did with my thesis, also with my former thesis advisor, Professor Peter Solovich of MIT. He had previously described in a project called the Guardian Angel Project that was funded by ARPA, a mechanism for having computational agents safeguarding patients' health. And I said the first step is to actually have a patient control of that data. And in fact, what we did was we actually showed how we could actually use simple web pages to encrypt this XML formatted data of the patient that had been extracted out of electronic health record systems, and that this data would then be under patient control and could be shared with others for research and for clinical care. And this ended up being this effort funded by the National Library of Medicine ended up being the progenitor of multiple projects, some of them the somewhat ill-fated Health Vault and Google Health efforts of the 1990s, but ultimately led to its intellectual descendant, which I'll get to, which is the personally controlled Apple Health record that now accesses over 800 academic health centers and provides patients control over their own data. The early work that I just described led to many other large projects, actually not funded by the National Library of Medicine, but were direct users of technology that had been funded by the National Library of Medicine. So for example, a cross United States pathology data sharing network called the Shared Pathology Informatics Network, funded by the National Cancer Institute, was a direct use repurposing of the code base that we'd actually developed for the W3 EMRS system that I described at the beginning. Under the CTSA, we demonstrated and actually used and published several studies that crossed whole academic health centers that use this distributed sharing mechanism that we had first demonstrated through that first grant that I got through the National Library of Medicine, but that was definitely following the script written in the RFA that National Library of Medicine had written. And an important point of all these efforts is that in these distributed queries, and I think this is something that we're going to revisit in spades in the coming years, is given the fact that it is unlikely for reasons of privacy, property, and culture that we're not going to be able to generate one huge planetary database of all patients, that we're going to have distributed queries that allows us to have a statistically well-grounded aperçu of health. The understanding that distributed queries allow us to create the paradigmatic, the whole is greater than the sum of the parts results. And this, again, thanks to the National Library of Medicine's funding, was amply demonstrated. The kind words of Dr. Smith referenced the I2B2, and yes, that did. I'm sure when we came up with the name, R2D2 wasn't too far from our thinking, but informatics for integrating biology in the bedside. This was a collection of open source modules that allowed us to liberate the data in a multiplicity of different vendors' electronic health record systems, so that for the first time, academics, quality improvement researchers, and genomicists could actually access data from the healthcare system and analyze it. This system, because it was free and open source and funded, by the way, people think of it because it was funded under the NCBC Office of Director program of Dr. Zerhouni, think of it as just a Office of Director program. In fact, the National Library of Medicine stepped in specifically to support the I2B2 project and added their own budget to it in order to fulfill what they saw as a realization of their own vision. And what we showed was the following, and we showed it in multiple studies, that if you merely used the samples that were drawn every day out of patients, shown here on the x-axis is time in weeks, so this is weeks, and on the x-axis is, on the y-axis is number of patients. And we showed that just in one healthcare system, you could accumulate thousands of samples per year for common diseases like depression or rheumatoid arthritis and link them to their clinical characterizations in the electronic health record, allowing us to do genomic studies at literally 1% of the cost and 100 times the speed of the old school method of taking decades to accumulate a cohort. And I think this inspired many other efforts to use healthcare systems as living laboratories for genomic discovery research, where we use both the biomaterials of our patients with their consent and the electronic health record phenotyping or clinical characterization to drive and accelerate research. I have to note parenthetically that many of us as patients assumed that the healthcare system was doing this all along, was learning with every new patient. Of course, that's not true, but this really helped drive for many healthcare systems, drive that realization forward. I show this diagram that my colleague and collaborator, Ken Mandel, actually generated to show a interesting outcome of that early investment in the personal internetwork notary and guardian, the PING project that I told you about, a patient's control of the electronic health record. And because we had developed those technologies, we were very prepared in 2009 when President Obama had announced the HITECH Act to actually propose in the New England Journal of Medicine the somewhat impertinent suggestion, well, why can't health IT be more like the iPhone, If I don't like my camera app, or I don't like my mapping app, I can download a new one and substitute it. Not so for a order entry system where I have to replace the whole EHR system. So we asked, why couldn't there not be such a modularity? And the government actually supported that question by investing in us as part of the ONC's, the Office of National Coordinators funding under President Obama's direction of these strategic initiatives. And that led to something called the Smart on Fire project. This is a project that's created an application programmer interface that was independent of the underlying electronic health record vendor. It was adopted by multiple electronic health record vendors, including the leading ones, so that you could have a common access point to data. And in a great example of doctors leading the charge in the sense of Dr. Lindberg and Dr. Barnett, we had two doctors, Dr. Josh Mandel, now at Microsoft, and Dr. Ricky Bloomfeld, now at Apple Computer, who actually led the migration of that initial API into a common standard, that it was now part of the 21st Century Cures Act that Congress passed, and that Apple made part of its Apple Health technology stack, so that now today patients can access through their iPhones their data from over 800 hospitals and growing of thousands. And there is, for the Android platform, a similar effort going forward, so that we already have tens of millions of Americans who can access their data, their labs, their medications, their procedures in ways that were previously not possible. And this is under their control, and they can actually choose to share the data with others. So that's a pretty long reach for efforts that Dr. Lindberg started back in the 1990s, and it's just the beginning. I mentioned that trust was at an all-time high back when Dr. Lindberg started his leadership of the National Library of Medicine. Unfortunately, there's been a collapse of trust in expertise and leadership across multiple domains. And I want to point out that even before COVID, way before COVID, this study done in 2013 in the JAMA Internal Medicine, I found very surprising at the time, but it ended up being predictive. And this was a study looking at how consumers perceived favorably or unfavorably different users of their data. And I don't think we would be surprised to hear that because of their history with the healthcare system, African Americans, for example, were less trusting of various users of their data than those of European origin. But what was surprising was that across all ethnicities, there was a high degree of trust of the doctors using the data. And not surprisingly, there was a large amount of distrust of commercial use by drug companies or insurance companies of the data. But what surprised me was that public health was also seen as a less trusted user of their data, of patient data, than the doctors. And I think that's a problem that we have to deal with. And this problem only got accentuated by the pandemic. And the leadership of the CDC has acknowledged that we have a problem here. And they have undertaken a massive rethinking of how we communicate and how we present data so that we can actually restore confidence. And I do believe that we will see historically that we went from high confidence in the 1980s to low confidence currently. But as we develop along the path that Dr. Lindberg laid out for us, better access to the primary data, allowing a rich ecosystem of reinterpretation or reanalysis, that there's going to be a regrowth of the faith and the expertise and in data-driven analyses. So what is the way forward? How do we go from here? So one path is clearly just starting, which is the CDC is really revisiting how it looks at the aggregate of data for public health as gathered from various healthcare systems. And by the way, as a point of pride, I want to point out that those of you who have used QR codes in various states, from Massachusetts to California, documenting your vaccination, are actually using Smart and Fire technology that, again, Apple, Microsoft, and others helped push into the public domain. There is another alternative which may happen and looks like it's happening, which is large data companies are going to step in. And this is a news story about Amazon acquiring One Medical, a large healthcare distributed concierge-like healthcare system. So now Amazon, in addition to having access to the widgets and movies that you buy, will also, for a certain group of patients, know a lot about their healthcare status. Amazon also has pharmacies in several of its Whole Food stores, and also has a pharmaceutical delivery service. And they also have a polypill service that a recent New England Journal of Medicine, talking about a different polypill, show has been very effective actually in reducing disease. So caution to the academic health centers or commercial or community health care centers. The notion of the power of data enabling better decision-making is not restricted to just the conventional healthcare system, but large data players who've already figured out how to commoditize and add value to individuals' data are jumping into the fray. Apple Computer similarly has jumped in the fray. I have to say they have an impressive model of privacy where any data that I described in the Apple Health record is actually not accessible to them or searchable by them. It remains only under patient control. Google has many important efforts in the space and multiple relationships with large healthcare systems to help them apply knowledge discovery and clinical management to these large databases that they have developed. There is an alternative model, one I happen to like a lot, which is Consumer Reports. Consumer Reports is a nonprofit agency, and they have really only one customer, the consumer, and they rate various household or automotive products and give you some sense of the best dollar performance trade-off. Would we be so lucky to have a comparison of all the checkpoint inhibitors in such a fashion, or of all the heart medications? Wouldn't it be great to see which one give you the best efficacy? Now, unfortunately, Consumer Reports does not have that role, does not see itself taking on that role. The FDA, unfortunately, also doesn't see itself taking on that role. It validates drugs as meeting its endpoints, but it's not running a Consumer Reports-like function, and where it's looking at how do we compare the top 10 cancer drugs. That's not in the FDA's remit, although they do a fine job of evaluating individual agents and devices under the terms of the trials that clinicaltrials.gov specify. The National Library of Medicine actually does a pretty good job of providing, through access from clinicaltrials.gov to the literature of trials, to the literature of basic science, to the actual underlying data, provides access to all of those data and permits a multiplicity of private, nonprofit, and commercial efforts to try to make sense of that for the consumer. But it does not actually do that job of synthesizing all that data for the individual. It has chosen not to for a variety of reasons, and one would wonder whether it's even possible for it to do it for all the multiplicity of purposes. I think it's done a fantastic job for the task it has set itself for, which is to make the data maximally available to the largest group of individuals, and notably the larger public. So I would actually like to argue that Dr. Lindberg, and this is going to be in closing, that Dr. Lindberg actually showed us the real way forward. And I'm going to cite, I guess, myself and Jeremy Berg in an article that we published in Science in memoriam for Donald A.B. Lindberg. And I had, while writing with this with Jeremy, I had the opportunity to read through many transcripts of interviews with Dr. Lindberg, and many of which were very amusing because the man actually did have a wry and dry sense of humor. But this one is a particularly good one. Early on, Don recognized that medicine needed to be more data-driven. During his residency training, his data-driven approach to medicine landed him in hot water with a surgery department. When he showed that the silicon used for cardiac bypass was causing extensive embolization, that means bits of blood and gunk going through your arteries, causing stroke and death. Only upon showing the surgeons the imaging data was he able to change their practice. So there's many things that are interesting about this story. A, he had a finding that implicated patient health. B, he didn't just say, hey, you idiots, you're hurting your patients. No, he met with them, he showed them the primary data and convinced them through their own conscience and the visibility of data what the right thing is to do. But the part that's less obvious is this went through the mind of Dr. Lindberg, the doctor, the care for the patient. And I do think that what we will see in the future Don Lindbergs of the world, whether they have the title MD or nurse practitioner or physician associate or maybe some other new term that we have yet to determine, there will be this expert who understands the biology, the medicine, the clinical concerns of the patient, and brings it together in full understanding. And I have to say, since it's 2022, assisted by machine learning agents that look at across the entire corpus of human knowledge, medical knowledge, particularly including the National Library of Medicine, to bring to that expert in a caring, patient-specific way, what's the right thing to do. I do think that there's huge value in the health professional. I'll use the term doctor as a useful handle, as a doctor who knows you, who knows what your preferences are, who truly understands literature, who makes available to themselves the knowledge of science, and who brings to you that expert judgment. I think that is the place that we are going. And in going in that direction, I do hope and I trust that we're heading in the direction that Dr. Lindberg so ably started us so many years ago. Thank you for your attention. I hope I did not bore, and I'm glad to take any questions if there's any time remaining.
Thank you, Dr. Kahane, for that outstanding presentation. Very thought-provoking, of course. So those of you who are watching, look for the live feedback button under your video stream, and that's the button you can use to send questions or comments to Dr. Kahane via me. We do have one comment that's come in. In communicating with patients, either individually or en masse, communicating your caring about them is essential to their reception of your message. I was privileged to know Don Lindberg throughout my entire association with NLM, beginning in 1979, when he was on the board of scientific counselors of the Lister Hill Center. Don communicated caring in every interaction I had with him, and I never saw him have with others. He may not have agreed with everyone, but he was never disagreeable. I believe that that was essential to why we are honoring him today, and why, of course, Dr. Kahane, in the way that you did, honoring Dr. Lindberg's scientific and leadership legacy. So sharing that comment.
So that's a terribly eloquent comment, and did a far better job than I did of summarizing the fact that he did not advance his views by confrontation or by piling on, instead by persuasion and data. And absolutely, yes, there's nothing that substitutes for knowing that someone cares about you. And it's that clinical relationship that I think, that relationship between the care provider and the recipient of that care, that relationship, which has to be data-driven, because it's not enough to be caring. You have to be caring and truly expert and up to date. And in fact, back in the 1980s, I remember being taught in my medical school that unfortunately many well-known doctors were famous and respected, even though they were not state-of-the-art informed, because they were charming and persuasive, but they did not have the underlying science. We need both. We need a data-driven expert who is genuinely caring. And that's going to be the essence of the biomedical profession for its future. And otherwise, I will predict, and I'm not predicting this because I don't think we'll go there, there will not be a medical profession if we don't actually grab that challenge of being trusted, of being dedicated to the patient's well-being, making that clear where our priorities are, and demonstrating that we are truly data-driven. So that's a very insightful comment. Thank you.
Thank you. Yes, indeed. Another comment has come in. Dr. Lindberg was also never condescending in manner when he shared his knowledge and expertise, as Dr. Kahane's last anecdote illustrated. So further to your point.
How dare you make that comment? No, yes. Condescending is just, and in fact, condescension, I would say, is probably one of the dominant notes of Twitter, and probably among its most destructive. I think condescension, which is often unearned and always wrong, is something that you never, ever saw in a leader such as Dr. Lindberg. And I think any hint of it is incredibly destructive to the tissue of trust that we have to reestablish.
Yes, indeed. And much of social media is confrontational and divisive, and only reinforces that condescension in the worst way, unfortunately. Can you tell us, questions come in about the medical humanities, the way in which the medical humanities can serve as a vehicle to educate practitioners of medicine, to augment their empathy to patients. The comment, it's really a comment that's come in, but could you speak to the currency perhaps of the medical humanities in the advancement of the culture of medicine that you described?
That's a very insightful question. I will first answer it tangentially and then to the center. I think that medical humanities are incredibly important, first of all, in the history of medicine. We like to think how modern we are, but much of what we experience has happened before. So for example, understanding what a revolution antibiotics was in the 1940s, but then how there was a race of multiple antibiotics with similar properties, and how claims were made for certain antibiotics of being different than other antibiotics, which were not actually data-driven. Understanding that history, I think will give the doctors who understand it a certain amount of humility in looking at current trials, let's say about state-of-the-art cancer or viral therapies. And so I think understanding the way medical progress has, humanities such as the history of medicine will really give us the appropriate humility in this broad march forward of science. With regard to the individual patient relationship, I think understanding how much value patients get, and when I say value, I mean not just reassurance, but actual positive health outcomes are obtained out of a vital and trusting and informed relationship, above and beyond any scientific breakthrough, above and beyond any specific therapies. Understanding that from the medical humanities and the value of that human interaction. And I'm not even talking about the important placebo effects. I'm talking about how we actually influence patients in ways that are healthful and that change the utilities, their outcomes in important ways. There are a few other ways to understand that without really engaging with the medical humanities. So I could not agree more with the implication of that question.
Thank you. We have time for one more question on the very heels of your response. Let me ask it to you because it is a great follow-on. What are the unintended consequences of patients receiving test results before their clinicians? My experience, this person writes, is that without the support of the clinician context, it can be anxiety producing.
I fully agree. And I don't want to get too personal, but I remember all too well getting a very, very disturbing report through a portal of result on a family member, and unfortunately understanding its meaning. And it was very, very depressing. And if I had not been a medical professional, I'm not sure what I would have done with it. And there are many opportunities for misreading of those results. There is no doubt about that. But I think we have to always, in medicine, we always worry about false positives and false negatives. And it comes down to a trade-off. And if I would, there's been so much that's been done unintentionally by not, in a bad way, by not communicating in a timely way with patients. That, for example, this is a slightly amusing example. My doctor took my lipid levels in anticipation of deciding whether or not to do a statin intervention, and basically never looked up the results because he got busy. But I looked up my own results and I was able to close the loop with him. That happens all the time. And I think on balance, we're better off having more and faster access to our data than not. Now, that's not to say we have to accept the way things are. I do think that in a smarter AI-driven healthcare system, if there was a meaningful result with possibly dire consequences, there would be many technological means to immediately loop in the expert clinician to have a conversation with the patient. It just so happens that our billing-oriented health automation is not oriented that way. So it doesn't have to be this way. But given the current set of cards that we've been dealt, I would rather err on the side of more faster sharing than less sharing. But at the same time, through personal experience, I totally agree. We could do far better in providing expert oversight, especially in cases of dire information shared with the patient. Thank you very much.
Thank you, Dr. Kahane, very much. And again, for your outstanding thought-provoking presentation. We're going to leave it there. And on behalf of the National Library of Medicine, thank you again very, very much. To all of our viewers, we're going to take a short break. We will reconvene at 10:45 a.m. Eastern Time. So join us back here in about 15 minutes. And we look forward to seeing you. Thank you again for joining this morning. And again, throughout our proceedings, if you have a question or a comment, please send it to us by the live feedback button underneath the video stream. So we're going to take our break and we'll see you back here in 15 minutes. Thank you. Thank you again, Dr. Kahane, very much. Thank you. Welcome back to the 2022 Lindbergh King Lecture and Scientific Symposium here at the National Library of Medicine, National Institutes of Health. I'm Jeff Resnick. I'm Chief of the History of Medicine Division at the National Library of Medicine and have the distinct pleasure of moderating today's proceedings. For those of you who are just joining, please use the live feedback button under your video stream to send us questions or comments. We're going to proceed now with the first panel of our outstanding program of today, entitled Lindbergh and the Advancement of Science Through Research Training. It's my pleasure now to introduce the chair of this panel, Dr. Lucila Ono Machado, who is Associate Dean for Informatics and Technology at the University of California, San Diego, where she is also founding chair of the UCSD Health Department of Biomedical Informatics. Previously, Dr. Ono Machado was on the faculty of Brigham and Women's Hospital, Harvard Medical School, and affiliated with the MIT Division of Health Sciences and Technology. Her own research focuses on privacy-preserving distributed analytics for healthcare and the biomedical sciences. In this regard, she directs the Patient-Centered Scalable National Network for Effectiveness Research and the NIH-funded National Center for Biomedical Computing, known as IDASH. We're honored to welcome her today as chair of our first panel, Dr. Ono Machado. Thank you very much for your valuable time and your engagement with us. And I'm going to turn things over to you. Thank you.
Thank you so much for the invitation to moderate this panel. As we have just heard from Professor Kahane's presentation, Dr. Lindbergh's legacy is unparalleled, and it touched the lives of so many people, so many faculty, trainees, and professionals in academia, industry, and government. This panel will address his legacy on the advancement of science through research training, and it includes prominent informatics experts who are leading impactful initiatives in their institutions in the country and in the world. Dr. Josh Denny is director of the All of Us Research Program, NIH's flagship precision medicine initiative, and will discuss the role of electronic health records and computing medicine in the development of an unprecedented resource for scientists everywhere who will have free access to genomes, electronic health records, and participant-reported data from the most diverse cohort in the world. Dr. Graciela Gonzalez Hernandez, professor of computational biomedicine at Cedars-Sinai Medical Center, will speak about Dr. Lindbergh's vision and investment in training, without which many of the speakers might have taken career directions much different than they had today. Biomedical informatics might not have succeeded as an independent discipline if those investments were not made at a critical time when computers were just starting to become an essential component of health sciences and healthcare. Dr. Nicholas Tatonetti, Associate Professor of Biomedical Informatics at Columbia University, will speak about how observational data can and has been used for biomedical discovery, including the role in generating new hypotheses, in addition to the known role of testing those hypotheses. This distinguished panel consists of a small sample of outstanding researchers who benefited from research training at leading institutions that held the prestigious T15 training grants from the National Library of Medicine. Not only those who were recipients of scholarships and fellowships from these grants benefited from NLM's investment. Other students, me included, benefited from the curriculum, the social structure, and from being around the exceptional trainees funded by the T15 program, such as Dr. Gretchen Purcell Jackson and many other current leaders in the field. Our three speakers cover a small portion of what biomedical informatics has become. For example, trends for research funding from NLM over the years indicate that AI, artificial intelligence, was funded since the 80s, and the impact of electronic health records would have on healthcare was anticipated early on. These trends are described in a recently highly recommended book about Dr. Lindbergh's legacy, edited by Drs. Humphreys, Logan, Miller, and Siegel, entitled Transforming Biomedical Informatics and Health Information Access. As this book documents, Dr. Lindbergh's impact in the field was profound. His legacy lives on, and this panel is emblematic of his achievements. It is thus an honor to host this panel, and I will introduce our first speaker, who is Dr. Josh Denny, Chief Executive Officer of the NIH All of Us Research Program. He has been involved in All of Us from its inception and served as the principal investigator for the All of Us Data and Research Center. He's an elected member of the National Academy of Medicine, the American Society for Clinical Investigation, and the American College of Medical Informatics. As a physician scientist, Dr. Denny is deeply committed to improving patient care through the advancement of precision medicine. Before joining NIH, he was both a practicing internist and a researcher, was professor of biomedical informatics and medicine at Vanderbilt University Medical Center. His research interests include use of electronic health records and genomics to better understand disease and drug response. He also led efforts implementing precision medicine to improve patient outcomes. Josh was a leader in the development of phenome-wide association studies, PheWAS, and phenotype risk scores. Please welcome Dr. Denny, who will speak about a legacy of computing medicine, accelerating precision medicine using EHRs.
Thank you so much, Lucilla. It's a real pleasure to come to you today and share some stories from my life and how I see the transformational leadership of Dr. Lindbergh really impacting and setting a course for a future of precision medicine that can really impact people at really the point of care, and advancing knowledge and learning from really every patient encounter. And if we think back of the time of where we were, we really weren't there at this time before his leadership. And so, as Lucilla mentioned also, I just want to recognize I was one of those T15 trainees as well, and the support of the innovation and idea that doctors could engage following the model of Dr. Lindbergh himself and so many others trained through these training programs and become leaders in intersections of computer science, information management, and delivery of care really impacted my life and my trajectory. So thanks so much to the organizers to have a chance to present to you and talk to you about this process. And so I want to just reflect back a little bit on how far medicine has advanced, really, in this case, we'll say in the last 60 years, through research that was done on carefully organized, often small cohorts of individuals, carefully followed using paper means, research projects, and intersections through phone calls, not so much the electronic health record. And these efforts have really had transformational impacts on medicine, the Framingham Heart Study being one of them. There's so many others. And they gave us intervenable risk factors by which we had been able to change care. And I would argue that, the goal of precision, or maybe personalized medicine, has really been since the inception of medicine, of how we tailor care to an individual. But what we've learned through beginning these cohorts is how we could use data to get smarter about intervening on things that may be less visible, and doing it using data and evidence bases. And so, one of our goals is how, and our hope is how can we similarly transform health with precision interventions over the next 60 years. I think the goal of precision medicine or precision health, as we think about how we want to personalize care, is much bigger than, of course, a term like personalized medicine. It is really about getting to the patient and really how we can improve their trajectory of health beyond just disease, but also prevention, resilience, and the way in which they live their life successfully and how they would define it. And a lot of this, I think you could even look back at the 1987 long-range plan that Dr. Lindberg authored with input from others. And in this, I just include a quote here about how the most encouraging aspect of this report is the recommendation that the library move as quickly as possible to translate existing raw technology of computers, information, and engineering sciences into products and services that through its insight and understanding of the special biomedical practices and needs can improve health care in America. And, as I looked through this in this book that Lucilla just recommended and thought about the impact and legacy of Dr. Lindberg on precision medicine, I really saw 3 points that emerged from this to me. And one of these was, moving from the curation of not just literature and making, of course, that much more accessible than it ever had been to a wider audience, but also, storage and cataloging of emergent digital data. It's kind of obvious today that we needed to do this. But, at the time, moving the library into a library, not just of published articles, but of things like the genome and the Human Genome Project and all those things were essential to accomplishing those goals and laying the foundation to build upon. The NLM has really been key and critical and called out from this long-range plan to develop electronic health records repositories and support things like clinical decision support. And clinical decision support, I would argue, its need has never become more obvious than what we see through implementation of genetic data into healthcare. And I think this will only continue, whether or not star 2 variant and star 3 variant and how they're fundamentally different than a star 17 variant. If you look at interpretation of a given genetic variant on drug metabolism. And so, that evolving medicine really needs decision support that can seamlessly partner with a physician to help guide them to the right solution. And then a real premise and foundation is on computational tools to link, search, compare, and analyze these kinds of resources, such that not just people reading the literature, but computers and algorithms can be consumers of these kinds of information as well. And that march forward through so many tools has really helped. And we have available big data resources across all sorts of domains that are mineable, accessible, and clinically relevant due to the last you can mark to the success of the implementation of this long-range strategic plan. And so these are some of the many tools, and Heidi in her opening, Zach also highlighted some of these, and there are so many that aren't on here. I'm going to lean towards referencing some of these that really have more of a clinical impact as I talk about an intersection of really a story of precision medicine that I think is leading us to where the All of Us research program is now. And of these things, we have things that target patients and people directly that are non-medical, as well as medical and research scientists, and really bringing them together so that we can build on knowledge. I also want to reflect on how my clinic space and our clinical charts looked when I was just starting medicine. We were fortunate to be pretty early adopters, actually, of information technology and electronic medical records. But the outpatient clinic, as I was starting, was just getting digitized. And so imagine trying to look through these to, figure out who was on a given drug if it's pulled from the market. Imagine trying to do cross-patient research. It was just so hard and so time-consuming. And so, as we move to electronic health records, and this is a screenshot of our electronic health records in the 2000s, how can we use this for research? And it turns out moving from, clinical care to research use cases and doing across patient kinds of research was not something that was how these were originally architected. And my initial queries, for instance, to try to look across patients would require lots of coding and algorithms to, scan across serially different charts. And so that was an evolution of time and supported by a lot of research from the NLM. And I want to give an example of what was the first cross patient cross EHR genome-wide association study that had a new finding, really relying purely on data in the EHR. And in this case, that algorithm on the left just shows you all the different information pieces we had to pull in. We had to do things like manually coding for spelling errors, for instance, and guessing how people would misspell things, and looking at all the different ICD-9 codes and CPT codes. And that was doctors looking through charts and thinking through, hey, how might this get billed, and coming up with this. And this took us really about 2 years to execute across these 5 medical record systems that each individually executed within their site. It could take some time to do this. But they found that, the algorithms worked well. Overall, we had more than a 90% positive predictive values for our cases and controls. We could deploy this across different systems. We could use genetic data that was derived for other purposes. And, we could find something that was new, a new association of a thyroid transcription factor that was associated with people who had autoimmune thyroid disease. And so it showed a promise of using this kind of technology. Of course, this has been commonplace. Really, all major research cohort studies at this point are using electronic health records as part of their research foundation. And we also, because of resources like ClinGen, at this point, PubMed and NCBI and cataloging of genome-wide association studies, we were easily able to find things like this study, which looked at people who had ischemic stroke that we didn't realize that they had any sort of atrial fibrillation or cardiac arrhythmias, but through genetics, they identified a locus that was associated strongly with atrial fibrillation. And so, you could basically do a study in one disease and define it and carefully curate it. And the genetics actually told you that there's an underlying cause you were probably missing. And this is shown in other kind of clinical studies, but even when this deep dive, it really helped sort of elucidate how in this early study, how genetics can start to tell you things that we don't clinically see. And it's certainly been a model also as we think about drug discovery. Lucilla mentioned phenome-wide association studies, and that's been a case by which we can use the richness of the electronic health record, really categorizing all diseases, all drug exposures, all these lab results. And instead of looking at just one disease, just like hypothyroidism, where those were derived from other studies and we looked at a new disease, we could take that and expand that to the scale of the phenome and figure out ways to map against different diseases comprehensively. And here I'm using the example of atrial fibrillation again. In this really large GWAS study of 400,000 people, when the GWAS for atrial fibrillation developed and shows across the phenome all sorts of different associations. And you can do this really fast once you have these data pulled together and see all these associations. But you can also ask the question, well, the genomics point all this. What happens if I adjust for people who have atrial fibrillation? Do we still have all these associations with the genetics? Or are the genetics actually more specific and they're clinical associations? And you can see when you take away those people who have AFib, all the other associations go away. So it helps, clinically, again, we're able to use tools and power and scope of things like the electronic health record to understand derived genetics and then understand the impact of those genetics much more quickly than we would, and in a more, maybe I would say, reliable, confident way of what we're finding. So I want to give an example of how all these kind of technologies, especially like the UMLS, which really has been foundational for my work early with natural language processing, moving to things like in how we just use as an interlingua amongst different vocabularies from ICD-9 to ICD-10. Great work that NLM did there in making those more consumable, not to mention making things like SNOMED available for everyone in the US. So helpful to not have to work through and make those linkages manually. And so what we did is we took the eMERGE network, which had 10 clinical centers, ICD-9, ICD-10, in and of themselves may be hard to work between a clinical repository and the UK Biobank, which has 500,000 people collected in the United Kingdom, 200,000 of which, when we did this study, had whole exome sequencing and clinical data derived from the UK. And by pulling these together, we have standards around sequencing data. We have lots of different EHR data, things like the UMLS, and all the work has been done around these PheWAS codes. we could map all those things relatively quickly together to around 3,000 different phenotypes. We could use ClinGen and determine amongst these cancer-causing genes that we wanted to look at and see who had pathogenic variants. And essentially, moving and adding a whole nother country's data and interpreting all their genomes were something that is a process of weeks after process approvals. And all these things are compatible. And we were able to analyze this huge data set with rare variants in these 26 cancer genes and look at things like these associations across the different. So here we have a combined sets of 23 genes on the x-axis and a phenome with each of those genes. And in using these data sets across all these different sites, we were able to, in one study, replicate all of these strong gene cancer associations for these genes. In ClinGen, OMIM includes non-cancer, a lot of non-cancer phenotypes in there. And we were able to replicate in the study 70% of those. And then we identified 15 new associations, most of which were non-cancer, but some are related to cancers as well. And we actually can look at their temporality as well in that and show in at least 2 cohorts, all enabled by the underpinnings of all these information technologies that we can use in a very rapid fashion and not even have to think about the languages we're using. That's really some of the power of all those tools that enables this and similarly countless other studies like it. And so, I've talked about how we began with things like Framingham and manually derived survey instruments and exams to incorporation of genomic data and those early atrial fibrillation studies that, also were using things like exams to derive that. And then the power of using health records. But, precision medicine and how we dissect individualized health is much, much bigger than that. And, I just want to recognize there's so many plays to this and the interrelations between them and getting them really powerfully incorporated within one population of individuals to share as much of this. And coming technologies, imaging data, mobile devices, and other sorts of sensor technologies, search of geospatial and other determinations of social determinants of health that we know are so important to understand the diversities of our populations and their influences on health. These things come together, and we really designed the All of Us research program to help us think about how we can, think about the many inputs to health over time. And we want to accelerate health research and medical breakthroughs to enable individualized prevention, treatment, and care for all of us. We really want to focus on a diverse population and understanding the variability that we all could experience. And we want to have a large size of at least 1 million participants that do reflect the diversity of the United States. Over 95% of all genomic studies right now are people of European ancestry. We wanted to change that story, and you'll see that in a minute. We really want to make the large, rich biomedical data set following NLM's model and Don's call to as available to researchers as we can. And it's really important that this be an ecosystem where people can share data, follow fair data practices to ensure and promote reproducibility and interactivity, shareability, findability, indexability, all that kind of stuff. And we really wanted to commit to a set of core values as well in this process. And we've been successful, I think, in enrolling a diverse audience and a large audience. COVID has been challenging, but we've still enrolled over 520,000 participants that have consented. It's very much ongoing. We launched in 2018, and over 365,000 have contributed all the basic steps. Because participants share longitudinal EHR data as part of this, same with digital health technology, they can link in their Fitbit data that they may have had for 10 years. Their EHRs, in some cases, go back 40 years. So we have longitudinal data that people are to share, even though the study started really in 2018. We have this record of data that people are sharing with us. It's really powerful to help us think about things. And we recently released our first set of genetic data, which included 100,000 whole genomes, 165,000 people with arrays. In those whole genomes, we've observed 600 million variants so far. 400 million of those variants are not in common resources. Now, why is that? So why are we seeing so many new variants? And I think it's largely because we have a population that generally hasn't been sequenced before, with over 50% diversity by race and ethnicity, over 80% by larger metrics, including disability, sexual gender minorities, rural location, things such as that. One of the challenges has been mapping across different electronic health records using common data models like OMOP and terminology work such as the UMLS. Again, we've been able to do that, and you can see that we're getting greener on our quality metrics across our 17 or so different vendors represented in many different versions. Because of the terminology systems, again, you can go from cancer to a term like malignant neoplastic disease, and lots of different terminologies that are mapped in without the user having to do the work that all we had to do with hypothyroidism. And what does this mean when you actually come to a participant or a researcher doing a study? And this is open now for researchers. This is an example of my last PhD student at Vanderbilt before I moved to the NIH. He defended in March 2021. He did a study where he pulled together lots of data, including the Vanderbilt clinical data, and found medications that might affect lipid response. And known medications were the most powerful, as is not unexpected. But then a question from the audience, which is not me, after his 3 years of work, you did this at Vanderbilt, can you replicate? And so he was able to apply to all of us for the first time, come in, do the training, come in and take his code from Vanderbilt, basically cut and paste it and replicate this in about a week, and send me this a near final figure with all of us data combined with Vanderbilt data, and show very similar results. And so I think that really shows a power of these kinds of things available across 60 plus medical centers. He was able to combine this data really seamlessly because of the hard work of all the decades before pulling these things together. So, using modern cloud technologies, you can work through things like this, where you can come in, describe with our tools visually and point and click in the resource. And this is not just all of us now. These models are being adopted elsewhere, where you can build a cohort, build a data set, come in and bring technology. At the end, you write in our system and many others, you still do have to write some code, but it can be a team-enabled science where you have different people, from clinicians who don't know how to code to people who data scientists and biostatisticians that work in the data. And you can actually go and run a GWAS like this now using the cloud environment in 30 minutes and find known associations or new associations. And after building your cohort, instead of the year's worth of work and thousands of emails that studies like the hypothyroidism study originally took. So with that, I want to thank everyone again. Thanks so much for the organizers for inviting me to attend, and just appreciate the legacy Don left and created through the NLM that is now continuing and had such a big impact in my life.
Thank you so much, Josh. It's impressive where we all as a community have been achieving, an impressive what you have in particular by leading the All of Us program. We will have a set of questions at the end, and people will be able to use the Q&A button or the chat, depending on which group you are in. And we will go ahead with the other two speakers, and then again have the questions at the end. Dr. Graciela Gonzalez Hernandez is Vice Chair for Research and Education in the Department of Computer Biomedicine at Cedars-Sinai Medical Center. Prior to joining Cedars-Sinai, she was an Associate Professor of Informatics at University of Pennsylvania. Her Health Language Processing Lab moved to Cedars-Sinai and focuses on natural language processing and machine learning for knowledge discovery, extracting unstructured information from clinical records, journal articles, and social media posting to elucidate data patterns, trends, and relationships that can aid the discovery process in areas such as pharmacoepidemiology, clinical research, or public health monitoring and surveillance. Dr. Gonzalez Hernandez and her team have made available to the health research community novel approaches to complete pipelines for information extractions from different sources using NLP. Her experience includes mentoring of more than 50 new faculty investigators, fellows, or graduate students at the master's and PhD levels, and she currently serves as a member of the NLM Scientific Board of Advisors, as well as a member of the NIH BDMA Grant Review Panel. Please welcome Dr. Gonzalez Hernandez talking about Dr. Lindbergh's legacy to the advancement of biomedical informatics, his vision of a new field for a new age.
Thank you so much. It's a pleasure to be here. When I was first asked to speak about Dr. Lindbergh's legacy and this new field for a new age, it has always fascinated me how broad and how wide his influence has been. So just to share a little bit about Dr. Lindbergh, the NLM, and my relationship and how I benefited from his wonderful contributions. I remember being the first interaction I had with him as a member of the review panel for the NLM. We will sit at the NLM library and then wait eagerly for the morning update that he will bring to the review to the panelists. And it was, I think it was one of the things that most impacted me when I first arrived at the NLM and was there and was able to hear his update on science and his views. And we will just sit there and absorb all his insights into this. So I do not pretend to do an overview of his legacy in this sense. There's a book actually on him, and I have the cover of the book right there. That if you want to check it out, is fascinating. And Zach certainly this morning gave an excellent overview of all his legacy. The thing that I want to emphasize is how just like me, there's many researchers across the United States and even around the world that have been, their careers undoubtedly reflect a lot of his findings, a lot of his emphasis on information as a means to improve health. He will always emphasize the latest findings, the latest applications, the latest ways that we could improve health and we could improve the way that people are cared for, public health, individuals' health. So in my particular career path, I got to the NLM early on, and the NLM got to me early on via the data that they share, via funding. So a lot of my funding comes even to this day from the NLM. Through the years, I like this little screenshot of how the NLM peppers all my funding from the beginning, and I'm eternally grateful, but also for the opportunity to review proposals. I've served to this date in around 50 or so NIH panels. And through that, those of you that have reviewed proposals means that I've seen about 2,000 or so proposals from researchers around the nation. And what is striking is how many of them use the resources that have been developed by the NLM and NCBI. GenBank, PubMed is just the influence that the NLM and Dr. Lindbergh have had in all of our research is tremendous. So this is the current year. Again, the NLM takes the lion's share of what I am able to do thanks to them and their continuous support. One very important thing, so when I was thinking how to focus this talk and the impact and contribution, the most important way that I can that I decided to go with was how the NLM was an early supporter of real world data. I think I have the very first or the oldest grant funded for the study of real world data. And I remember that when I proposed it, there was hardly anything published on how to use social media data. And I think the most interesting thing that I discovered is that my proposal wasn't about any specific solutions. What I proposed was to study how it could be used, how real world data from social media could be used for pharmacovigilance. And so I never promised that I was going to find early signals of adverse effects, or actually didn't promise what I was going to find at all. All I wanted to do was to find the tools, develop the tools, test the tools that could enable it. So just like social media, electronic health records, of course, are foremost one of the most important sources of real world data. So coded and structured notes, large repository of clinical and genomic data. They contain details on in free text that could address many knowledge gaps. And one will think we have been hearing about electronic health records being used for our research and our studies. One would think that they will be widely used, that all this data from all these people out there could certainly, and Joshua's presentation highlights that, the importance of that. And it is one of the efforts, I think, that is more striking on its reach. Social media can still contribute. There's stories in social media that people share openly, that people share without the structure of a questionnaire. They sometimes go back in their history. So this search that I like showing is I'm diagnosed with. And if you focus on the middle story, okay, a medical student diagnosed with obsessive compulsive disorder, and so it gives a lot of the details and what kinds of medications this person has used. Then there's a lot of what we call a follow-up story. So many people retweet and put their own little 2 cents on it, or they share a similar story. There's also obviously the things that are not the right thing, like that other one. So these tweets come from the feed directly, and that's exactly how we see them. So this one is a contrast with the same search. You can get really valuable information, and you can get a lot of the noise. The challenge is distinguishing the two and being able to develop the systems that can distinguish the two. The next striking factor that I've discovered through this analysis of real world data is that it's grossly underutilized. I was invited to write a paper on biases in data, and through this I started thinking like, okay, so how much of the data is in the structured portion of the EHR versus the coded portion? So there are some studies on it, and it's very interesting. They're beyond what I can talk about right now, but it's about 70 to 80% of usable, actionable data is in the unstructured portions of the EHR. However, only about 0.5%, and I'm being a little generous there, of the studies based on EHRs use this free text. 99.5% of them focus on just coded data. And this is not too much the fault of the researchers running these studies. It's just data is not easily accessible. Unstructured portions of the data are very hard to get. You will have at every institution, with few exceptions, you will have a very hard time getting free access to it. And even if you can access it and use it, there are not many standards on it. So revisit that one. Social media data and other forum data is not officially used at this point by any regulatory agency. And I say officially because unofficially it is. And actually, if you count the FDA's declaration that they use social media to get early signals about COVID treatments or fake COVID treatments, they mention that that's how they get them, but they don't mention how they use social media on their website. So I guess a declaration on an official website could be seen as an official use of social media. However, there's like little information as to how it is done. Social media data is used mainly to inform other studies like systematic reviews. So there's also references to finding mentions in social media to go then look at what is published about them and then add them to studies. So all of this data that we're surrounded by needs a little bit more of a systematic approach. So this is the paper I was referring to. best practices on big data analytics to address sex-specific biases in our understanding of disease. So in writing it, I saw, for example, that studies that use EHR data and that specifically have a finding that refers to biological sex as a factor, as a difference in their studies, very widely in the use of male and female records. So we have from 75% male, 25% female, all the way to the other way around, 65%, 70%, many studies in between with a great imbalance in the data that they use, even if their finding is specifically related to a biological sex. So the data imbalance is one of the things. And the rate of use of this unstructured data, going back to that point I was making, these studies, you saw the complete, in that graph I showed, you saw all the studies we found that actually use unstructured portions. So the way we derive this is we found first sex-related terms and disparities for different terms and try to get the ones that had a finding that had to do with biological sex, and found 67,424 articles in Medline. But only 469 made it across to include machine learning, AI, and NLP related terms. So we use that as a proxy for the use of unstructured data, because that's the only possible way that you can really process this. So when we saw sex-specific and differences terms only, we get the 67,000 sex, and when we add the text mining or NLP terms, we go down to less than 1%. And it might seem that that's like, well, it's okay. It might remind you what 1% means. It sends you rushing to finding your charger. So that's how I think we should feel about this. It's like, what are only 1% or less than 1%? There's this urgency to correct that and not sit and think that it's already done. It's not done by any means. And there's a lot that we can be done. There's a lot that we can learn. So we could be missing key information, key actionable information by not using these unstructured portions of the electronic health record. So as the anecdote that Zach included about the finding that Dr. Lindberg had in the images of the use of silicon for cardiovascular surgery, something like this might be already happening in one after another study here. So if we just use coded data, in this particular paper, they were looking at hypoglycemic occurrence and severity extracted from EHR data. When they use only code, ICD-9 codes for it, they found about an even number of serious, they use any of this, with severity extracted only from code, hypoglycemic occurrence seemed to be about 46,000 from the data set that they were using. When they threw in NLP, they found 93,000, about twice as many occurrences were identified. And the actual balance of them also varied a little bit. So they found a lot more of the mild and moderate recorded there. Serious were still a good number, just with NLP. When you combine them, though, the power comes through. So when you combine NLP and ICD-9 data, they found in the same data set about 3 times as many events. Even if you discount the mild and moderate, they're still looking at about twice as many using NLP and ICD-9 combined. So the power of the unstructured portions of the record is still untapped, given the few that are there. So moving from real world data to real world evidence requires this advanced NLP and machine learning and artificial intelligence approaches that can really get everything that's there and put it into the right conclusions and the right studies. So just to give a sampling of these challenges, the challenges of using real world data start from extracting the data. So The methods are not widely available. Many are just ad hoc to the specific institution. This example of being able to deploy something that was done in one institution and then apply to like the all of us data. Those are the kinds of things that we're looking for. We're looking for ways that we can deploy methods generically or with minimal adaptation in different data sets. These steps, unfortunately, or these methods, unfortunately, are inaccessible to the average healthcare researcher in general. And then it's very hard to make sure that the data that you're getting is high quality or was done in the proper way. So that's also throws a little bit of a dampening effect on the use of the data or the extraction of the data. The guidelines are lacking, so using the data becomes challenging because researchers don't have a specific pathway to incorporate the data into traditional studies. There's specific things that need to be done before this can even happen, like normalizing terms. So if you're talking about adverse effects, you need to normalize them so that all of the references to specific adverse effect will be accounted for. And then even proving the value of the data, it becomes difficult. Many times it is dismissed as biased or very noisy. It is difficult to obtain funding, not impossible, but difficult, because then you have to go through many hoops that people are not familiar with and on try to demonstrating that you're doing things the right way in order to extract this data, use this data, and apply it and deploy it. Publication process is also difficult. There's no standards. There has been for a long time a standard of sharing data like genomic data, but sharing data extracted from unstructured portions of records has a double barrier there in privacy and in just the practicality of sharing for reproducibility. So there's still many challenges. I will briefly, in the time that I have remained, that I have still, will share a couple of the projects that we've done with funding from the NLM and that we have shared for general use. We have data sets, we have annotated data sets, and we also have these pipelines for processing. This DeepADE Miner is the first end-to-end pipeline for adverse event detection from social media. It is now usable, actionable. It can take data from the streaming API and filter mention. This is collected using drug names and variants of drug names, and then filters and classifies the user post for drug mentions, identifies the span of a name entity for ADEs, and then normalizes to terms. And it has been validated, and it can really be used for taking advantage of this constant deluge of data that is streaming directly from users. So we have numerous publications. I think we're up to like 30 or so in different findings from different analyses for different studies. One of the other ones that we have running and is here is where the social media data can be seen as complementary to a lot of the studies that we have traditionally done in pregnancy. We collected a cohorts of over 500,000 pregnant women over now 5 years, 3 years at the beginning, and then we refined it, and have run studies on birth defects. We have run studies on, now the latest ones are on COVID vaccine and other medications. But basically, just so you understand how this longitudinal data can contribute to the body of knowledge that we have, we get identify women that announce their pregnancies in social media, and then after filtering and classifying, we can get their whole pregnancy timeline and tweets done during the pregnancy, particularly in early pregnancy, and then after the baby is born. So we can identify birth defects, we can identify either illness or medications that we're taking at the beginning of pregnancy, even before the woman herself knows that she's pregnant. So we have a very valuable data set that can be mined for different health studies. Then we have also my social media for detecting mention of changes in medication treatment. So people share openly why they change their medications or when they change their medications. And mining the reasons becomes very important for studies in adherence and tolerability, because many mild adverse effects that are not even reported sometimes to the FAERS database are the underlying cause for switching medications. So we have findings on this particular aspect of it. Just to give you an idea, so the adverse drug reaction was mentioned as a reason for medication switch in about 19.2% of the tweets that we found that mentioned changes in medication. So so adverse effects was the number one reason. And so studying them in relationship to specific medications will be something that can be done with social media. Unique findings from social media can also be done by reducing the volumes to a point that it can be used in a mixed method study. So this one in JAMA Network Open was about statins, posted on Twitter, and it was a qualitative study. It was done by hand, but the only way that it can be done by hand is by having all the automatic methods that can reduce it to the point that humans can look at it. And we found an interesting thing that was not published in any other study about the use of statins, is that people were using them as a way, so as a license to eat an unhealthy diet and not exercise, because they are on statins, therefore they no longer have to do any of that. So this risk compensation behavior became evident in not just one tweet, but in a number of the tweets. And it is the way we took it is, okay, so let's now try to see if we can do another study, traditional study. So it could feed traditional studies as well. So our findings continue, our data sets continue. And I can say without a doubt that my career continues because of all of these wonderful contributions that Dr. Lindberg brought to our field. And I can say that basically is the birth of the field of biomedical informatics is because of his vision and his contribution to our health studies. Thank you.
Thank you so much, Graciela. I think that was a great overview of your body of work and also how NLM has been so influential in that work. I will like to introduce our final speaker, Dr. Nicholas Tatonetti, who is Associate Professor of Biomedical Informatics in the Departments of Biomedical Informatics, Systems Biology, and Medicine, and is Director of Clinical Informatics at the Institute for Genomic Medicine in the Comprehensive Cancer Center at Columbia. He received his PhD from Stanford, where he focused on the development of novel statistical and computational methods for observational data mining. He applied these methods to drug safety surveillance and for the discovery of dangerous adverse drug effects, and in fact has identified and validated previously unknown and serious drug-drug interactions. His lab at Columbia is focused on using this massive scale real clinical and molecular data for making robust and validated scientific discoveries with a particular focus on detecting, explaining, and validating drug effects and drug interactions. Dr. Tatonetti is passionate about the integration of real-world data, such as those stored in electronic health records, into high-dimensional data captured with next-generation sequencing, high-throughput screening, and other omics technologies. And he does that to reimagine and rescale the scientific method. So please welcome Dr. Tatonetti speaking on observational data for biomedical discovery.
Thank you, Lucilla, for that amazing introduction. And just to start, I just want to say super honored to be here and speaking, one, with my amazing co-panelists, but also for today and talking about Dr. Lindberg. It's interesting. I never got a chance to meet Dr. Lindberg in person, which is unfortunate for me, especially because it sounds like the more I read about him and hear about him from stories, that his sense of humor is something that I would have really appreciated. And but through all this reading, which has been just fantastic, I've got to read some of his work and some of his writings, but also a lot about perspectives on his impact on the field. And it's been fantastic to see and kind of eye-opening to see all the ways that he's influenced me. And even to the point of some of the things I say and some of the things I think, which I think are totally my ideas, were so clearly derived from his ideas and planting those seeds far before I ever had a chance to learn them. So I think it's really been a wonderful journey of self kind of exploration to rediscover Don in this way through his writing. I just want to highlight one thing I read about him, which I thought was so cool, which is in the 60s, he was, like a lot of us in our early days, hacking around, figuring out how to turn computers into things that do work for us. But in the 60s, they had a lot of different technology than what we have now. So they were using punch cards, and he actually built the first laboratory information system using punch card programming. And just 20 years later, he built the first AI system to diagnose rheumatological disease. So to go from developing on punch cards, which is something very advanced, laboratory information system on punch cards, to developing the first AI for rheumatological diagnosis is one amazing. And then think about that, just 20, 30 years later, he was there to see the emergence of these tools, these AI tools that we think of now, and all of the groundwork that he laid to make that happen. So it's just been super great. So I'm going to tell, so I was also one of these trainees of the T15 program during my PhD, my pre-doctoral period. And so I thought it would be fun to kind of dust off some slides. So you'll see these slides are actually square shaped. They're very old. And tell the story of my PhD work, and then kind of couple that with a newer version of that story that we've done while I've been at Columbia, that I think is actually really, I didn't realize this at the time, but really follows the philosophy that Dr. Lindberg had. So I'm just gonna dive into it a little bit here. I love observational data because observations start everything. Charles Darwin sailed around the world to collect observations of the biological world so that he could form new hypotheses that we now know developed into the theory of evolution. In pharmacovigilance and drug safety, there's some famous seminal scientists, McBride and Lentz, clinician scientists, who discovered the association between thalidomide use and birth defects, really kicking off modern drug safety surveillance as we know it today. And they all did it because they were making observations. Darwin of the biological world, McBride and Lentz of the clinical world, the patients that they were taking care of. Now we're making observations at a scale that dwarfs what these early scientists were able to do. They were collecting data with their human senses. It's an amount of data that you could describe on a very small disk drive with bytes or kilobytes of data. Lindberg could have coded this on his 20 kilobytes of RAM in his first laboratory information machine, right? A very small amount. And now with new technologies like sequencing data and sequencing hundreds of thousands or even millions of patients, we have huge, massive data sets to troll through, to look for new hypotheses, to make new discoveries from. So it's gone from being where we had just to observe our patients maybe when they walk into the clinic and just clinician scientists really having the opportunity to now having these electronic health records, which you've seen mentioned multiple different ways and across wide different range of projects that give us the ability to form hypotheses. All of us, gives all of us the ability to form hypotheses using this data as a secondary data set, using it for discovery. Now very widely used around the world. I like to think of every drug order as an experiment. As Josh said, we can learn from every clinical observation. And how do we do observational analysis? How do we form hypotheses? Well, when we're trying to do something that on an order of magnitude much greater than traditional scientists have been able to, we have to employ computers to help us do that. I think part of Lindbergh's vision was really about how do we use computers to help with every phase of the scientific method, and one of those being generation of hypotheses. And I like to think of data mining as really this phase. It's using computational tools, informatics tools, data science tools, whatever we want to call them today. But it's using these advanced tools to get computers to generate the hypotheses for us. There's a problem with using these types of tools and using observational data, and that has to do with confounding bias. So I love to illustrate this with a picture of a couple of birds. And here we have a blue bird and a red bird. And so imagine that you live, I live across the street from Central Park. And so imagine we're walking around Central Park one day, and we want to know the relative populations of these birds that live in Central Park. And so you walk around and you make tick marks on a notebook. Every time you see a blue bird, you make a tick mark on the left. And every time you see a red bird, you make a tick mark on the right. And we get back to the apartment and we notice that we observed 5 times as many bluebirds as redbirds in our walk through Central Park. Now, what does this tell you about the simple question you wanted to ask, which is what is the relative populations of these birds in Central Park? Well, in fact, it tells you absolutely nothing, because I'm going to tell you something else about these birds. These birds, like bluebirds, you might be able to figure out by looking at this image, they're very friendly. When they hear people come into the park, they fly to them and they tweet at them and you notice them. But redbirds, they hide. They don't like people at all and they flutter and fly away. And so the behaviors of these birds have actually confounded the data that you were able to collect, making it impossible to answer the simple question you had. And this is not just true in our hypothetical example, but this is true every day in the hospital system. Patients, providers, healthcare practitioners are all making decisions, and their behaviors change what we can observe in these observational data sets. And their behaviors may invalidate them for very simple questions that we think we could answer using these data. But I'm going to show how we can focus on an example of drug-drug interactions, and through multiple data modality integration, we can actually address some of those limitations and make real discoveries. So drug interactions are a common cause of adverse events, and understanding them will lead to better outcomes. It's very common for patients to take multiple drugs at the same time, and that increases with age. Right now, the main way in which we monitor the safety of drugs when used in combination is through observational studies. Clinical trials don't have the sample size or the power really to investigate drug-drug interactions holistically. So we turn to these large observational databases like the electronic health records and like other databases that governments or intergovernmental organizations maintain, like the FDA's spontaneous adverse event reporting system. And these are collections of adverse event reports, which are submitted by physicians and patients and providers that we as pharmacovigilance scientists can use to look and see if there are any early signals of drug safety concern. We decided to use this to study drug interactions. The problem is most of the reports that are submitted submit spurious annotations. Most of these drugs don't cause these adverse events, and it becomes very difficult to decipher any one report, as you can see here. So what we did is we identified some common sources of bias. One that came from concomitant drug use. Basically, if 2 drugs are used together, it's very common for them to be associated with the other drug's side effect. And another bias that came from indication, namely that if a drug is really commonly used for a specific indication, it's often reported with that indication signs and symptoms and not those actual drug effects. We use these to design a new algorithm, which we called the statistical correction of uncharacterized bias, that implicitly corrects for confounding. We were able to apply this to discover drug effects with much more accuracy. In one example, we were able to show that we can reduce false positive rates very significantly while maintaining positive signals. Now, what I'm showing you here is a set of antiarrhythmics. Antiarrhythmics were commonly associated or reported with arrhythmia. Many of those associations are actually spurious. They're because of the indication being treated and not because of the drug itself. But dofetilide is one example of an antiarrhythmic that has a very narrow therapeutic window. And in fact, it is known to increase arrhythmia in many patients. And so what you can see here is in the circles, our corrected measurement after we apply our method to correct for these signals. And in the diamonds, the original estimate. You can see that we've reduced the signal in most of these cases, but maintained it for some important proarrhythmia signals. Overall, we're able to show that we can implicitly correct for age differences in these large observational cohorts. What I'm showing you here are the 20 most biased drugs in terms of the average age of a patient taking these medications. So then the top here, zanamivir is a drug whose average age of a patient taking this is about 30 years younger than the average of the entire data set. If you did a naive analysis without accounting for age, then that would be a significant confounder. But what we're able to show is for that many of these top 20, we can implicitly correct for this without modeling age itself using our models. So we're able to show that we can correct these biases. Now, can we actually infer missing data, stuff that might not be directly reported or even observed? Now, drug-drug interactions are really common, are commonly affected by this, in that there are not a lot of reports for drug interactions, and they may not be observed even when they do occur. So we'd like to be able to implicitly identify them. We built a model, a supervised machine learning model that was inspired by the way that physicians diagnose disease. So when you walk into the hospital, you may have diabetes, but you don't have diabetes written across your forehead. Instead, it lies under some level of detection. And so the doctor will instead use certain signs and symptoms. So you might have pain in your extremities, you might have sweetened urine, or you might have high blood glucose. These collectively can be used to form a diagnosis of diabetes, even though it can't be directly seen. So we're going to do something very similar, but for adverse events. We hypothesize that there's a very severe adverse event or drug interaction that is being unmeasured or unobserved, but that through a collection of different signs and symptoms or other side effects that are commonly associated with that more severe event, we can build a model that can identify and then infer the presence of the drug interaction. So we did that for several different types of models. One was for a type 2 diabetes model. We're able to predict or try to identify if drug combinations were increasing blood glucose. Our top prediction from this was between paroxetine and pravastatin. Now, paroxetine is an antidepressant that was commonly used at the time, and pravastatin was a cholesterol-lowering drug, one of a class of statins, which of course are very popular drugs. We estimate about 1 million patients are on this combination back in about 2010. So what we did, though, is we went to a new database, a totally different source of data, and the electronic health records, which was pretty novel at the time, and analyzed blood glucose values for patients taking those combinations of drugs. And what we found was that in patients taking the combination of drugs, there was a significant increase in the blood glucose values for those patients exposed to the combination, and no change for the controls. And when we include diabetics, we actually see an exaggerated increase, a 60 milligram per deciliter increase in the blood glucose value, something that could complicate diabetes therapy and treatment. Now, this is where another parallel that I found between Dr. Lindberg existed, because when I would normally give this talk, I would get to this point, and it was very early in my PhD career. I was very excited about this, and I would give talks to maybe different faculty or different seminars on campus. And I ended up giving a talk to an epidemiology seminar. And at this point, they were very excited and thought that was very cool, but they were also very concerned about confounders that I hadn't considered. You know, what times of day are these glucose values taken? What are the patient populations? Patients who are taking multiple drugs are probably sicker than patients who take a single drug. Coming up with all different ways, kind of like Dr. Lindberg faced a lot of pushback when he was first showing the adverse events that he was discovering during surgery. So ultimately, what I ended up trying to do is go one step further. And despite the weird build problem here, I did a mouse experiment where we took mice and we fed them this combination of drugs, and we measured their blood glucoses to see if we could see the change there. Can we establish this as a real causal relationship rather than simply an association derived from observational sources? So we had these mice that we fed this high-fat diet, put them on a pre-diabetic state, and then we fed them the combinations of these drugs. And what we found was a 60 milligram per deciliter increase in their blood glucose values for the mice that were exposed to the combination versus the controls, which is almost exactly what we found in humans. And like Lindbergh making headway with his fellow surgeons after he showed them the imaging data, this really changed the conversation for me. And instead of being questions about confounding and what other explanations there could be, the questions turned into biological questions. Questions about what the mechanism was. Was it pharmacokinetic or was it pharmacodynamic? How could we follow this up? What additional experiments could we do? And it really changed what my entire career from that point on. Realizing the power of using observational data coupled with experiments and other validation techniques to establish causality has been kind of a hallmark of my career ever since. And so that's the story I wanted to tell you today. I had another part of it, but it was more fun to kind of talk about my experience with kind of learning about Dr. Lindbergh and the many parallels. And so I'm going to leave it at that. And I look forward to taking questions and discussing with my fellow panel members. Thank you.
Thank you, Nick. I think that's fascinating to see how things evolved over time, and this flashback of square slides was interesting too. Thank you so much. So we have 10 minutes for questions, and I would like to start with one to each one of you. If you were to pick one thing, we saw there are so many that Dr. Lindbergh has done, but what would you pick as like, I want to be like him, I want to do X as well. So why don't I start in the same order with Josh, then Graciela, then Nick?
Gosh, that's a big question. I think a profound impact in leadership of NLM would be through all the resources that were created in NCBI, sort of driven UMLS, ClinGen, PubMed Central, et cetera. But, when you phrase it as you did around a personal characteristic, it would be that, a doctor wearing a computational hat, exploring the world in a humble, dry sort of way at times, influencing a culture to investigate, explore, learn, and improve care. That's a much more personal aspect on taking it. And I think that character of his was so influential on so many people. Actually, I think Lucilla, you may have been muted briefly.
Oh, thank you. Thank you, Josh. Graciela?
Well, I think from my personal interactions with him, one of the things that struck me and that I would like to emulate, I guess, is his capacity to listen. So he will listen with attention, and sometimes you get the feeling that people like seem to be listening, but the first thing they say after you finish something, they say something about themselves or something about like totally different thing that you were talking about. But he will like question, and he will like bring examples. So I remember on a more personal level, we were like registering for one of the NLM events, and he was by me, and he noticed that I had my 9-year-old with me. So I took her on that occasion. And he started telling me about taking his own kids to conferences, and as he traveled, and how much it made a difference to them. And so it's just a simple example, I guess, nothing of the grandiose things in data that he did, but I think it just reflects a way to go through life and listening and noticing, and then making sure that the person that you're with can understand or can see things the way you see them. And by doing that, you learn what is it that it will take to show this person, be it a group of physicians or whoever it is that you're communicating with, the best set of data that exemplifies or that makes your point across better.
Thank you so much, Graciela. And Nick?
Yeah, I think it's I love those comments and the ability to listen. I think that's so important. And I think that's coming through in what I hear and read about is leadership style, and just I know I've been affected by. The ability, if I could emulate anything, would be kind of the ability to lead by example and not by dictation. And I think that that is a critical skill that is sometimes forgotten, but when people have it and they do it right, it has such a broad impact. And I think you're seeing that with all the people that have been so strongly influenced by Dr. Lindberg.
Thank you so much, Nick. And abusing a little bit my moderator role, let me include my own account of what I think is a tremendous and most influential aspect of all his work. I would say, even though we cannot measure directly, PubMed saved more lives than any other computer intervention that I've ever seen. And I, like Zach, I remember the times when we didn't have free access to that information. It was so hard to get into a library, go through books, or even the CDs that were sold at the time. And PubMed made such a difference. And PubMed Central with Betsy Humphrey's work as well is just extending that to yet another level. So with that, I would like to conclude and say that the legacy is so large that we couldn't, with 3 panelists in an abusive moderator, praise everything that Dr. Lindberg has done. But it has been such an honor to host this panel and to be able to comment on the so many great achievements of Dr. Lindberg. So thank you all, and we'll see you next session. Jeff, back to you.
Yes, thank you, Dr. Ono Machado. Doctors Denny, Gonzalez Hernandez, and Tetnetti, thank you very, very much, all 3 of you, for your outstanding presentations. And Dr. Ono Machado, thank you for your chairing this very thought-provoking panel. And we appreciate it tremendously. A lot to think about, a lot to reflect on for today, and certainly for tomorrow with respect of Dr. Lindberg's legacy in science and leadership, and also certainly on your outstanding research programs as you continue them, and especially respectfully, Dr. Denny, with respect to your work here at NIH with regard to the key All of Us program that you continue to lead so wonderfully and impactfully. We're going to take a break now for 90 minutes, and we're going to return at 1:30 Eastern Time. We welcome you back then, and we wish you a good break, as we will all take one here as well. So thank you again for joining us today for the 2022 Lindbergh King Lecture and Scientific Symposium. We'll see you back here in 90 minutes. Thank you. Welcome back, everyone, to the 2022 Lindbergh King Lecture and Scientific Symposium here at the National Library of Medicine, National Institutes of Health. My name is Jeff Resnick. I'm Chief of the National Library of Medicine History of Medicine Division, and it's a distinct privilege for me today to be moderating our proceedings. For those of you who are just joining, please look for the live feedback button under your video stream to send us questions or comments. Continuing our symposium, I'm going to turn things right over to my National Library of Medicine colleague, Jerry Sheehan. Jerry, over to you.
Thank you, Jeff. Hello again to everyone, and welcome back. I hope you're enjoying today's event as much as I am. I am Jerry Sheehan. I'm the Deputy Director of the National Library of Medicine for Policy and External Affairs. I had the great pleasure of serving with both Drs. Lindbergh and King during their time here at NLM, and I'm pleased to be part of the NLM leadership team that's building on their legacy and helping carry NLM into the future. I'm joined in that effort, of course, by many, many capable colleagues here at NLM, NIH, and beyond, all of us working under the inspired leadership of our 2 next speakers. It's my great pleasure to introduce them to you, Dr. Lawrence Tabak and Dr. Patricia Flatley Brennan. I will introduce them both, and then they will continue with their remarks. So let me do the two introductions. Dr. Tabak has been performing the duties of the director of the National Institutes of Health since December 20th of 2021. He previously served as the principal deputy director and the deputy ethics counselor of NIH. And before that, as the director of the National Institute of Dental and Craniofacial Research. Before coming to NIH, Dr. Tabak was a professor and dean at the University of Rochester in the great state of New York. He trained as a doctor of dental surgery and has a PhD in endodontics. His major research focus has been on the biochemistry and function of glycoproteins. Dr. Tabak continues work in this area, in fact, maintaining an active research laboratory within the NIH intramural program, in addition to his administrative duties. He is an elected member of the National Academy of Medicine, fellow of the American Association for the Advancement of Science. I'll say has been a great friend to the NLM during his time here at NIH. Dr. Tabak's remarks will be followed by those of Patricia Brennan, the director of the National Library of Medicine. NLM, as you have heard today, if you didn't know before, is a leader in biomedical informatics and data science research, and also oversees and manages vast literature resources that span 10 centuries, including print and a lot of electronic resources that are used billions of times each year by millions of people in the US and abroad. As NLM director, Dr. Brennan has positioned the NLM as a hub of data science nationally and internationally. And NLM's extensive data information resources are used to accelerate discovery, to engage us better with new users, and help advance a workforce for a data-driven future. Dr. Brennan has a Master of Science degree in nursing from the University of Pennsylvania and a PhD in industrial engineering from the University of Wisconsin-Madison. She too is a member of the National Academy of Medicine and holds fellowships in the American Academy of Nursing, the American College of Medical Informatics, and the American Institute for Medical and Biological Engineering. I want to welcome both Dr. Tabak and Dr. Brennan, thank them for joining today's symposium. And I want to turn things over to you now to start us off, Dr. Tabak. Thank you again.
Well, thank you very much. It's certainly a great pleasure to be joining you all today for the Lindbergh King Lecture and Scientific Symposium. And it's a particular honor to be here to discuss the science, society, and the legacy of the Dr. Donald Lindbergh. I want to thank the hosts, the National Library of Medicine, and the friends of the NLM, and of course, the many excellent speakers. Now, Dr. Lindbergh was a true visionary and pioneer. As many of you know, he was the director of the NLM for more than 30 years, from 1984 to 2015, and indeed was one of our longest serving leaders at the National Institutes of Health. Dr. Lindbergh received his MD from the College of Physicians and Surgeons at Columbia University, and I received my Doctor of Dental Surgery degree from the School of Dental and Oral Surgery, same institution, a few years later. But we did share stories about faculty that we knew in common, and in particular, what the surrounding community was like during each of our tenures at the institution. Dr. Lindbergh was always forward-looking. He was one of the very first to predict that computers would become increasingly useful in biomedical research and in patient care. And he foresaw that medical informatics would emerge as a formal research field and academic discipline. Again, as some of you know, his training initially was as a pathologist, but remarkably, he was able to reinvent himself to become a leader in the use of computers in medicine. Dr. Lindbergh helped establish the American Medical Informatics Association and became its founding president. And he made notable contributions to advance information science for use in medical diagnosis, artificial intelligence, and educational programs. He created programs that transformed our approach to information. While director of NLM, he developed long-range plans that really helped deliver on these predictions that he made. Under his leadership, NLM embraced the internet, enabling the public, healthcare providers, and scientists to have far more access to the medical literature, clinical trials, and consumer health information than ever imagined. He was committed to delivering high-quality health information to all, from health professionals to the public, no matter where they worked or lived, and at no cost to them. Many of the resources he pioneered remain in wide use today. PubMed and PubMed Central, the repositories for medical literature, clinicaltrials.gov, which provides access to clinical trials and their results, and Medline Plus, which provides consumer health information. Dr. Lindberg was integral to the establishment of the National Center for Biotechnology Information, or NCBI, which is a division of the National Library of Medicine that provides access to biomedical and genomic information. The NCBI became a focal point for big data before that term even became fashionable, and remains so even today. NCBI supported databases includes things like GenBank or dbGaP. In addition, Dr. Lindberg led important interagency programs. He was the founding director of the National Coordination Office for High Performance Computing and Communication in the White House Office of Science and Technology Policy, and he was the U.S. National Coordinator for the G7 Global Healthcare Applications Project, a framework for international cooperation in medical informatics. I'm so very pleased to see that Dr. Lindberg's scientific legacy is well represented here today by a diverse group of inspiring advocates for bioinformatics, precision medicine, computational sciences, and library management. We've certainly come a long way over the years, yet much remains to be done. My hope is that today's distinguished speakers, along with all of you who are listening to their words, will work together in concert to continue to advance Dr. Lindberg's exciting vision for the future of biomedical research. With that, I thank you, and I'm very pleased to turn it over to my colleague, Dr. Patricia Brennan.
Thank you very much, Larry. And let me begin by thanking you for taking the time to be with us here today. You are a colleague and a mentor to me, and I'm grateful for that. I want to thank all of the people who worked to make this session come to fore. Lots of planning, Jerry and Jeff, and in particular our friends of the National Library of Medicine. This has been an important day. My thanks also to all the speakers. As I prepared my remarks, I reflected on the question, what do you get when you stand on the shoulders of a giant? What can you see? I've had the good fortune of becoming the director of the National Library of Medicine, NLM, immediately following the 30-plus-year tenure of Donald A.B. Lindberg. I'm sure that each of you today treasure your own recollections of Don, maybe from a conversation you've had or a laugh you've shared with this great leader, this teacher, this visionary and colleague, who is also a husband to Mary, a father, a grandfather, and friend. I am both proud and humbled to stand on the shoulders of this giant as I lead this incredible organization. I know more viscerally than most of you Don's legacy as the director of the National Library of Medicine. I sit in the office he occupied. I walk down the halls he walked. I work with many of the people he hired, and I see and experience every day the fruits of his judgment, his investments, and his vision. I also now sit where Don once sat, representing the National Library of Medicine at the leadership table of the NIH, along with the other institute and center directors. Because Don paved the way, I have a platform to extend the National Library of Medicine's thought leadership and technical assistance to guide the NIH's continued efforts to advance data-driven discovery. The goodwill and collaborative spirit engendered by Don across the NIH opened doors for me and helped me deliver on his legacy to advance the promise of science accelerated by broad access to the literature and data. Don and I shared a particular commitment to ensuring that the public benefits from NLM's efforts to assemble, organize, preserve, and disseminate biomedical knowledge for society. It was his early vision that made Medline Plus a trusted resource for consumer health information and ensured that the PubMed citation database and the PubMed Central Literature Repository were made open and accessible to everyone, everywhere, with an internet connection at any time and place. Please watch this video to take us back almost 25 years to see the beginning of this effort.
Today on Capitol Hill, the National Library of Medicine's Medline Internet database is made free to the public.
The superhighway on medical information will now become a freeway.
This development by itself may do more to reform and improve the quality of health care in the United States than anything else we've done in a long time.
We actually at NLM alone answer 1 million inquiries a day.
A day?
A day. It's a staggering amount. It's going 400 million a year.
We have tens of thousands of genomes, not just one, and all of that has to be assembled in a place where people can compute on it and learn from it. And that's where NLM is just a central hub of information that we all depend on.
Researchers are downloading data equivalent in size to the contents of the entire Library of Congress every week. That's amazing.
The real heart of PubChem is the links from each chemical to other sources of information about its biological properties.
When we were formulating the Framingham Share program, in which we wanted to genotype the 10,000 participants in the Framingham Heart Study, we wanted to put the genotypes and the phenotypes together in a common database. And before we knew it, there was dbGaP, database, genotype, and phenotype.
Oftentimes, the National Library of Medicine that I turn to, and not just as a reporter, but also as a doctor. There are 23 million citations on PubMed. ClinicalTrials.gov is a place that I often send my patients.
I push Medline Plus. I eat, breathe Medline Plus. It's just amazing, you know, the amount of information that they have on the website.
You know, today there's virtually no lag between new knowledge coming out of any kind of research activity and it's a clinical application. The basic reason for that is what the National Library has done, taking advantage of the new technology for the transmission of information.
Commitment to the public was also evident in his efforts to educate the next generation of biomedical informatics scholars. Frankly, I believe that of all the aspects of his job, Don's engagement with the trainees was his favorite. When you stand on the shoulders of a giant, you have a great advantage. The foundation Don built and the relationships he established provided me with a playbook right out of the gate. However, I know that it is not enough to solely rely on his vision to guide our future. In one of our last conversations, he said to me, "This is your game. Make sure you play it well." Well, in order to do that, I cannot simply stand on the shoulders of a giant. I must keep my head up and my eyes forward to the future to envision new pathways and find new opportunities to bring forward the riches of the National Library of Medicine for the benefit of science and society. I close by inviting you to stand with me on the shoulders of this giant, to meld your sights with his, for it is not by holding tight to that which he could see, but by using his vision as a stepping point for our own, that we will best serve his legacy. Thank you and welcome.
Thank you, Dr. Brennan. Thank you, Dr. Tabak, for your remarks. And yes, I think highlighting the contributions and the legacy of Dr. Lindberg in the NLM and all of our services and users to the NIH community and beyond, internationally across the federal government. I appreciate your comments on all of those dimensions of Dr. Lindberg's legacy. And with that, want to help us move on with our program. So Dr. Resnick, let me turn things back over to you for the remainder of the afternoon.
Thank you very much, Jerry. I certainly echo your thanks to Dr. Tabak and Dr. Brennan for their remarks, which certainly underscore the scientific and leadership legacy of Dr. Lindberg in the current and certainly the future work of our institution. Before we begin the next part of our program, I'd just like to remind everyone watching that today's proceedings in their entirety are being recorded and will be made available soon in the NIH Videocast archive. This archive recording is significant because it is permanent, so many more can appreciate today's programs and the wonderful presentations that we've heard. And I'll also add that this permanence is apropos of the legacy of Dr. Lindberg itself, its own permanence, in fact. Indeed, its influence on the lives of so many individuals and library circles, many of whom we've heard today and many more who are watching, of course. So now it's my distinct pleasure to introduce my NLM colleague, Dr. Clement McDonald, who will offer a personal remembrance of Dr. Lindberg. Dr. McDonald is the Chief Health Data Standards Officer here at the National Library of Medicine. In this role, he coordinates standards efforts across the NLM and the NIH, including the Fast Healthcare Interoperability Resources, or FHIR, interoperability standard and vocabularies specific to clinical care. Dr. McDonald previously served a dozen years as director of the National Library of Medicine's Lister Hill National Center for Biomedical Communications and as scientific director of its intramural research program. Dr. McDonald's research focuses on electronic medical health records, EMRs, their use in clinical care and research, and data standards needed to feed EMRs and epidemiological studies of clinical databases. Welcome, Dr. McDonald. I'm going to turn things over to you. Thank you for joining us.
Excuse me, Clem, you're on mute and we're not hearing you. And Dr. Howell's slides are up, Jeff.
Okay. Yeah, so I appreciate this chance to talk about my personal experiences with Don and reflections on stories I hear about him. So some people think of Don as distinct, as distant and perhaps a bit stiff, but actually he was a fun guy and he liked to laugh. He liked it a lot. He was a Renaissance man with broad and eclectic interests. He was an excellent photographer. He had his own darkroom, black and white and color. He was a cowboy. He and his children all had horses and rode them together. He loved music, especially opera, and had a big collection of opera CDs. He loved art. I remember his interest in Turner's watercolors because the Indianapolis Art Museum had one of the biggest US collections of Turner, and he loved music, especially Massenet. So I would like to include also, that you heard this already, his inclusion of medical record technology as an important part of NLM research. It was part of his 2006 strategic plan, and he breathed life into medical informatics from the beginning of his tenure at the library. So NLM was a major funder of medical informatics research until recent years when Oregon Institutes discovered it. He fostered the creation of AMI and was its first president, and I was privileged to be in his executive cabinet for 2 years. I love to listen to him talk extemporaneously. His phrasing was polished, lively, and clever, just as it flowed out of his mouth, as though he had written and hand-edited it. He was also willing to say what he thought, tell it like it was, a rare trait in Washington. So after I joined NLM, he and I would often meet at the end of the day. And toward the end of the meeting, he would say, "Hey, how about coming home to dinner with Mary and me?" And I thought, what? You can't really bring a guest home on such short notice. What would Mary say? And she always said yes. I had many late invitation dinners with them many, many times. With Mary's cooking, they were gustatory delights. Some people saw Don as stern and tough, and he could be that, but he was also great fun. He loved to laugh. So those meetings with you and Mary were a special treat. He and Mary are really convolved and combined almost in everybody's mind because they always were together. And how they connected is a ready-made script for a romantic comedy. I had a long talk with Mary recently, When she met him, she was working on a little baby in the Vanderbilt Pediatrics Treatment Room at Columbia Hospital. She and her team were unsuccessful in drawing blood after 2 sticks. And as a matter of principle, she would not stick a child more than twice. So she sent a note to the lab saying, unable to draw a blood sample. Don was a resident in clinical pathology at that time, and he showed up shortly thereafter, asking Mary arrogantly, now those are her words, "Who wrote this note?" "I did," she replied. And he continued arrogantly, "Where did you train?" And she said, "Simmons College, affiliated with Harvard." And she asked, "Where did you train?" He said, "Amherst." And then very shortly, he blurted out, "Amherst has a football game with Williams in October. Would you be my date?" She had said, "But I'm engaged to be married in December." And he said inexplicably, "Maybe another time." However, he found her the next day and asked her again, and she said, "Okay." After that, he asked her on another date. "Can't go that day. I have a prior appointment." The appointment was to be fit for her wedding dress to another guy. Somehow they worked out another date. She lived in Manhattan and the date was in New Jersey. Coming back, he became very lost and ignored all of her admonitions about how to get back to Washington Bridge. On the way to Manhattan, they circled for hours and finally found, despite his stubborn resistance to her advice, found the way. On that date, he asked her to marry him. No mass gathered under Don's feet. She said, "Yes." I asked Mary, "How could you decide to marry him after 2 dates?" She said, "We spent many hours together in Boston, New Jersey." I also had another great privilege. Mary called me over to Suburban Hospital to join the immediate family for his last 2 days. He was no longer fully conscious, but occasionally responded with a movement or a grimace that suggested he understood something. We held his hand at times. Those 2 days with him and his immediate family were the most precious moments. In his last hours, I got to kiss his forehead, squeeze his hand, and say goodbye, old friend. Thank you very much for being a chance to just present these stories to you.
Dr. McDonald, Clem, thank you very, very much for pulling together those stories and reflections about Dr. Lindberg, and certainly Mary as well. Thank you for sharing. It's now my pleasure to introduce our next speaker, Dr. Sally Howe, who's going to be joining us today by pre-recorded video to speak about Dr. Lindberg's high-performance computing and communications leadership. Dr. Howe began her government career in 1980 at the National Institute of Standards and Technology, NIST, where she worked in statistical computing and computational geometry. And there she was chief of the Scientific Computing Environments Division. In 1992, she joined the newly established National Coordinating Office for High Performance Computing and Communication, or HPCC. She worked there and at its successor, the National Coordinating Office for Networking and Information Technology, R&D, until 2007, including as Associate Director from 2001 until 2007. From 2007 until her retirement in 2017, Dr. Howe was at the National Library of Medicine, where the National Coordinating Office for HPCC had been located since the mid-1990s. At NLM, Dr. Howe worked in the areas of health effects of climate change, and she built the print archive and finding aid for the National Coordinating Office for HPCC. We certainly appreciate her pre-recording her presentation as part of today's proceedings. So I'm going to turn it over to Dr. Howe.
Hi, my name is Sally Howe. Thanks for inviting me. My talk is about Don Lindberg's High Performance Computing and Communications, or HPCC, leadership and legacy. Don Lindberg led the HPCC program from 1992, when it was created, until 1995. I joined the new National Coordination Office for HPCC in 1992 and stayed for 15 years. I'll talk about events from the 1980s to the present. Next slide. This quote is from Walter Isaacson's 2014 book, The Innovators. It captures the impact of Don Lindberg's HPCC leadership. It was a two-step process. Over the course of more than 3 decades, the federal government, working with private industry and research universities, designed and built a computing, networking, and information technology research and development, or R&D program, to help federal science and engineering agencies. Those efforts were formalized in the presidential HPCC program. Don Lindberg was its first leader. He laid the foundation and the framework for the program, which continues to this day. Walter Isaacson went on. Then the government threw that infrastructure open to ordinary citizens and commercial enterprises. This was the National Information Infrastructure, or NII, or Al Gore's Information Superhighway. In 1994, the HPCC program was asked to add R&D for the NII. Lindbergh and HPCC didn't miss a beat. The HPCC plus NII community funded and conducted the R&D to make America's digital revolution of Isaacson's title the extraordinary success that it is. Next slide. This story begins inside 8 federal science and engineering agencies. Researchers and managers in those agencies were making 2 discoveries. Computational science, modeling and simulation, was proving itself to be the 3rd leg of scientific inquiry, alongside experimentation and theory. In fact, computational science could do things that experimentation could not do, such as modeling and simulation of phenomena that were very big or very small, very fast or very slow, or very far away. It could do modeling and simulation of phenomena that were dangerous to health or safety, or were prohibitively expensive. So computational science could help the agencies achieve their mission goals. They were also discovering that a supercomputer architecture could do both numeric calculations and symbolic or text processing. The agencies needed both. Those 8 agencies were the Big 4, the Defense Advanced Research Projects Agency, the Department of Energy, the National Aeronautics and Space Administration, and the National Science Foundation, plus the National Institute of Standards and Technology, the National Oceanic and Atmospheric Administration, the Environmental Protection Agency, and the National Library of Medicine. Next slide. Given those discoveries, the agencies found they had common needs. To do computational science, they needed general purpose supercomputers for unclassified science and engineering R&D. The agencies were funding R&D by manufacturers who were building supercomputers that agencies and the private sector were buying. They needed high-speed networks to connect supercomputers to the researchers who used them. They were funding R&D by companies that were building those networks, and the agencies and others were buying services. The agencies also required that their networks be interoperable. Altogether, the agencies were funding and developing the technologies underlying the internet. Those supercomputers and networks would need to be ever faster and more capable. That meant long-term R&D, largely in universities and technology companies. It would be expensive. The agencies wanted to divide up the work and have access to the results. In those early days, few were thinking about what ordinary citizens might need or want. Next slide. Under the umbrella of the Office of Science and Technology Policy, or OSTP, in the Executive Office of the President, the agencies laid out their case in a series of reports. They recommended a balanced federal R&D program in computer hardware, software, networks, and education and training. Next slide. Their Grand Challenges reports said why. Grand challenges are fundamental problems in science and engineering that have broad economic and scientific impact and require high-performance computing. They span climate and weather, machines like airplanes and cars, the life sciences, and general purpose tools like visualization, imaging, and virtual reality. The visionary Don Lindberg had written the book, The Computer and Medical Care, in 1968. He long knew that medicine and healthcare needed powerful computers. With the Global Change Research Act becoming law in 1990, Lindberg observed that climate change was considered important because it affected people. He said he joined the next multi-agency program that also affected people. That was HPCC. Next slide. What did Congress do? It held hearings and funded R&D and procurements. Senator Gore and his colleagues in the House of Representatives introduced high-performance computing bills. University and industry witnesses testified at hearings, conveying support and offering good advice. The HPC Act became law in December of 1991. The act said that the United States needed high-performance computing for national prosperity, national and economic security, industrial production, engineering, and scientific advancement. That's still true today. The act created a presidential program, not a program led by an agency, and was assigned responsibility to OSTP. While informal planning and coordination had been fine, a presidential program with growing requirements and budgets and visibility warranted formal coordination. That's where Don Lindberg comes in. The act authorized appropriations from sums otherwise authorized to be appropriated. Funding was and still is part of the regular budget process. It wasn't a competition. The law didn't give the program a name. For many years, it was the High Performance Computing and Communications Program. Next slide. In the summer of 1992, OSTP asked Don Lindberg to lead HPCC. That had two parts: chairing the HPCS subcommittee, which already existed, and heading a new national coordination office. Everyone was delighted. He was the only HPCC person who had both a national and an international reputation. His selection signaled how important the government thought both the program and the grand challenges were. The agencies knew him and NLM, and he could rely on NLM's infrastructure to get the NCO started quickly. Next slide. He set up a 6-person national coordination office. 3 of those people are in this picture: Dr. Lindberg, Executive Assistant Pat Carson, and Charles Kalina, who was the Executive Secretary of the HPCS subcommittee. The other 3 were a person on detail from NASA, an administrative assistant, and myself, then on detail from NIST. Next slide. As we all know, Don Lindberg was a curious and voracious reader and a thinker across not just medicine and healthcare, but also science and technology and the humanities. He thought about how science and technology could help people. Before the HPC Act became law, HPCC people naturally associated themselves primarily with their own agency or university or company. They thought of themselves individually as hardware people or software people or networking or applications. Don Lindbergh helped them forge a new additional identity, inviting them through his actions and his words to be part of a broad HPCC R&D community. He did that by speaking at conferences and workshops on HPCC topics and visiting supercomputer centers. He and the HPCST met with supercomputer center directors, leaders of software companies, and leaders from the telecommunications industry. He met with everyone who wanted to visit, and he talked to all of them about HPCC. In 1994, HPCC added R&D for the National Information Infrastructure. NII R&D focused on 4 applications areas: education, healthcare, manufacturing, and digital libraries. The HPCC R&D community easily expanded to include NII R&D. Don Lindbergh remained NLM director while guiding HPCC. He spent mornings at his office on the mezzanine of NLM's main building, doing NLM work. Then he spent afternoons at HPCC's National Coordination Office, doing HPCC work. The NCO was in B1, B for basement, of NLM's Lister Hill National Center for Biomedical Communications. NLM was an early adopter of HPCC technologies. It moved key services to the internet in early 1996 and offered free public access to PubMed for search and retrieval of biomedical literature in 1997. Next slide. In April 1993, 7 months after he became head of HPCC, Don Lindbergh wrote his lessons learned. He acknowledged his excellent, reliable, and self-motivated agency colleagues. He introduced and welcomed every newcomer at their first HPCST meeting, kept up with their progress, and asked good questions to probe their views. Next slide. His HPCC colleagues had a surprising tolerance for the efforts required to adjust common goals to satisfy the numerous agency mission requirements. He made that easier. The NCO started adding technical coordinators, subject matter professionals who help the agencies identify their shared goals and document progress. Next slide. HPCC needed conscious application of ordinary management systems and principles to the operation of the complex HPCC project. And it needed careful documentation and formal dissemination of the results to agencies and the public. To that end, the NCO had full-time technical writers who drafted the annual supplements to the president's budget request required by the law and drafted technical reports. Next slide. He wrote that multi-agency budget crosscuts are worthwhile for projects of clear national importance and cross-agency relevance. Today, there are only 3: climate change, HPCC, and nanotechnology. Next slide. This photo from the NCO for HPCC archive housed in NLM's History of Medicine division looks like it was taken at the 1995 reception honoring Dr. Lindbergh after he had stepped down as HPCST chair and NCO director. It reflects HPCC's several parts. From left to right are Bob Kahn of Inventing the Internet fame and on the NLM Board of Regents, Tom Pike of NOAA, an applications R&D agency, Norman Glick of the National Security Agency, a computing systems R&D agency, and Dr. Lindbergh. Next slide. Today, HPCC is the Networking and Information Technology R&D, or NITRD, program. It has 12 components. The first 6 listed here trace their roots to the 1990s. They include high capability computing infrastructure and applications, and large scale networking. The other 6 are newer. They are R&D in large scale data, artificial intelligence, cybersecurity and privacy, computing systems that help people, physical systems that have computers in them and networks connected to them, and robotics. 21 agencies participate. The total budget is almost $8 billion. NSF is the largest at just over $2 billion. NIH is number 2 at just under $2 billion. 24 NIH institutes and centers plus NLM participate. Sadly, NLM isn't mentioned in the 2022 supplement. Next slide. But that supplement notes that 30 years of HPCC/NIDARD investments underpinned our science and technology response to the pandemic. They facilitated or enabled rapid vaccine development, search for therapeutics and cures, connectivity. One thinks of the internet, web browsers, search engines, smartphones, and video conferencing for many of us, and access to supercomputers for COVID research. In early 2020, many HPCC technologies needed only to scale. Without Don Lindberg's leadership, HPCC might have remained a technology R&D program for the federal science and engineering world. With his leadership, a new broad HPCC/NIDARD community built and continues to build the technologies underlying what Walter Isaacson called a new economy. Next slide. HPCC technologies and the knowledge and understanding they enable now pervade every aspect of our lives. In August 2022, just last month, the CHIPS and Science Act became law. It calls for OSTP to coordinate national scale technology R&D and transfer from federal agencies to the private sector. The Act identifies 10 key technology focus areas, and 5 of which mention NIDARD topics. Lindbergh's HPCC, now NIDARD, could serve as an excellent model for building their new community. The end. Thanks for watching.
Thanks very much to Dr. Howe for her presentation. And although she ends on a the end note, we all know, and as she mentioned 2 minutes earlier in her presentation, the story continues. The leadership legacy of Dr. Lindberg remains squarely in place, along with now the leadership of Dr. Brennan and future directors of the National Library of Medicine. Thank you again, Dr. Howe. Now we're going to proceed with the second panel of our program, entitled Lindberg and the Evolution of the Library as Research Partner. To this very end, it is my distinct pleasure to introduce the chair of this second panel. Teresa Knott serves as Associate Dean for the Virginia Commonwealth University Libraries and Director of its Health Science Library. Prior to joining Virginia Commonwealth University, she served as the Deputy Director at the University of Maryland, Baltimore's Health Sciences and Human Services Library, and she held several positions at the Texas Tech University Health Sciences Center Library of the Health Sciences in Lubbock and in El Paso. She was a 2005-2006 National Library of Medicine Association of Academic Health Science Libraries NLM ALHHS Leadership Fellow, and in 2017-18 she served as a mentor in the Leadership Development Program. In 2016-17, she served as president of the Medical Library Association, the MLA. Teresa Knott, a warm welcome to you. Thank you for your time this afternoon. I'm going to turn things over to you. Thank you.
Thank you for your kind introduction, Jeff. Good afternoon. I'm pleased to welcome you and our distinguished panelists to this session on Lindberg and the evolution of the library as research partner. As you've learned, Donald A.B. Lindberg was the visionary leader of the National Library of Medicine for over 30 years. He considered libraries and librarians key research partners. Excuse me. I was a fledgling health sciences librarian when Dr. Lindberg was appointed as the director of the National Library of Medicine in 1984. Dr. Charles Sargent was my director at the time, and he had worked closely with Lindberg when they were both at the University of Missouri. And Charlie was happy to share stories of his experience working with Lindberg at Mizzou. Later, I had the privilege of attending the NLM-sponsored Woods Hole Biomedical Informatics course, an initiative that brought librarians, physicians, healthcare providers, informaticians together. It was a transformative experience for many of us, and really the first time I had the opportunity to interact directly with Dr. Lindberg. He was visionary and inspiring and quite personable. From my perspective, Dr. Lindberg initiated many programs that reshaped the work of health sciences librarians and researchers in the health sciences, while democratizing access to high-quality health information and enhancing clinical care through the application of biomedical informatics. As we move forward, I would remind you that you can use the live feedback button under your video window to send us questions, and we'll try to get to as many of your questions as possible after our panelists speak. Today, our panelists will share current projects they are working on and how Dr. Lindberg's legacy echoes in their work. Our first panelist this afternoon is Christy Holmes, PhD. Christy is the director of the Galter Health Sciences Library and Learning Center and professor of preventive medicine in the Division of Health and Biomedical Informatics at Northwestern University Feinberg School of Medicine in Chicago. Christy serves on the leadership team of the Northwestern University Clinical and Translational Sciences Research Institute in UCATS, where she directs evaluation and continuous improvement for the Institute and several other programs and centers. She also serves as the Chief of Knowledge Management in Northwestern's Institute for Augmented Intelligence in Medicine and directs the NNLM National Evaluation Center. Her work focuses on the discovery and equitable access to knowledge through collaborative, computational, and social action. Today, Christy will speak on The Modern Library Found, an article that Dr. Lindberg published in the Bulletin of the Medical Library Association in 1996. Christy, welcome.
Okay, great. Thank you so much for that introduction, Teresa. Can you hear me okay? Okay, wonderful. Thank you. Thank you all for the opportunity to join you today. It is an absolute honor to be part of this wonderful event that celebrates the life and legacy of Dr. Lindberg. Before I begin my remarks, I'd like to take a moment to thank the organizers, the National Library of Medicine and the Friends of the NLM, Dr. Lindberg's family and friends, so many of my own collaborators and colleagues who have made profound impacts and influences on my own work, our strong partners at Northwestern University Feinberg School of Medicine, and the dedicated and extremely talented team at Galter Health Sciences Library and Learning Center who regularly make magic happen through our resources, services, and spaces, and whose work I will briefly highlight a bit later in my remarks. I also want to call attention to the design on some of my slides, which reflects the design of the current strategic plan underway at NLM. This active effort builds on an incredible body of work at the National Library of Medicine, accelerating biomedical discovery and data-powered health. It is indeed a bright future for libraries as research partners. Dr. Lindberg's impact is impossible to quantify. Across biomedical informatics and library communities, through information standards, technology trends, a deep dedication to interdisciplinary partnerships, and thoughtful engagements to impact health, his influence will be felt for years and years to come. Perhaps the most remarkable is that much of his work was happening during the relatively early days of the internet, which Dr. Lindberg himself called an intellectual Wild West. Today's foundational resources, such as those shown on the front page of the National Library of Medicine website, which is shown on the left, like PubMed, clinicaltrials.gov, Medline Plus, and more, were once new and unfamiliar. And as they were launched, they offered access to medical information like never before. A great example of that is shown here, where we see Vice President Al Gore with Suzanne McInerney, co-author of InfoMedicine, David Lippman, who was the director of NCBI at the time, Harold Varmus, the director of NIH then, and Dr. Lindberg. In the image, Vice President Gore is demonstrating a new system developed by the NLM called PubMed, which simplified searching for online medical information by researchers and the public alike. The flexibility of PubMed and the ease of use prompted Gore to make those remarkable comments we heard earlier in the video, in which the Vice President said, making information like this freely available on the web may do more to reform and improve the quality of healthcare in the United States than anything else we have done in a long time. I've thought a lot about what to share during my remarks today. Eventually, I came to the realization that I can likely never do a truly fitting tribute to the legacy of Don Lindberg and his lasting impact on libraries as a research partner. I decided that perhaps I will just contribute to the discussion with a few thoughts and experiences that build upon the idea of libraries as research partners. I'll also share the story of how I entered the world and found a thoroughly invigorating professional home in libraries. I cannot imagine a better place to be, and I am grateful to the champions at NLM, such as Dr. Lindberg and Betsy Humphreys, and now Dr. Brennan, and so many others for their role in helping me find my way here. Several years ago, I read Dr. Lindberg's lecture, The Modern Library, Lost and Found, in which he presented at the 7th International Congress on Medical Librarianship in May of 1995. There are a few passages I'd like to share with you today during my remarks. First, he shares that the system of connections between computers and their users has remade our world even more than the computers themselves. He goes on to write, suffice it to say that the spirit of voluntary cooperation and helpfulness within the library and the medical communities permitted the work of NLM to be fruitful. And here's the great section. The human network, in other words, preceded the electronic network, as it always must if useful services are to result. Indeed, this human network, depicted as the puzzle pieces on the right of community and capacity building, provides both a strong foundation as well as momentum for health sciences libraries to partner, lead, and champion exciting efforts to translate and advance what we think of as a knowledge network of data and resources in extraordinary ways. This remarkable synergy between the human and knowledge networks reminded me of a quote attributed to Aristotle, where he communicates that the whole is something besides the part. In this case, and the case of libraries as research partners, the whole is something much more impactful than the sum of the parts indeed. Whoops. I'm sorry, could we go back a couple of slides? Okay. As is the case for many of us who have served in research roles in health sciences libraries, my first major connection with the National Library of Medicine was through training. I joined Washington University's Becker Medical Library as a bioinformaticist in the summer of 2006. I just graduated with a biochemistry degree the year before, and I was searching for something that would allow me to build programming and connect with people in more of an infrastructure support role rather than a discovery role that I might have as a postdoc. I was able to quickly find training opportunities at the National Library of Medicine, such as the Field Guide workshops and the NCBI Advanced Workshop for Bioinformatics Information Specialists, which is affectionately called NAWBIS, a 5-day intensive training program held at NCBI, which helped me get up and running to teach my own workshops and to be able to partner with researchers through consultation services. I also found an incredibly supportive community of practice through a network of bioinformation specialists at different libraries across the country and through these NAWBIS leaders, and at NLM such as Renata Gear, and a few example papers of the work of this group are shown on the left. For me, this is one of the most meaningful examples of the power of Dr. Lindberg's human network that NLM made possible. Many of us have gone on to work together on various research projects, outreach partnerships, and more. This focus on people continues today in a variety of ways at NLM. For example, if we look at the Learn page today at NCBI, we can see that it supports both end users and other workforce roles who engage, use, and support these resources. A great example of this is the NCBI Virtual Outreach Event Series. This series expanded online outreach to a worldwide audience of people who use NCBI resources for biological and biomedical research, science education, clinical applications, and much more. These virtual outreach events included a wide range of activities such as interactive workshops, webinars, and even codathons. Another great example currently underway is the NIH Comparative Genomics Resource, or CGR, a multi-year National Library of Medicine project to maximize the impact of eukaryotic research organisms and their genomic data resources to biomedical research. The National Center for Biotechnology Information, as part of NLM, leads both the development of this initiative as well as the important work of engaging genomics communities. Ultimately, the CGR project will facilitate reliable comparative genomics analyses for eukaryotic organisms in collaboration with the genomics community. The CGR project intends to achieve several impacts that will benefit research in the genomics community, which are listed here on the right. Community collaboration, again, that human network is critical to CGR. Feedback from the genomics community will inform improvements made to NCBI data, tools, and interfaces, as well as help to guide new developments in these areas. Moreover, CGR will enhance the NLM or NCBI held content with community supplied content, such that the sample metadata and gene functional information and other types of resource information like that to further empower scientific discovery. My first meeting of Dr. Lindberg in person, as Teresa shared, was at the Medical Informatics course in Woods Hole in 2007, another incredible human network program. This course was launched in 1992 by Dr. Lindberg and Kathy Norton, who served as the director of the Marine Biological Laboratory and the Woods Hole Oceanographic Institution Library and Archives, who was a real information and technology trailblazer as well. The course was designed to bring together medical doctors and librarians who were in a position to be change agents in their institutions. When I attended the course, I was now 1 year into my job as a bioinformaticist at Becker Library. I thoroughly enjoyed this training and consultation role on campus, building partnerships and programs for our research community, but I was uncertain about this job long term. While I was at the course, I had the chance to explore new ideas, meet incredible people in the medical informatics community who are shown here on this picture, and I know there are a lot of familiar faces in this photo, and really think about my career and what might be possible. During one chat with Dr. Lindberg, I had a chance to ask him about this. I asked him if he thought I could make a career out of this. And to be honest, I think I didn't really believe that a field of work so interesting, supportive, and fun could actually be a career for me. His reply, why not this? And why not you? Go for it and you won't regret it. And I don't regret it. After the medical informatics course, I crossed paths with him at AMIA meetings and on campus at NLM for the Blurk Grant Review panel. And without fail, he would ask me how I was doing, what work I'd been up to, and how things were going in Missouri. I appreciated his support and kindness. Since that time, I've come to realize that everyone has a special Don Lindberg story. That he was able to connect with so many in such a meaningful way is a real testament to his legacy. Looking back, my experience in the context of Don's human network of community and capacity building has set a remarkably collaborative tone for so much of what I do today. Both local and national community and capacity building initiatives, catalyzing new partnerships and projects, and helping me push against my own biases and assumptions about data and methodologies in ways that might not have been possible without this nurturing environment. I also had the opportunity to think about putting data to work in new and exciting ways, not only for healthcare research and education, but also administrative workflows, knowledge dissemination and discovery, evaluation and continuous improvement, and even understanding meaningful impact all of which has provided a strong foundation for our work at Northwestern. The Galter Health Sciences Library and Learning Center, which I'll refer to as Galter, is a next-generation, fully integrated information knowledge management hub for Feinberg School of Medicine. Galter provides dedicated support for the research, education, and patient care activities at the Feinberg School of Medicine and McGaw Medical Center. Galter is uniquely positioned as a unit within Northwestern University Clinical and Translational Sciences Institute, or NUCAT, the only relationship of its kind. This relationship facilitates important synergies across research, clinical, and education priorities on campus. We are actively involved in a wide range of research activities and partnerships at Galter, such as an NLM-funded project with the Center for Health Equity Transformation, which has catalyzed a partnership with the Chicago Public Library, Chicago Department of Public Health, and the Health Sciences Libraries at the University of Chicago and University of Illinois Chicago. A clinical informatics training program with the Northwestern Medicine Enterprise Data Warehouse. A clinical informationist program to support healthcare and a robust systematic review service across Feinberg School of Medicine, as well as extensive partnerships and activities with Northwestern's Institute for Augmented Intelligence in Medicine. Beyond research activities, we take our core library mission to heart every day. This means a few specific things. We intentionally focus our human network, including our community of users in the Galter Library team. We provide targeted and dependable services, resources, and innovations, and nurture inclusive action through our practices, collections, and spaces. We foster integrated partnerships and collaborative action. We support professional development of our team, encouraging and celebrating their professional growth and accomplishments. And we advance our deep commitment to knowledge equity and access to make our library and collections welcome, accessible, and inclusive. Our team has catalyzed enhancements in library services and spaces to support strategic priorities and advancements in information structure, aggregation, retrieval, and application. They are responsible for catalyzing remarkable enhancements in our clinical support services, educational programming, special collections, special projects, open science, research impact, and so much more. The blocks on the right highlight different departments at Galter Library, which support an extensive range of spaces, resources, and services, both physical and virtual. In addition to these departments, we also have two specialized cores, the Metrics and Impact Core in the library's Department of Research Assessment and Communications, which supports evaluation, benchmarking, and strategy needs across the enterprise, and the Data Lab, a high-tech data core for training, one-on-one consultations, and community building around informatics and data science. The modern university library is not just a steward of information, it is a partner in creating new knowledge. Over the last several years, we've initiated a variety of programs to align our library's priorities with our greater collaborative mission and set a course for the library as a 21st century research partner. To demonstrate the role of the library as a research partner, I would like to highlight just one timely topic area to show how we leverage the synergies possible through the human network of our user community and library team and that knowledge network of data and resources. In this slide, we can see data sharing activities mapped to a few of our departments in the library, further highlighting staff library team expertise on this important research topic. The Galter team is a very collaborative one and often happens in cross-department collaborative working groups. This is something we're working on now as a collaborative effort to establish the resources and services, expertise, and workflows needed to meet the NIH data management and sharing policy, which goes into effect in January of 2023. The Digital Systems Department provides expertise for the creation, development, maintenance, and support of technologies at Galter Library. Accessibility is also advanced through the information systems themselves to ensure that they meet accessibility standards and principles. Digital Systems houses the Data Lab, which includes support for the entire research data management pipeline. We are also enhancing our systems infrastructure as contributors and core developer partners on the Invenio RDM open source community to build a turnkey next generation solution for digital repositories. The department's Data Lab provides consultation and training for all stages of the research data lifecycle and links researchers with university experts at cores and other research facilities that can serve any complex needs that come in. The Department of Research Assessments and Communication provides expertise in bibliometrics and alternative metrics, information visualization for research assessment, and advisory services for increasing the visibility and accessibility of research in a digital environment. Scholarly communications and digital scholarship, including our repository, is a critical aspect of the preservation, dissemination, and reuse of research. The Research and Information Services team, shown in that light turquoise block, meets the educational, clinical, and research needs of our campus. Research and Information Services coordinates all reference activities at Galter, as well as our liaison librarian program, which pairs librarians with departments, centers, institutes, and programs to enhance communication, collaboration, and the effectiveness of our library in supporting campus education, clinical, and research needs. The Collection Management and Metadata Services team provides rapid and reliable access to resources. The department's cataloging and metadata services are core to the way we describe and make discoverable our resources and the care we take to be aware of and address biases in our information systems and practices, not only in the past, but today as well. Across these activities, we see the power of integrated human and knowledge networks. In listening to the comments of the earlier speakers and panelists, it's clear that anything is possible when we focus our investments in time and resources on a vibrant ecosystem that supports the evolution of resources and data with a human community and capacity building component. We see this in Dr. Lindberg's remarks at the end of this passage. The modern library's evolution during the next 10 years do seem somewhat more clear. More sophistication will be expected both of the user of the information and of the librarian who arranges for it. In this respect, the modern library will be ever more interesting. It is critical that we keep an open mind and unfailing optimism about what is possible when we work together to realize the vision that Dr. Lindberg had of the library as a research partner. As we look to the future, we will continue our keen focus on research, education, and clinical priorities, and will grow in ways that reflect the evolution of our campus and mission. Areas of effort will feature human and knowledge networks working in synergy to produce new strategic partnerships and the evolution of our research services and resources to harness this work to power innovation and discovery. While various priorities and opportunities will emerge over time, we will work to be nimble and continue to prioritize actions that support the role of the library as an active, open, and transformative research partner. I'd like to invite everyone. There are a number of really amazing resources that have been made available by the National Library of Medicine, and we're really just such a pleasure to go back and reread in preparation for this, and I wanted to include those here. And I'd like to thank you for your time and attention, and I'm excited to hear the remarks from my fellow panelists. Thank you.
Thank you, Christy. One of the things that you talked about that really resonated with me is how the human network that Lindberg referenced lives on through those speaking here today, those who are attending, as well as how Lindberg really leveraged the human network synergies to facilitate the creation of interconnected systems to improve health across the world. So with that, thank you so much for sharing your experience at Northwestern. Our second panelist this afternoon is Philip R.O. Payne, PhD. From the Washington University in St. Louis, Philip is the Janet and Bernard Becker Professor and Director of the Institute for Informatics, or I2, at Washington University St. Louis School of Medicine. Philip serves as Associate Dean for Health Information and Data Science and as the Chief Data Scientist. He is internationally recognized as a leader in the field of clinical research informatics and translational bioinformatics, as well as in the field of clinical research informatics and translational bioinformatics. His research portfolio is actively supported by a combination of NCATS, NLM, and NCI grants and contracts, as well as a variety of awards from both nonprofit and philanthropic organizations. Today, Philip is going to speak about integrating informatics in the health sciences library, creating a digital hub for the contemporary academic health science. Philip.
Great. Thank you, Teresa, for the introduction. And I have to admit, I'm a little daunted by the prospect of following Dr. Holmes, who I consider to be a good friend and colleague. So I will do my very best to continue the sort of high bar that she set with her presentation. So I'm really excited and honored to be here today, and I appreciate the invitation. Like many of the speakers and panelists today, almost every aspect of my career could be traced back to the influence that Dr. Lindberg had. And I'm going to leave a few remarks about that towards the end of my presentation. So don't worry if you haven't heard me speak about that. I will touch on that topic. But what I do want to talk a bit about is the efforts that are underway here at Washington University in St. Louis to integrate our health sciences library with our broader data, information, and knowledge enterprise in support of the School of Medicine's multiple missions. And you may note that I, unlike some of my fellow panelists, am not really a traditional medical library professional. In fact, I have trained and spent the bulk of my career as an informatician, and only recently stepped into a role where I took responsibility for the strategic direction of the library. So I think I'll bring a slightly different lens to this, and hopefully one that makes sense with the broader theme of today's sessions. So I want to start, well, I've already missed one of my slides. I want to start with a quote. And many people have provided quotes today, and I think in part that is because Dr. Lindberg was so voluminous in his contributions to the knowledge base. But this particular quote from Dr. Lindberg's swearing-in ceremony as the director of the NLM in 1984 was particularly prescient given what I wanted to talk about. Because really the theme here in this quote is that the role of data, information, and knowledge in modern medicine was only going to increase. And that as a result of that, the fields of informatics and library science were inexorably intermingled and central to the future success of the academic health center and really health and wellness more broadly. And I think one of the true testaments to Dr. Lindberg's leadership is that he recognized this well before, I think, almost anyone else in our field, with the exception of a few other key individuals who have participated today and have also made remarks, really fully understood. So as I mentioned, I want to start by just saying a little bit about the Becker Medical Library here at Washington University in St. Louis. And actually, Dr. Holmes did a nice job of providing a little bit of a sneak preview of that, given her prior affiliation with our organization. But I think one of the things that's interesting about the Becker Library is that it really does have a long history of working at this intersection of informatics and library science. The library is very sort of senior in its lifespan, in that it was established in 1911 and actually is one of the oldest and most comprehensive libraries west of the Mississippi. For those of you that know me well as an individual who grew up on the West Coast and then went to school on the East Coast, I've suddenly found myself as a Midwesterner, and therefore can make almost any reference in sort of correlation to the location of the Mississippi River now. But at the core of this long history of bringing informatics and library science together was a relationship that began in the early 1990s with the NCBI, where the Becker Library was deeply engaged in the development and dissemination of a number of critical tools and data resources that tackled fundamental problems in the biomolecular sciences. And it was actually because of that work at the intersection of Becker and NCBI that a core information technology and bioinformatics support unit was created in 2000. And the goal of creating this new unit was really to provide a front door to critical resources that would enable this modern knowledge enterprise in a research-intensive academic health center. And in particular, the group was quite focused on areas that you see enumerated here, such as genomics, research computing, and knowledge management. Not surprising for an institution that also housed a large genome institute and a sizable clinical, as well as translational and basic science enterprise. It was also interesting that with the foundation of this group within the Becker Library, there was a clear acknowledgement of the fundamental interdisciplinary nature of this work, in that there was a faculty advisory group that spanned both the preclinical and clinical domains in the medical school that came together to provide strategic guidance to this new unit. And one of the important aspects of the unit when it was created in 2000 was that it was meant not only to provide services, but also to invest time and energy in workforce development. It is an interesting sidebar, actually, that Washington University was also one of the very first institutions to receive a training grant from the National Library of Medicine when that program began as well, under Mark Frizzy's leadership at the time at the university. And I think that speaks again to this commitment to workforce development and the intersectionality of informatics and the library in that space. And I won't read the other details here other than emphasize that, like everyone in today's session, I have at least one embarrassing picture or magazine cover showing people dressed in sort of late 90s or early 2000s apparel, holding shockingly large computers that were high tech at the time. But nonetheless, there has been this very lengthy and intentional approach to building bridges between scientists and informatics and technology professionals that has been based in the Becker Medical Library since the very beginning of such efforts. And now I want to sort of engage in just a little bit of time travel and fast forward to today and the role that I'm in and sort of how that's reflected in the evolving mission of the Becker Medical Library. And this is really the story of how we've created this new unit, which we call the Office of Health Information and Data Science, which I lead in my role as Associate Dean here at the School of Medicine. And I won't bore you with the details other than to point out in this timeline that the development of the Office of Health Information and Data Science has been relatively short in duration as compared to the lengthy history of the Becker Library, and actually dates back only to 2016 with the formation of the Institute for Informatics, or I2, at the university. And now today, we've really created an integrated academic home for informatics research, practice, and education. We've brought that group together with our biostatistics and data science teams, as well as research, computing, and data infrastructure, and the Becker Library, in order to create an integrated unit that really spans the full spectrum back to that theme from data to information to knowledge. And this has really been a major change for our institution. For many who know WashU, we are, as I often affectionately use the phrase, pathologically decentralized, in that we enjoy building very robust silos of excellence across our enterprise. And we've been very successful in driving critical advances in basic and clinical and translational research for decades in that mode of operation. Yet there was also a clear recognition by our leadership that in these critical areas of data, information, and knowledge, we really needed something that was purposely built to be horizontal and cross-cutting and really support all of our mission areas, which is where this office becomes really the hub for that work. And you can see here our mission very clearly is to bring those pieces together and in fact create the infrastructure, the workforce, and the scientific discoveries that really will drive precision medicine and our ability to improve the quality of health and healthcare locally, regionally, and nationally. And certainly St. Louis and the surrounding region is a microcosm of the challenges that face the national health system here in the United States, and thus is an ideal testbed for many of these initiatives. This is sort of the abridged version of what this office means in sort of practical reality, which is that it houses a informatics unit that spans a spectrum from translational bioinformatics to clinical informatics to population health, a rapidly growing biostatistics and data science research unit, shared educational and workforce programs, all of the fundamental structures and functions that make up the Becker Medical Library, as well as all of the research, computing, and data infrastructure that sits under what we call our Office of the Chief Research Information Officer. And we see this as sort of the template for a next generation academic home that, again, is quite horizontal in its nature to achieve all the goals I've talked about. And you can see a number of the research highlights here, but I would point out that almost every one of these research domains, which also involve practice in terms of services and practical tools, have been in some way supported or enabled by the activities of the Becker Medical Library. So there's deep integration across all of our research teams, as well as the services and training programs that we offer to our medical school curriculum as a function of this tight coupling of the Becker Medical Library and all the other units that make up the office. We'd also be remiss if we didn't talk about educational programs, because as much as we would like to believe that we can recruit every single person to St. Louis that we need in order to tackle these large and complex problems, we simply cannot do that. And so we're very committed to growing a workforce locally that works at this, again, intersectional space. And we do that in traditional ways that many of us are familiar with, but also in equal measure in what we believe are quite innovative ways, such as K through 12 outreach and engagements and a very, very robust regional internship program that brings in trainees who get experience in the Becker Library, in the Institute for Informatics, and in our research computing services group all at the same time. And of course, all of the other components that you see enumerated here. But the takeaway is we're very committed to building the pipeline of future trainees and exposing them early and often to the fields of library and information science, as well as informatics and data science, and training a workforce that can work in equal measure across all of those areas. And that also leads to the services that we offer. And I want to draw your attention to the role of the medical library in that regard, because one of the key roles, and perhaps one of the most important roles that our library serves today as a digital hub for our campus, is providing practical training in all of the tools that our researchers need, not only to survive, but thrive in a modern data-intensive research environment. And this is a critical role that I think the library is uniquely suited to fill, in that their sort of capacity as an impartial and central hub for the campus, not connected to any particular disease domain or basic science domain, but rather focused on these data, information, and knowledge related activities, makes the library a trusted partner for delivering this type of training, as well as access to these services and capabilities. And increasingly, what we've done is position our library as the front door or on-ramp to all of our informatics, data, and knowledge management services. And I'll say a little bit more about that in a moment. And so that really leads me to the final part of my remarks this afternoon, which is really, how are we innovating, sort of going from that history of the initial establishment of the Becker Library and its very early leadership in informatics, to this new structure with the Office of Health Information and Data Science, to sort of looking forward. What comes next for our organization with this structure and means of operating? So first and foremost, when we talk about the future of the library, we talk about it as a hub for what is increasingly, if not essentially, a digital knowledge enterprise that characterizes all parts of our teaching and learning, research, and clinical missions here at Washington University and with our partners at BJC Healthcare. And that means, in addition to the collections and knowledge resources that we provide today, we also are increasingly focused on creating what we call centers of excellence. Some of them are areas that might be familiar to many of you, such as our Center for History of Medicine, which, in addition to providing access to all of our archives and other historical documents, serves as the official historian of the medical school, so that we can learn from the prior history of the research and educational and service activities of the lengthy history of this institution. We also recently created a new Center for Health and Science Communication with the explicit goal of helping to train our scientists and practitioners to better communicate their work with the general public. And I think we can all acknowledge that the trust gap between the general public and academic medicine has never been greater than it is today. And one of our key roles and responsibilities is to help address that gap and bring those parties closer together with shared understanding. And then, of course, in a way that's similar to some of our other peer institutions, we have a deep investment in growing our evidence synthesis review service to truly help our investigators navigate increasingly complex knowledge resources as they pursue their research endeavors. As I already alluded to before, we've also established the library as our on-ramp to informatics and data services. And this is really about, how do people come in and find those services? Because by and large, our investigators, our trainees, our practitioners don't necessarily know what services or capabilities they need. And it's unreasonable to expect that they would navigate the myriad of resources that are present. What we really want to do is provide, and I think Dr. Holmes referred to it earlier, is white glove service, wherein human experts help our investigators, our trainees, and our clinicians to navigate these myriad resources. And importantly, again, we provide a number of emergent platforms, such as our expertise profiling systems, and then our institutional data repository, which we've stood up in conjunction with our new data management services to help our investigators navigate the new NIH data sharing policies and embrace a culture of open science and sharing here at our campus. When we think about future directions for the library, we are now increasingly focusing not just on the medical school, but also the campus writ large. And we've just launched a program to initiate a 10-year digital transformation program for the university, which brings many of the lessons learned from the formation of the Institute for Informatics and the other components to the rest of our campus. We're also increasingly looking at how we can expand our digital collections, and particularly those that are relevant to just-in-time information and knowledge needs at the point of care, and expanding that to our entire health system. So in conjunction with BJC Healthcare, we want to provide these just-in-time knowledge resources to practitioners across all 14 hospitals in a 300-mile catchment area, including both rural and community hospitals and academic tertiary care centers, really sort of democratizing access to these knowledge resources. We're also using the library as a hub for navigating how do we provide new modalities of support for all these data information and knowledge management needs, given the sort of evolving nature of our hybrid workforce in this post-pandemic time period. And then also providing new tools and resources to increase utilization of public data sets and repositories that are increasingly central to research and innovation endeavors. And then finally, and a little bit more sort of pragmatically, we're looking at the space that physically makes up the home of the library and ascertaining how does it truly become the hub for convening and team science activities across our increasingly geographically distributed campus. So I'll just end with a slightly embarrassing picture, but one that I think is apropos of my comments about my own personal connection to Dr. Lindberg. And this is a picture actually from a location at the University of Missouri-Columbia, our key partner in both our CTSA and Cancer Center programs, and located just a little bit less than 2 hours from where I am today in St. Louis. And the first time I visited, shortly after coming here to St. Louis 6 years ago, I went to Columbia and I had the opportunity to see this display, which is in recognition of the Donald A.B. Lindberg Award that is given each year to excellent faculty in the health informatics program at Mizzou. And it was sort of a prescient moment as I looked back upon the impact he's had on my career. And that impact has been multifold. There are certainly geographic and sort of institutional affiliations that tied us together, including the fact that Dr. Lindberg was a Columbia alumni when he received his MD, and I was fortunate enough to train in informatics in the Department of Biomedical Informatics at the College of Physicians and Surgeons. Certainly the connection here in Missouri. I would not have had the opportunity to come into the field of informatics if not for the NLM fellowship support that I received. And I remember fondly the many convening events of the NLM trainees, including, I think, and perhaps most importantly, many of the social events that Dr. Lindberg helped to organize, even though we were all quite intimidated by him at the time. And then when I sort of fast forward in my first academic leadership role at The Ohio State University, when we were fortunate enough to receive a T15 training award, during the final site visit, Dr. Lindberg, as well as Dr. Korn, came to Ohio State to visit us and talk about the program they were planning. And I always remember because Don had a very dry wit at times. We showed him space that we had for our students to engage in collaborative and team science. And as we showed him the space, he looked at me and he said, "You just created that space just for this visit, right?" And it was because he could smell the fresh paint in the room. And that was entirely true. And he left it at that. But I think that was apropos of his sense of humor. And then I think perhaps most importantly to me, I had 4 years of having the good fortune of serving on what at the time was the BLERC, the standing study section of the NLM. Actually, Dr. Holmes and I were on that committee together for a period of time. And perhaps the best part of those meetings were what I refer to as the family dinners with the study section and Don and Mary, where we really got to hear sort of his view of the history of the field. And then lastly, I'll just share that most recently, I had the opportunity to help lead a strategic planning process for the American College of Medical Informatics, which included thinking about the history of that group, which we've already heard about earlier today, and how it might evolve to meet current needs. And this is towards the end of his life. And Don was so generous with providing his sort of historical insights and knowledge as I navigated what was a very politically tenuous process of sort of reshaping the future of ACME. And I was immensely thankful for his willingness to share his time and knowledge. And I will always remember that very fondly when I was doing that very critical work. So I'll just say, like many of us in our field, Don has been a giant in the field of informatics, hugely impactful, and has shaped my view of the world, which I hope what I shared with you today is manifested in how we're bringing our informatics and library teams together. And I'll just conclude by saying I think that this is consistent with Don's vision for this intersectionality of informatics and library science and medical libraries. And I think it's only appropriate that that would be happening here in the Show Me State where Don started his career. So thank you again for the time, and I will turn it over to our moderator and look forward to our other panelists' comments.
Thank you, Philip. I have reflected too on how, in many ways, the whole Don Lindberg journey in informatics really started in the Show Me State at the University of Missouri and the deep connections at the University of Washington in St. Louis, and how that has propelled informatics forward. Additionally, I think that Don's leadership at the National Library of Medicine and how he encouraged the organization to fund research in informatics and in training programs, I think is especially insightful. And one of the things that I found especially meaningful about what you're talking about is that libraries, and particularly librarians, because it's librarians who do the work, really have the ability to serve as this impartial and connected hub, bringing trusted partners together across the university as we engage in team science and advance our research. So thank you so much, Philip. I do have one more thought that I want to share. I think that apparently we need to create a compendium of Don Lindberg quotes that would inform future generations that might be welcomed by many. Our next speaker is Peace Awesome Williamson. She has her MLS and a master's degree in science. Peace is the Associate Director of the National Center for Data Sciences for the network of the National Library of Medicine at the New York University Health Sciences Library. Peace's expertise includes data sciences, scholarly communication, and outreach in libraries. In recognition of her research, Peace received the 2021 Texas Women's University Hallmark Alumni Award, as well as the Medical Library Association's 2020 Ida and George Eliot Prize for an article she co-authored. The Ida and George Eliot Prize recognizes the most effective article in furthering medical librarianship. As an active educator, Peace teaches research data services and libraries at San Jose State University and public health informatics at the University of Texas at Arlington. Today, Peace will address expanded expertise in emerging specialties, the role of librarians embedded in each stage of research. Peace.
Thank you so much, Teresa. I don't know if I need to take control. Okay, I have control. Wonderful. Okay, thank you so much for the invitation and for the opportunity to speak today. I'm really excited to be part of this panel. I think that it represents numerous perspectives and really all of the roles that medical libraries can touch in all of the fields. Dr. Holmes and Dr. Payne spoke from perspectives of biochemistry and informatics. As someone who did not know Dr. Lindberg personally, I'm here to provide insight into how his vision carries on into current and future developments in libraries. This computational focus of Dr. Lindberg and now Dr. Brennan came in advance of many of the clear examples of its need and its impact as evident during the COVID-19 pandemic and beyond. I'd like to challenge us in libraries to continue to investigate and engage in metacognitive processes where we evaluate where our field is heading, with a focus during this presentation on data librarianship. Dr. Lindberg created programs that changed fundamentally the way that biomedical information is collected, shared, and analyzed. Through all of the computational changes he oversaw at the library, he still valued primary resources and original documents and the stories they told. In an introduction he wrote in Hidden Treasure in 2011, he wrote that speedy computer access to information is truly wonderful. Yet there are times, especially when we ask why or how a discovery or a belief arose, when we need to see and hold the original intellectual work in context. As a data librarian, I often emphasize the importance of the domain of expertise in addition to the data literacy that's necessary for understanding broad trends. You cannot have one without the other, and it is incredibly important to have that expertise partnered with the interpretations that take place. Under Dr. Lindberg's leadership, NLM embraced the internet, enabling the public, health providers, and scientists to gain new or improved access to medical literature via PubMed and PubMed Central, clinicaltrials.gov, and consumer health information on Medline Plus. He played an integral role in the establishment of the National Center for Biotechnology and Information, which we've talked about numerous times today. But I'm going to talk about how that leads into the current roles of data librarianship as we move forward in discovery. My focus today is mostly on the topic of open science. It's something that I champion, it's something that I'm incredibly passionate about, and I believe that a lot of the developments of Dr. Lindberg and the NLM have led toward the advancement of this aim. Open science is the natural wave of this movement, and it focuses on transparency and accessibility. Research aims, methods, materials, and processes should be made as openly available as possible, which include open licensing. Open, as defined by Open Knowledge in 2005, involves a standard which allows for reuse and remixing. However, in order for open science to occur, it involves a combination of infrastructure, policies, and guidelines, incentives and tools, in addition to resources, skills, and effort. Librarians are natural partners in this endeavor. As librarians are leading the open movement alongside many other scholars and activists, the open movement seeks to work towards solutions of many of the world's most pressing problems in a spirit of transparency, collaboration, reuse, and free access. It encompasses open science, open government, open pedagogy, and much more. Participatory processes, sharing of knowledge and outputs, and open source software are among its key tools. The specific definition of open as applied to data, knowledge, and content is set out by the open definition. And with these aims, many libraries are actively transforming by increasing their capacity for supporting the open movement. The librarian is active in the effort toward advancing open computing, data-driven biomedical research, and open science through expertise in information organization and information literacy. Now, some data to back up my claims. Open is clearly something that's influential. We all know this with the current pandemic, but even prior to that, we saw evidence of that, where openly published research had increased citations, increased views. Not present on this slide are also more accurate representation in how it's being portrayed in news articles. We also see that the field usage, as evident in the SNP score, is higher for research that is open. And this is really kind of more obvious as you think about when the entire article is made available and open, people are much more able to understand what occurred and be able to replicate it. In addition, we call it a movement because we are moving in that direction. As of 2019, 25% of research being published has been published open access in all of the research that can possibly be studied using unpaywall data. So what does open mean and what does it involve? Let's take a look. Here is a very simplified view of the research data lifecycle. And we see how libraries are active partners here. As previously mentioned, open science involves an investment of resources, support, and effort at multiple levels, and they exist at each stage of this research data lifecycle. In this pictured simplified data lifecycle, you can see planning, acquiring, structuring, analyzing, and sharing data. Libraries have developed services and built infrastructure at many, if not all, stages of this process. If we look at what this process looked like traditionally, it involved a great number of proprietary tools. These are often commonly used for open publishing with a shift in the end at that sharing stage. However, many of these tools come at a significant cost that all cannot afford and work within tools and environments such as utilizing proprietary file types and statistical software that does not track the actions that are taken and can inadvertently be inaccessible to others and make reproducibility more difficult or impossible. In 2005, Dr. Lindberg and Betsy Humphreys wrote, In the future, journals are still an important vehicle for disseminating peer-reviewed research results, but many individual articles have electronic lives of their own. Much scientific information is available free over the internet, thanks in part to earlier efforts to make information about clinical trials and government-funded research available to the public. So many sources of electronic information required paid licenses. In this, he and Ms. Humphreys began to highlight efforts toward open resources and digital libraries to inform researchers and the public. As researchers shift to open science methods, new processes and products are necessary for transparency and accessibility at each stage. Looking at this simplified model again, with some examples, there are many, of open tools, software, file types, etc. at each stage, we can see there's a lot involved in the movement toward open science. Unfortunately, the true integration of multimedia information is still either not simple or cheap, says Dr. Lindberg. Technology that supports ready online access to full text, pictures, sound, video, etc. continue to evolve quickly, and technology companies derive more income from selling services than from selling hardware, which makes it less of a priority. A library back in 2015, which was what he was looking at as far as 10 years in the future, continues to be the logical entity to manage this complexity on behalf of the institution, to make decisions about inevitable and substantial expenditures, to adapt information services to new realities, and to provide essential user training and support. Again, this was something written by Dr. Lindberg in the New England Journal of Medicine in 2005. And you can see that that rings extremely true as we look at this model and open examples of each stage and think about the entire environment of the open movement today. As data have become easier to collect, analyze, and reanalyze, store and share, and as processes toward open science become more complex, there is a growing demand for data literacy skills, data technology, and infrastructure and process implementation in research. Libraries, particularly research and medical libraries, are expanding services to support these practices, particularly services for research data curation and reuse. In this context, I describe data curation as encompassing managing data throughout research and the process of making data fair, or findable, accessible, interoperable, and reusable over the long term. Libraries are now building open platforms like repositories and data portals, teaching classes on use of open software, and more. Librarians are partnering with larger resource providers to simplify and make easier the process for their researchers in using their resources. For example, I live in Texas. We have the Texas Advanced Computing Center, which has storage options, cloud computing, and statistical services, in which research data librarians assist researchers in making use of. Research data services, or RDS for short, have become a critically important topic for academic libraries, medical libraries, and research libraries of all kinds. With the average R1 classified university employing a range between 0 to 10 librarians, with an average of 2 data librarians per institution, assessing the data services being offered in ARL member libraries, some researchers in 2018 placed them into the categories of information access support, technical support, and personalized consultation. And these describe the acts of providing the information, the technology, and in-person assistance to be able to work in this new landscape. Many libraries have information placed online or in places such as the Data Management Planning Tool, or DMP tool for short, but they are limited in the consultation category due to a number of factors, which could include the number of them, again, mentioning that the average have 2 per institution. Working with all of the researchers in one institution is quite an undertaking. The financial aspects of the infrastructure and more. In addition, the focus has been on the preparation and the final curation of data, where fewer librarians provide support for data acquisition, processing, and analysis. However, that is shifting. So I'll talk a little bit about each stage, and we'll circle back into kind of, again, looking at the future of libraries. So thinking about the planning stage, in addition to data management planning, librarians can advise on components of a good protocol and assist with pre-registration. We also work with colleagues across campuses to develop guidelines and make resources and services more clear. This includes working with research offices, IT departments, information security, innovation and commercialization offices, and more. Together, we work to communicate across these offices to make requirements clearer and more consistent to researchers while providing services to support their work. Librarians are collaborators with specialized skills. We are able to help researchers across this life cycle, from reviewing data management plans to assisting with data sharing and publishing. We do this by helping researchers one-on-one during consultations and by holding workshops where we teach different data analysis and visualization tools. Depending on expertise, librarians can provide guidance on best practices for designing data collection tools, particularly surveys, to have well-structured data at the completion of their collection. And as I mentioned, we've provided significant amount of training on software, programs, and other tools for data collection. For secondary data, librarians have awareness or the ability to find data sources that may be useful for research, and we assist researchers in the process of submitting requests or applications to data sources, including projects and data that you may be familiar with through your local health department, other data sources like CMS data, and so on. Some libraries also kind of exist within the center of the data lifecycle, including working to help researchers in structuring their data and analyzing them. I mentioned the idea of creating workshops, online tutorials, and tools, and helping people one-on-one in consultations with data structuring, database design, and also working with analytical software and research methods. Two decades ago, Dr. Lindberg stated, "If I read and memorize 2 medical journal articles every night, by the end of a year, I'd be 400 years behind." Adam Marcus stated in Dr. Lindberg's obituary in The Lancet that this was a statement from 2 decades ago. So imagine how wide that gap is now that millions of articles are published each year. And we saw this ramp up even further with the COVID-19 pandemic. His career focused on applying the power of computers to medical research, discovery, and information access. As a researcher, he led the development of AI systems, and he wrote that the flood of patient-specific data generated by large-scale prospective normal cohort students presents special problems. And I don't want to skip over the problems that are involved in a lot of these processes and the amount of commitment that it takes to be successful in moving toward this movement. Not pictured are the numerous NLM products and data sets. I only had so much room in that life cycle picture, but a lot of NLM work focuses on metadata, such as the Unified Medical Language System, DailyMed, ChemID+, and so on. Before the UMLS, databases lacked common terminology, and these systems have numerous uses for information sharing, compilation of evidence, and interoperability. This is a key area of leadership coming out of the LIS field, as librarians can and are helping usher researchers past standalone data sets toward fair data and interoperability. Hopefully the text isn't too small in the slide, but I also wanted to point out some other areas of support that libraries are offering. I think these will only grow and intensify with all of the memos and policies that are currently coming out. But some of these include helping researchers find where to publish, funding article processing charges for open access initiatives, with the idea that funding you on the front end with a one-time charge to make your article permanently public, where you're saving that library the funds of continuous subscriptions in order to maintain access to those articles. Assisting with copyright and helping researchers navigate their copyright agreements to, possibly have their articles open as possible, not just their articles, but also their data sets, and then assessing the research impact on the back end. I don't want to forget to point out that librarians are researchers as well. We have a number of domain-specific expertise, particularly in medical libraries. Many of us have, as Teresa mentioned, I have a kind of public health background, and others have backgrounds in biology, chemistry, and so on. We also have our initial focus, which is around information literacy and information access, information organization, and now scholarly communication as that field grows. With all of this, I hope this helps you look forward toward where libraries are going, opportunities for libraries, and the legacy that Dr. Lindberg has set by focusing on computers in medicine and in librarianship. You can also see this legacy carried on within NLM in continued R&D with LitCoin, common data elements, and advances in medical research description and access. Again, thank you all so much for having me as a speaker, and I look forward to your questions.
Thank you, Peace. That was excellent. I really appreciate that. And in listening to what you said, I see some common themes from science data, team science, collaboration, open access through science, solving problems, how librarians can serve as a partner in the research enterprise. And from everything I know about Don Lindberg, this really reflected his vision of the future, where librarians are collaborators and connectors in the research ecosystem. Before we move on to other questions, I do have a question for Peace, which is, with the new announcement of the White House Office of Science Technology Policy last week that the embargo is going to be removed and that there's going to be a focus on sharing of data, how do you foresee librarians working in that space? Or how will it change the practice of librarianship?
Yeah, that's a great question. Thank you for asking. For those who are unfamiliar, the White House just released a new memo, which included basically 4 large changes to the previous OSTEP memo, in that there are no more embargoes. So any research that's being published from federally funded agencies must be made immediately available by deposit in acceptable repositories. And that includes not only the article itself or the publication itself, but also the underlying data, as well as the metadata describing kind of the researcher and, just making some of that research process transparent. In addition to that, all federal funding agencies must now adopt these policies, when the previous memo was only to the largest agencies. So that includes agencies like NEH, which was not originally included. This promotes equity in access to research. It increases trust in the research that's being participated in, and it makes sense. Taxpayers are funding this research, and that research should be made available for any use. We also saw the importance of this, of course, as I mentioned numerous times, public health side, I have to, is during the COVID-19 pandemic, where the access to information allowed for the speedy creation of things like vaccines and understanding of this virus. So what is the role of medical libraries in all of this? Well, I'll be honest, I'm already hearing from medical libraries in terms of what this means. Not only this new OSTEP memo, but the NIH policy that is coming into place in January. As these policies and memos work toward motivating researchers toward openness, they are looking to their libraries to support them as they engage in the changes necessary to be able to foster that. Not only the researchers, but I mentioned that in my presentation, also the institution as a whole. I worked when I was a data librarian with a number of non-academic units to create policies within the institution that aligned with these federal policies and memos, to also create infrastructure that made it easier, and to look at the software and tools that we have available and how can we make them as seamless as possible and as focused on reproducibility and openness as possible in order to do that. That it can be things like teaching how to make use of tools that allow for reproducibility, saving in open file types, and depositing in these repositories that are being recommended federally. So I think there are a lot of opportunities for libraries, and it's a matter of getting engaged in this process and also looking at the leadership coming out of the NLM.
Thank you, Peace. That was excellent. So we do have a question for the panel that I would actually ask each of you to answer that, which is, what other frontiers and opportunities do you see for your institution? So we'll go back to the order that we started, which is Christy Holmes from Northwestern first.
Sure, thank you. So for me, I mean, I think the sky's the limit. It's been a remarkable day to hear about all of the ways that that we see intersections between data and informatics and research activities, and the people that not only do this work, but the people who benefit from it as well. So the thing that's making, I think, me most excited these days is the role that libraries can play in equitable access to research. So taking advantage of not just technology, but social strategies, working with people, engaging in real ways, partnering with communities, community-led research activities, so that we're really making the most of these incredible investments by American taxpayers. So it's not perhaps as technologically strong of an area. I don't see a lot of huge work to build technology or data standards necessarily, but I do think that it's something that requires intentional action. So it's something that everyone agrees is a worthwhile activity, but it's really hard to be intentional about it. And so that's something I've been thinking a lot about these days. And I'm really excited about the work that libraries are playing to help to advance this work in many different areas.
Right. Thank you, Christy. Philip?
Yeah, so I'll give 3 concrete examples that I think actually are just emblematic of some bigger themes. So I think you heard all 3 of us talk about in different ways the critical issue of communications, and in particular how we equip our various constituencies in our academic health centers to more effectively communicate with the broader public. And I think that's a unique role that the libraries at our institutions can fill, certainly at our institution, and an area where we really want to lead, because we believe that the trust gap between our communities and our researchers and practitioners is an impediment to achieving sort of critical goals around access, affordability, equity, and improved overall population level health. And it starts with being able to communicate and get people to sort of understand and have a sort of shared framework for the current state of the art in health and healthcare. So that's one big area. I think the second area, and I alluded to this, is how do we better help our investigators, specifically in the research arena, navigate the myriad of large public data resources that are available. And at the risk of sounding like I'm making an editorial comment, I'll say that, you know, the natural tendency of funders and researchers alike when given the opportunity is to create yet another data set. And the question is, you know, are we fully leveraging the very expensive and, you know, very sort of voluminous data sets we've already created before we create yet another data set? And I think that begins with helping people to understand and discover what resources are there, how it can augment what they may be doing at a laboratory or clinical research or population health level, and then bring those pieces together. And again, I think it's a unique role that the library can fill. And then the third, which is much more aspirational for us, is that, you know, we have a very large health system, and we all know that, you know, health systems are increasingly aggregating and creating larger and larger networks of both ambulatory and inpatient facilities. And we have really just this incredibly diverse workforce of individuals at all of our facilities that need access to just-in-time contextual information sources. And we believe that those individuals will benefit greatly from the expertise and capabilities that a medical library brings to the table in terms of delivering the right information, the right time, place, and format. And of note, that's like a critical intersection of informatics and library science. And so we're really focused right now. Like I mentioned earlier, we've got 14 hospitals over a 300-mile catchment area, and they're not all tertiary care academic health centers. In fact, that is the minority of sort of the beds and employees in our system. And so the question is, how do we extend the reach of our medical library to meet the information needs of those individuals, where we can see direct impact on not only education and workforce development, but patient outcomes and quality and safety and value of care? So those are sort of three big themes that we're particularly focused on in terms of sort of frontiers and opportunities that we really want to pursue.
Thank you, Philip. So Peace, the question is to you as well. And I don't know whether you want to put on your NNLM National Center for Data Services or one of your other hats. So again, what other frontiers and opportunities do you see for your institution? Pick an institution.
Yeah, just thinking generically, I think just to add to something that Philip said about kind of always wanting to create another data set, is the idea of the massive amount of information that is currently existing, and kind of going back to what we know about human subjects research and the idea of respect for persons, and thinking about honoring people's participation in our research, whether it's a survey or something a lot more involved, or even just making use of their, you know, EHR data. This is something that we need to remember, and I think that also drives our aim toward the open movement of, rather than kind of recreating every time, we're making use of what already exists. And I think libraries can help drive that. In addition, I think that there's so much to develop in terms of linked data and interoperability, making use of, there is some talk about machine readable data in the new OSTEP memo, but, you know, just thinking about more than kind of static data sets and how we can build infrastructure for that future. I also think that there's a push-pull between you know, participant and patient privacy and confidentiality of their information, and scientific advancement, and how to respect that, particularly as we think about marginalized communities and who is involved in the research and who is involved in kind of as the researcher and as the like patient and participant. So I think that libraries have a lot to develop and to explore in terms of moving this forward in a way for discovery, but also in a way that respects persons.
Great. So the other question that's come in from the audience is, Dr. Payne explained one focus of his institution, among key others, is to be the history of medicine. Can you please describe how this focus fits with and contributes to the contemporary mission of Washington University, St. Louis?
Yeah, so it's a great question. I would begin by saying I'm a little bit of a history nerd. So fundamentally, I'm always excited about our Center for History of Medicine and the archives collections and the other activities of that group. But I would start by saying, we recently went through a process of refreshing our medical school curriculum. And we really found that there were 3 essential themes that weren't reflected in our current curriculum that we wanted to embrace with that refresh. One was really preparing our providers to be more humanistic and more able to serve as advocates for the patients and communities that they serve. The second was to incorporate public health competencies into sort of the core competencies of practitioners. And the third, constructively for us, was to incorporate digital health and informatics and data science as sort of another core competency. But from our perspective, being able to prepare future practitioners that sort of embrace the humanistic side of medicine and that are able to advocate for the communities that we serve begins with understanding the history of how those individuals and communities have been served in the past. And that history is both positive and negative. And our Center for History Medicine both provides sort of the tangible artifacts and the expertise to help people navigate in sort of a given domain, sort of all of those knowledge resources, but also, as I mentioned earlier, serves as the official historian of our medical school to speak to sort of the role that we've played. Again, both positive and negative, because I think we all have sort of, dimensions of the histories of our institutions that we look back at and in a current historical context, require some deeper analysis and understanding. And so that is a central role of that center. And we also want to support both trainees and faculty that want to make the history of medicine part of their scholarly endeavors. Again, reflecting that humanistic angle of the field. So when you put it all together, the value of history, this is the history nerd in me, is being able to learn from prior sort of positive and negative lessons and then transpose and understand that in a current and contemporary context. And that's exactly what our center does on a daily basis.
That's
It also, as a sidebar, has the distinction of being very popular for the fact that there are a couple Nobel medals there that on occasion you can go and actually hold. So if you ever are so inclined and you're in St. Louis, we can arrange that as well.
That's awesome. So Peace or Christy, do you have any thoughts on that as well?
I'd like to weigh in. So actually, we have a number of really important partnerships that flow through our special collections. It allows us to be able to ask questions and investigate topics in a much more nuanced and I think engaging way than simply a report or a discussion topic. And so one resource at the National Library of Medicine that I'd like to highlight is the exhibition program. And that's been a really tremendous opportunity for us to be able to catalyze conversations on our campus across a wide variety of topics. And so this exhibition program, it's really fantastic. There are resources that travel around the country. There are banners and other kinds of exhibit materials, and you're able to set it up in a way in your space, whatever that is, that provides a way for the attendee or for our patrons to be able to look at this content in new ways. And then we supplement that with materials from our special collections that may look at that topic from a historical perspective. We also then use it as an opportunity to catalyze conversations that perhaps may be related to the topic in the exhibit. And so it provides a really, I think, a setting, an environment to ask difficult questions, to perhaps ask ourselves how we're contributing to some of these topics or conversations. How are we advancing what's happening on our own campus and in our community in meaningful ways? And it's been a great catalyst for networking too. We have a number of conversations and partnerships that have started as a result of conversations that have started from those activities in the past. So we're delighted that this program has started again from the National Library of Medicine, and we'll look forward to hopefully being able to bring one of those exhibits to Northwestern.
Thank you, Christy. And I can echo what you're saying, because when we bring those exhibits in, we do programming around it that allows us to contextualize the history of medicine in Richmond, Virginia, and across the country. It's a unique learning opportunity for many of our users. So with that, I would like to thank the panel for sharing their knowledge and experience. I Very much appreciate your contributions to the session this afternoon. And I'm going to turn things back over to Jeff.
Thank you very much, Teresa, and to all of our panelists. Outstanding presentations and a great Q&A. Really appreciate your time and your engagement with us on this wonderful day. And we are going to take another break for 15 minutes. Our proceedings will pick up around 5 minutes to the hour. So please come back and join us for our last two presentations of the day. Thank you very much. Welcome back to the 2022 Lindbergh King Lecture and Scientific Symposium. My name is Jeff Resnick. I'm chief of the NLM History of Medicine Division, and it's been my distinct privilege this afternoon, all day, to moderate our proceedings. For those of you who are just joining, please use the live feedback button under your video stream to send questions or comments. We're going to continue with our program, and in so doing, it's my great pleasure to introduce Betsy Humphreys, who is with us to offer her reflections on Dr. Lindbergh's leadership and scientific legacy. Betsy retired as Deputy Director of the National Library of Medicine in 2017 after serving in that position for 12 years. Throughout her 44 years at the NLM, she took on many responsibilities, including serving as NLM's Acting Director, where she was responsible for all of the library's activities, ranging from program development to evaluation to policy formulation. Betsy contributed to the development of NIH and HHS policies on health information technology, public access to research results, and clinical trial registration and results reporting. Her earliest accomplishments at the NLM included automation of internal operations, leadership of NLM's Library Operations Division, where I work, and direction of the Unified Medical Language System UMLS project. And very notably, Betsy recently co-edited a very important book entitled Transforming Biomedical Informatics and Health Information Access, Don Lindbergh and the U.S. National Library of Medicine, published this year by iOS Press. Welcome, Betsy. Great to see you, and I'm going to turn things over to you. Thank you.
Oh, okay. Thank you, Jeff. This has been a great symposium, a really interesting day. Of course, I love hearing about the wonderful things that people have done with NLM's data and services. I enjoy seeing people who were helped early in their career by training opportunities that NLM provided. And so it's a great treat for me to listen to people, many of whom are my long-term friends and colleagues. So I've enjoyed it a great deal. I think that Don would have approved of a program that began with a focus on patients and included so many stellar people who have benefited from NLM's services and training programs. He would also have resonated to the recent comments about needless creation of new data sets, respecting research participants' contributions by enabling reuse of their data, and the value of history, and of NLM's traveling exhibition program, which is really part of his legacy. He was a tremendous contributor to NLM's History of Medicine programs along multiple dimensions, including really invigorating the on-site exhibition program and really pushing traveling exhibitions. So he'd be glad to hear that people are still using them and enjoying them. Having listened to everyone's comments about Don's outstanding qualities as a leader and a person, you know that I was beyond fortunate to have worked directly with him for all of his 30+ years at the National Library of Medicine, and to have had the advantage of him as a mentor, a great boss, and a good friend. And because of the latter, also, because of all these roles, really, also becoming a great friend of Mary Lindbergh and knowing his family. I think that it's obvious that Don was a great boss. He gave people who work for him, myself and others, challenging opportunities, resources, lots of running room, good advice, backup when things got sticky, and plenty of limelight. Don started many things, and if you came along later, 5 years later, 10 years later, 15 years later, you might have said, well, what did he have to do with this? I see, Alexa, I see Betsy, I see David Lippman or whomever. And it's because that he got things started, he delegated, and he gave a lot of freedom, and he didn't need to be the front person for the things that he turned over. He was very interesting in what he spent his personal time on, very judicious. He had a particular view of looking at each activity and seeing whether the direct participation of the director of the National Library of Medicine could make a difference. And in a lot of areas that involved making underserved populations realize that NLM was serious about working with them and helping them, or encouraging leading lights in the field who are headed to retirement to deposit papers where they would be taken care of, and in coming up with great ideas about how technology could be used in a particular NLM program. He would be passing off great ideas and focusing on some of them. So that was another aspect of his great leadership. Like Dr. Kohani this morning, I'm going to start by reminding you about 1984. In that year, trained searchers, primarily librarians, conducted less than 3 million searches of NLM databases and paid their fair share of the commercial telecommunications costs to reach NLM's computer system. They searched Medline and other bibliographic thesaurus, chemical, toxicological, and cancer databases. The library's network managed by NLM, the library network managed by NLM, probably filled about nearly 2 million requests for full text journal articles, although it would be a few years before DocLine could actually count them. In 1984, all the index citations and abstracts were keyed de novo for the Medline database. Some of the data in the factual databases were received on magnetic tape from other federal agencies and organizations, including the Chem Abstract Service, actually. And NLM licensed Medline to other US online database providers and had formal agreements with the Pan American Health Organization and the governments of 13 countries to facilitate access to Medline outside the US. By 1984 standards, this was very heavy use. Now imagine that you are very familiar with that picture of NLM, you know all about it, but just before Don Lindberg arrives as his director, you are kidnapped by aliens and taken to another galaxy. 31 years later, they decide to punish you by returning you to Earth. Knowing the NLM of 1984 and being apprised of the general tremendous expansion in worldwide access to advanced computing devices and the internet, what would strike you as the most surprising aspects of NLM services in 2015? I think it would be what was entirely new and had no precursor in 1984. My comments are going to center on how expansion of NLM's scope from 1984 to 2015 occurred and the role of Don Lindberg in making it happen.
Excuse me, Betsy.
Yeah.
Hi, pardon me, it's Jeff. We're not seeing your slides advance and you do have control.
Yes, that's because it's not ready to be advanced yet.
Fair enough. All right, over to you. Sorry, we just wanted to do this.
I failed 101 in presentation by having so much to say about before I advance my slides. At
Very
any
good.
rate,
Thank you.
at the time Dawn retired in 2015, I first encountered Stuart Kaufman's ideas about the adjacent possible and their application to institutional innovation. Kaufman theorized an additional contributor to evolution. Quote, "It may be the case that biospheres, on average, keep expanding into the adjacent possible. By doing so, they increase the diversity of what can happen next." This is a good metaphor for expansion of NLM's program services and influence if you have a broad view of what's adjacent and what's possible, as Don Lindberg clearly did. Well, now I am trying to advance them. Ah, there we go. So I want to talk about why Don Lindberg came to NLM. He came with a purpose. He looked at the opportunity of NLM's directorship and realized that NLM was in a position to really accelerate the application of advanced computing and communications to patient care and biomedical research. And he thought that he was a person who could really make this happen. He was attracted by the existing NLM foundation that he could build upon. The mission he loved and frequently quoted it. And he was aware, and because of his previous experience at NLM, which involved serving on the board of scientific counselors for the Lister Hill Center, and also serving on the BLRC, which we've heard discussed by previous speakers, the Grant Review Committee. He knew that NLM had a really multidisciplinary staff and multidisciplinary programs that covered the gamut, the services, the educational program, research, and grants. So this was a broad way, many different ways he could influence what he wanted to have happen here, which is the application of computers to healthcare and biomedicine. He was proud of the services that NLM already had. They were excellent, they were regularly updated, and for 1984, they were very frequently used. And he was very enthusiastic about the NLM network because of his experience as someone in institutions who were members of the network. He was very admiring of the capabilities of medical librarians. One can sort of understand why. One of the medical librarians that he was very familiar with was Estelle Broadman, who was director at WashU and a real pioneer in library automation. I first spent time with him when he came by giving him a tour. Somebody asked him if he would like to see the current state of automated systems that were used to build NLM's databases. And they were among the systems that we were in the midst when he arrived of redeveloping and trying to improve. And he responded, "Nothing would please me more." And I was given the role of giving him the tour. I immediately discovered some things that you all know too, if you knew Don, he was interested in everything. He was fascinated at looking at the online indexing system, of which he was very complimentary. And he asked questions that I realized later were questions to find out whether the users of the system had participated in designing it and whether it had been developed in an iterative way. Because as far as he was concerned, that was the only way to develop a good and useful system, iterative with the users and then make the improvements based on real use. One of his famous quotes is, "Systems that get used get better." So he was very interested in that, but he was also interested in the fact that the cataloger who was showing him the cataloging system was working part-time at home. This was in 1984, and NLM was doing an experiment. We were the NIH experiment about FlexiPlace, working at home some days and whatever. So he was fascinated by that, and he was perfectly delighted that NLM had been in the forefront of that, as we were actually in the forefront of a lot of things. So I learned a lot about him on that trip, on that tour, and he immediately asked me, as he asked everyone, when he was thinking about something and he met somebody new and he wanted some, he just would ask, well, what do you think about this idea? So he asked me, what did I think about the UMLS, his idea, which was very sort of inchoate at the time. But I said, well, we have a little minor project that sort of is in line with that. And he said, oh, what was that? And I said, well, we have a project to map the medical parts of the Library of Congress subject headings to the medical subject headings, which is the one we used at NLM. And he immediately said, this is music to my ears. It was not long after that that I was on the UMLS team. But he arrived with visionary ideas, but moving ahead on them was going to obviously require a substantial increase in NLM's budget. And the list of his initial priorities he brought really reflected this. You see them here along with cryptic notes on early progress, which went ahead pretty quickly, as you can see. The health community, the healthcare community, as far as he was concerned, the general public and the Congress needed to become more aware of NLM and its programs and services. The Board of Regents was all on this page already, so they really supported this. And in a very fortunate coincidence, NLM was to celebrate its 150th anniversary in 1986. Don saw this as ample justification for special events and expanded publicity, much more than NLM had been planning, I should say, before he arrived. And much of it was sponsored by the newly established Friends of NLM, which he was, enthusiastic about that new organization, which also I think was created in 1986. Now, to make an important difference and justify increased resources, the library needed a long-range plan with compelling goals. Well, you've heard a lot about it and you've seen it. The board was in complete agreement with this priority of Don's as well. And Don was absolutely clear that the plan should reflect the ideas of a very broad, multidisciplinary range of NLM current and potential users, partners, and stakeholders. As it happened, about 200 people participated in the 5 panels that contributed to the development of the long-range plan for 1986 to 2006. A number of them were from many different disciplines, were part of Don's existing personal network, to refer back to remarks in the last panel. Donald West King was one of these. Like Donald King, many participants became strong advocates and allies for NLM and for the plan and for NLM. as you have heard before, seeking and listening to ideas and opinions from a wide spectrum of sources and enlisting them as allies was a hallmark of Don's leadership. To quote him, "No one has a lock on good ideas. They come from everywhere." The great idea to establish NCBI at NLM arose in the planning panel on factual data, which included one future and two former Nobel Prize winners. One at least, Josh Lederberg, was a long-term colleague of Don. The overall 1986 plan raised some topics as requiring more focused plans. Don considered two of them to be especially important. The specially focused outreach panel chaired by Mike DeBakey, another previous colleague of Don's, advocated expanding the mission and funding of the library network to promote NLM services to health professionals not affiliated with institutions and that had medical libraries. In 1990, Don made outreach to expand the use of all NLM programs and services, an NLM-wide priority, and it was one that was highest priority for him till the day he left the National Library of Medicine. Also in 1990, a special planning panel on electronic imaging, chaired by Dr. King, I should say, endorsed the production of the visible human data sets and provided a blueprint for the project in 1990. Don believed in the importance of imagery in understanding biomedical concepts and data. To Don, the increasing availability of personal computers in offices and homes was a golden opportunity to expand NLM's direct users group to health professionals by providing an affordable way to search Medline to answer clinical questions. He was particularly concerned about physicians practicing outside of institutions with medical library services. Less obviously, the UMLS resources he envisioned would be the first NLM products designed expressly for system developers and informatics researchers. In 1984, the problem they were designed to address, namely the differences in terminologies and codes used in disparate electronic biomedical databases, was a problem that Don saw, but very few others did. And then in response to recent reductions in NLM's extramural budget, not unrelated to acrimonious interactions with publishers in the information industry, Don's initial priorities included the grant budget, increasing it, and improving relations with publishers and the information industry. There were many heroes in the fast start to Don's tenure at NLM, including great advisors, strong advocates, et cetera, supporters in the Congress, and terrific NLM staff, both existing and newly recruited. But Don's visionary ideas, ability to inspire and action, and uncanny judgment were essential. Throughout his career, Don made inspired decisions about what to do and when to do it. A shining example was his decision to aggressively pursue the establishment of NCBI as the highest priority coming out of the 1986 long-range plan. I should add that Don also made great decisions about what not to do. In that category, his first and best was refusing Ken Smith's offer to step aside as NLM deputy director. The establishment of NCBI at NLM in 1988 with the functions shown here, an initial budget of $8 million, had a tremendous positive impact on biomedical science and on the scope and effective integration of NLM services, as you have heard from many speakers. It made sense, as stated by the planning panel, because, quote, at the time, the problems of scientific research in molecular biology are increasingly problems of information science. I think they still are. However, the establishment at NLM was by no means inevitable. I'm sure that the advocacy of Josh Lederberg, Alan Maxim, another Nobel Prize winner, Richard Roberts, who would become one, was extremely helpful in overcoming the skepticism in the scientific community that a library was a reasonable home for this responsibility. And of course, in addition to bringing the scientific community on board, Congress had to understand the need for it. You could see Don immediately recruited Dan Macy's, who was an NCI branch chief who had served on the panel that made the recommendation, as director of the Lister Hill Center to help NLM's scientific visibility and credibility in biotechnology information. And he was ably assisted by Dennis Benson, who was already working in Lister Hill at that time. Parallel effort, which involved another NLM employee, Frances Humphrey Howard, Hubert Humphrey's sister, succeeded in educating Claude Pepper on the importance of creating the center in the short window before the expected 1,000 fold increase in molecular biology data began. By the time Congress acted to establish NCBI in November 1988, NLM had a higher profile, an initial set of microbiology research tools, and was adding sequence data tags to Medline citations, the latter being Don's idea and instruction to the indexing operation. Don quickly hired David Lippman to lead the new center once the law was passed. And Jim Estelle actually arrived at NLM shortly before David. And of course, as I've said, Dennis was already in place. NCBI was up and running in 1989, early in 1989, and designated to assume full responsibility for GenBank in 1982. In the 1990s, and Sally gave us insights to this, and you heard from other people as well, NLM embraced the internet and the web browser and reinvented all of its services. This was not an easy thing to do. It was inevitable. As soon as the web browser appeared, every other interface was obsolete, and issues and problems that you had been struggling with in the past, like nothing was really platform independent, and designing products to be loaded on machines as we were with Grateful Med, and having to have a Mac version and a PC version. So, the web browser was nirvana for service developers. But we had a lot of services, so they all had to migrate, and we had to deal with something that is not common today. We had to make sure that all our existing users could had an internet connection, and B, had a web capable workstation. Now, of course, we're used to the fact that the users having new devices means that the system developers have to develop new services, not that you have to ensure that people have the right equipment to use your service. This change obviously enabled the things that have made a huge impact on the world. It enabled us to, first off, and one of the earliest things was to really make our historical resources beautiful, gorgeous, special collections, pictures, movies, etc., accessible to remote users in ways they never were before. And this was something that was actually a big high priority for Don. As I said, he loved the historical collections. The biggest thing I don't have to go over was, except to tell you that it was important to orchestrate the announcement of the free Medline in such a way that there would not be any blowback from others in the information industry about unfair competition for the private sector and this, that, and the other thing. So consequently, as Don said, I figured I was pretty bulletproof. I was up there on the stage with Harold Varmus, with the vice president and with Senators Harkin and Specter. So he figured that he was not going to get any blowback, and he really didn't, although this was a seismic and upset in the access to information. And of course, once we saw how the public was searching Medline, the issue of, but is Medline really going to be helpful to them for many of their issues, which is gaining an understanding of basic concepts and getting something that is not written on a specialist view. People in library operations, my predecessor there, Lois Ann Coliani, saw this one coming. So a group was already put together to develop a prototype of what became Medline Plus. As soon as we saw that, as Don saw the level of public use of Medline, this seemed like the next step, and he was delighted because he would have always liked to have served the public, but before the internet and the web browser, he didn't have a way of delivering services that would be useful to people. This is a very high level explanation, which you already know, and I'm not going to run through this, about the fact that by 2015, life was totally different. And the time he retired, everything had expanded. You've heard about it before. You didn't hear so much, but the active outreach program that NLM had was enormous. The network of libraries had doubled in size because it now included public libraries, community information centers, and other partners, as well as health sciences libraries, to help people understand what was available to them from NLM and to actually become aware of it. People don't use things if they don't know about them. Many people say, oh, you just discovered on the web, maybe a little harder now with so much stuff on the web, not as hard then, but a lot of people didn't at that time, didn't necessarily know why they should be on the web or why they should be looking for it and where they should go for health information. So the outreach was really important. And of course, Medline began the avalanche in terms of free data available. And there were many more channels of access to data, application program interfaces, download sites, integration of data across systems. This was all made possible by these technological advances that you all know about as well as I do. And NLM also worked on organizational arrangements and public policy and trained more people that could contribute to all of this, as we've heard from some of them already today. It was the interaction of all of these things, working on all of them, they actually cemented and expanded NLM's influence. So in this next set of slides I'm showing you are old slides. This is what life looked like in 2015. And you can see that a tremendous amount had happened and much more has happened since and will still go on. It's very interesting if you look at this little place where it says PubMed citations back to 1940s to the present. Back to 1940s was also Don Lindberg. He initiated the project to go back from the 60s, which is really where our automated data had started in, and convert the indexing, pre-60s indexing. And of course, the vast connections were the payoff from the addition of data to NLM services. What we just saw in terms of access to the literature was huge and valuable and maybe our greatest contribution or his. But on the other hand, if you look back to 1984, it's in a straight line from there. It really is. It's just doing it better with the technology that's available. The creation of NCBI was a total different thing for NLM, and it had huge benefits, including the tight integration and access mechanisms for all of these kinds of data. We could wonder whether this would have happened if NCBI had been created somewhere else. It probably wouldn't have had it happen as quickly or as smoothly. Maybe it wouldn't have happened at all. I don't know, but it's a huge legacy of that one decision. Now, it's interesting to look at clinicaltrials.gov because the origin of clinicaltrials.gov was not a decision by Don Lindberg. It followed the following sequence of events. In 1988, NLM asked the staff what we could do to serve AIDS researchers and patients better. They said the top one would be to create AIDS-Line, a focused bibliographic database of AIDS information. We did that. At the end of 1988, in the same legislation that created NCBI, there was a requirement to build new AIDS resources for the community, AIDS drugs and AIDS trials. So NIH, everybody looked at that requirement, which was HHS was all involved in everything too. And they said, well, NLM's done AIDS-Line and they have all these other databases. So they should build the AIDS trials database. So we did that. So fast forward in 1997, the Congress says build clinicaltrials.gov. And Harold Varmus, who has this assignment, looks around, some progress is being made, people are talking about it, but nothing is happening. And in 1998, he sends Don Lindberg an email. And he said, Don, I want NLM to take this over to do this. And you have the experience, you've done well with AIDS trials, so you take this on. And please get back to me immediately and tell me who on your staff is going to be in charge of this. And Don shortly responded, Alexa McCrae. So then you end up with the situation of NLM has clinicaltrials.gov. And as you see here, we go down there and 10 years later, there's now a new requirement. I think what's interesting here and what our returned person from the other galaxy would also find remarkable was the extent to which NLM databases and services were tied into requirements for the research community, where in fact people had to use NLM services because of what had been laid down by legislation, public policy, and what have you. This was a major change. And then you get to NLM's vocabulary portfolio. I could give you a very long list of things that were required as a result of this, how this happened. Don was essential to this ending up being an NLM priority. And not only was it essential for him to get this started in the direction for us to move ahead on this, it was actually essential that he stayed as long as he did, because this was also quite a distant adjacent possible when we started, and it required steady support and interest in this direction for this to happen. I think that it is the data, the NCBI's genomic data, the clinical trials data, and NLM's foot in the standardization of electronic health data. It is those things which are different in kind from what was going on at the National Library of Medicine in 1984. And NLM, certainly Don Lindberg, had a lot to do with all of those directions. But in fact, he would have been delighted. NLM, there is a connection between NLM Services Direct, used all the time, between Medline Plus and EHRs, and it is enabled by all of that work and standards. But in the end, what Don was really interested in was helping people. And he focused a lot of his own personal time on trying to make services and information more accessible, more usable, and more useful to the whole community, and trying to get more people in that community into the business of working on information systems and information delivery. So I think that that is really a great part of his legacy. Thank you.
Betsy, thank you very much. We've received a number of comments during the course of your presentation, and one of them rings especially true, and I'd like to just share it. And it's a quotation that's been attributed widely to a variety of people over the past several decades, but it applies here, and I want to share it, and then a follow-on thought. The comment is Dr. Lindberg, in his leadership of the National Library of Medicine, embraced the idea that the only way to predict the future is to invent it. And I'd like to, with respect of your comments and those of our earlier presenters, say we can extend that, saying the only way to predict the future is to invent it, which is what he did, and to plan for it with a distinctive appreciation of the past, combined with embracing experiences and challenges and opportunities, and to your very point at the end of your presentation, being supportive of people all along the way, colleagues, peers, students, all who can contribute to the public service mission. So thank you for allowing me to reflect in that way, and thank you very much for your presentation. It's good to see you.
See you too.
Likewise. So for our closing remarks this afternoon on this great day with so many great presentations, we have a distinct honor before us. It is my pleasure to introduce Christopher Lindberg. Christopher Lindberg is the grandson of Dr. Lindberg. He is currently a senior at Portland State University in Portland, Oregon, so he's joining us obviously from the West Coast. His interests in photography and the outdoors echo those of his grandfather. In fact, as I understand it from Mrs. Lindberg, when Dr. Lindberg loaned Christopher his camera during a visit to Plymouth, Massachusetts, when Christopher was about 2.5 years old, Dr. and Mrs. Lindberg were astounded at his excellent eye, and they could see that Christopher had immediately taken to photography. Indeed, he has grown to become what I understand to be an avid photographer. So it's therefore very apropos for Christopher to close our proceedings today to help us see even further how his grandfather exercised his own eye to lead the world's largest biomedical library, and in so doing, as we know, leave a remarkable legacy of service to science and society. So Christopher, a warm welcome to you from all of us at the National Library of Medicine, the NIH, and thank you for joining us today. I'm going to turn it over to you. Thank you.
Thank you, Jeff, for those kind introductory words. It's so great to see so many of you. Betsy, Kent Smith, Clem McDonald. Jeff, I'd like to take this opportunity to thank you personally for all your hard and tireless work the last few years putting this together and making sure that we were able to finally get it done. And I'd also like to extend that to the media team today for making sure everything has gone so smoothly. Yeah, so as this is no small feat, I would have loved to have seen all of you in person back at the library, of course, but health risks demand otherwise, so we convene remotely. Despite my initial disappointment at not being able to see you all, I realized that, again, like all of you, I agree 100% that my grandfather would have loved the fact that this was still happening remotely and had an avenue to, you know, connect globally and make sure that this was, you know, a nice pathway for information to be exchanged and for all of us to get together again after being apart for so long. That was one of his main goals in his career, was to make public communication and make certain information available to the public, as is perfectly exemplified by his efforts with Medline and Medline Plus, Pub, all those things. He was someone who truly wanted to help people, I feel, and to further the betterment of mankind genuinely. And there aren't many people like that throughout history who do as good a job as he did, and are as in close proximity to us as they do them. He saw into the future of medicine and knew that the storage and transfer and application of information was going to change, and knew that computers were part of the answer. In a chapter of the recent book that Betsy and Robert Logan have put together and put so much work into, there's an excerpt that he says journals on the shelf will become too remote for immediate decisions. And I think he was spot on and saw that coming a mile away, and that he assumed that computers would soon be potentially essential. And I think by our remote convening today, he was onto something. He loved his time at the library, as I did as well, the short time that I was there. And it was truly the passion that fulfilled his life. I was privileged to see this process firsthand from behind the scenes, as my time spent with him at the house was matched in my early years to the time spent in the office. He was the same person in and out of the office. We all knew the same person, always cool, calm, collected from door to door. He loved every minute there. And I truly don't believe he ever had a bad day in office or at his time at the library. As I watched parts of the library grow and change, the library seemed to watch right back as I grew up and got to know everybody, and they got to know me and see me grow up and go through my processes. And I was for a while an annual fixture in the mezzanine every summer, which in itself was a great pleasure. And I look back as some of the greatest times that I will ever get to experience. These are, of course, among core memories of my childhood, as are the people who were at the library at the time. Previously mentioned Betsy, Clem, so many more that I would love to mention and personally thank and extend gratitude for all of the time and kind energy that they have given me over the years. I believe that I saw the library in its golden years, both because of my grandfather's influence and, as previously mentioned, the people who worked with him at the time, who he had handpicked and trusted and personally believed in. And these are the part of what made the team so special. These people are part of what made the process and his time there so special. The group of doers and accomplishers that followed and supported him, and that he supported and followed right back. Again, people like Betsy Humphrey and Robert Logan are incredibly special to the Lindbergh family, and will forever be held in the highest regards in our hearts, and have put in so much fantastic work into the book the last few years, and making sure that we all could properly remember him and remember ourselves with him. And the organization of events and exhibits throughout the years made the library a place that was enjoyed as well as respected. And I think that was, again, one of his driving goals for the library. Not just to be an intellectual powerhouse, but to be a place that was inviting to everyone and made people want to learn and want to come and explore and investigate. And things like the murder rooms and the costume parties, and when David Nash had the Frankenstein mask on, these were all things that were just so fantastic and so great that wouldn't have happened otherwise, I feel like. And this was how he conducted himself. Combination of, well-rounded comedy, as has been previously stated, and constant commanding respect, not of people, but of the situation and how he handled things. These also seem to be recurring themes in our adventures. For example, 4th of July one year at the government printing office, followed by several hours of lost driving in the city, or boat trips up the Potomac for the weekend, you know, complete with towing up rock. One time we towed up a rock that was so big it took 4 people and 3 different watercraft to unwedge it from the anchor. And, you know, seemingly random elements of hilarity that seemed only too perfect for the scenario, you know, too perfect. So even in absurd situations, just always had command of the situation. And I saw how far this reach was and how far his respect followed him on numerous trips that we took together. One such trip to Alaska for the Native Voices was, I think, one of our favorite trips we ever took. And I had never been there before, and my grandfather was finishing up the work on that exhibit, Native Voices, whose traveling adaptation would reach over 20 venues across the country in the following years. Here we were met by Ted Mala, who facilitated our numerous bookings and appointments, and is another of many people that I was able to meet and be around and learn from, and have been lucky to call my friend ever since. The hospitality and accommodation was second to none. And I had experiences, like I said, that I may never have again that were so rich. And these range from salmon fishing in the rain to long nights up talking, you know, over several rounds of drinks with whoever was there. And they were the kinds of conversations that had no destination or direction. And I think sometimes these are the richest forms of conversation. And it was rare that you would have a conversation with my grandfather and not have learned something that you didn't know before. And my relationship with him was similar in nature. And I always had a tremendous respect for him, which came from the usual familial structure, but also in his inherent way of commanding the room. There was never a lack of conversation, and rare was the occasion, like I say, where you would walk away not having learned something. He had piles of books cresting the armrests on both sides of 2 separate armchairs in 2 different rooms of the house. And he had just had an ever-growing intellect and thirst for knowledge. And this gave him the ability to entertain a conversation with anyone about anything in a way that made them feel included without looming an intellect or making you feel less than or uninformed. I never felt condescended to or spoken down to, which, as I grew older, I came to realize was a true testament to his character and himself as a person and all people. Consistency and understanding were cornerstones of our relationship. Some of his hobbies became mine, and my endeavors were always a priority and were treated as such, and vice versa. We both shared a love for cinema and film that stemmed from photography and grew into something we just loved doing together. One Christmas, I remember we were all staying up for the New Year's for the ball drop, and we were channel surfing, waiting to pass the time. And until this time, my grandfather had never wasted time with television. He saw it as just that, a waste of time for the most part. And that night, though, we stumbled upon Turner Classic Movies. And this was a soft spot my grandfather didn't know he had. And he was instantly hooked. And if you're not familiar, it's just older movies from anywhere from like the 50s, 60s, 70s, 80s, you know, spaghetti westerns and things like that, and James Cagney movies. And he loved it right from the jump. So we watched the first film that we found was the 1966 adaptation of Fahrenheit 451, followed by a couple of Cary Grant movies. And we became so infatuated with the films that we missed the ball drop, the whole event, and watched until about 4 a.m, which was shocking. It was absolutely unheard of. After the end of each film, I would go to turn off the TV, and before I could reach it, he would say, "Well, hold on, see what else there is." And we would slide right into the next movie, and then we would get right through that one, and it just went on and on and on. And that was his first introduction to television. And you know, after that, he loved the westerns, the John Waynes, and all those great things whenever he had the chance. But it was never a form of entertainment that he seeked out or would seek out. That being said, this would become one of our favorite things to do together. Our love of photography helped me grow a passion and practice that has become a business. As you can see, I'm in a partially finished studio for green screens and media production. And I've been running a multimedia production business for about the past year and hope to scale it into a successful brand after the practices of my grandfather and his photography. In addition to myself, Rob Logan and I have joined forces in attempts to digitize and preserve that vast collection of photography, which includes prints and digital copies and amassed images from my grandfather's extensive travels. These will ideally be the next installments in the Lindbergh legacy and will hopefully be available on the internet, as these recordings will be in the next year or two. He shared these experiences with my father before me, and I hope to share it with my family in the future. Looking back, the things that stand out as core memories are seemingly simple in nature, but the older I get, I see them differently and with a more refined understanding. For example, the fact that my grandfather taught me how to swim in the backyard pool of the house in Maryland, which I'm sure many of you are familiar. As a child, these are some of the best days in your life. Sunshine, pool toys, visiting the grandparents for the summer. It's all sublime. This is how I'd remember this memory for years, but now with the prospect of planning family for myself, I have a whole new level of respect for my grandfather and what he was able to accomplish. In that moment, what was a simple afternoon of poolside fun to a child was the result of years of hard work, accomplishment, and commitment, and the satisfaction of teaching your grandchild to swim in your own pool alongside your beautiful house is a whole worldly accomplishment in itself. Accomplishment was simply second nature to my grandfather. His effortless control is something I look up to this day and try to instill in myself. He managed to master so many facets of his life and in so many areas that it seems daunting by comparison. But he wouldn't see them as such and would simply advise you to do your best and to do what's right, as oftentimes they are one and the same. Some parts of me found it somewhat difficult to organize this collection of words, mostly because it stems from wanting to accurately and appropriately represent him and remember him, as everyone here has done today in so many beautiful words. But it's really the finality of this event. And although this is the final ceremony, I remind myself that it is far from the last memory of the legacy best left behind. The National Library of Medicine is forever changed and influenced for the better, as is the world. I extended tremendous thanks to my grandfather for being the driving force for our family and our surroundings. And with that, I offer my closing statements, and I thank you guys all once again for being here, for organizing such amazing tributes, and I hope to see as many of you soon as I can. Thank you very much.
Christopher, thank you very, very much. Your reputation, as I understand it from your grandmother as a photographer, is incredibly wonderfully obvious. Your keen eye and keen ability with words is fantastic. And I share your thoughts respectfully, and I appreciate them both professionally, having known Dr. Lindbergh myself for 7 to 8 years, maybe a decade, but also personally, if I may so publicly say, the beautiful way in which you articulated your memories of your grandfather is unique to you, unique to your memories, but it's universal at the same time. And I thank you both professionally and personally for what are wonderful, wonderful remarks, and very respectfully, of course. And with your remarks, I want to thank you very, very much for your time and our communication for today. And I look forward to our own paths crossing again soon, and know that we're here to support you. And we wish you all the best in your studies, and certainly in your business and on your own path in life, influenced so wonderfully by your grandfather and his leadership of the National Library of Medicine and science and society and all that we've learned today from these wonderful proceedings. So thank you very much. Best to you.
Completely likewise, Jeff. Thank you so much. Thank you.
Welcome. So with your remarks, Christopher, and all of the wonderful contributions today, we're going to conclude this special and outstanding program that we've had the experience of watching and being a part of today. On behalf of the entire National Library of Medicine, which I've had the great privilege of representing today, thanks to everyone for their contributions, and especially, of course, to our keynote presenter, Dr. Isaac Kahane, for his enlightening and thought-provoking presentation. Thanks again to the Friends of the National Library of Medicine, the FNLM, for their co-sponsorship of this event and for being such wonderful friends of the NLM, the world's largest biomedical library located on the campus of the NIH. I'd also like to thank, along with all of you who are watching and all who contributed today, our outstanding NLM communications and media teams for their time and their outstanding talent and our mutual support for such a long time to realize this wonderful event. Each and every one of you is fantastic. It's been a pleasure working with you. And this program is a testimony to Dr. Lindberg's leadership and scientific legacy, and it's also a testimony to our teamwork and representation of the world's largest biomedical library to the global public. And of course, thanks to all of you for tuning in near and far, for watching our program today. The archive proceedings will be available soon, as I and others have mentioned. They will be available permanently and freely to anyone in the world with internet access, and they will be in the NIH Videocast archive. And for everyone who registered for the program, you'll receive word when those proceedings are freely and permanently available. Thanks once more. My NLM colleagues and I appreciate you tuning in, and we look forward to keeping in touch. Thank you.